Hello, everyone. First question, do you see me? Do you hear me?
Good morning.
Yes.
Yes to both.
Good morning. Hi,
Good
thank
morning.
you.
Yes.
Yes, I think we can start now. So once again, good morning, everyone. Welcome to the second day of the Natural Baltic Science Conference. My name is Krzysztof Polaczek, and I have this pleasure to start this day. First, I would like to say the idea behind our conference is to be international, online, and completely free. And we want to create a place when young scientists can share your research with each other. And in this year, the organizers of Natural Science Baltic Conference, it's Student Science Club for Chemistry of University of Gdańsk, Doctoral Student Council of University of Gdańsk, Chemistry Student Council of University of Gdańsk, and Center of Student and Doctoral Activities of University of Gdańsk. Our event is also held under the patronage of Fahrenheit University, the Rector of University of Gdańsk, the Dean of Chemistry Department of University of Gdańsk, the Marshal of Pomeranian Voivode, the Pomeranian Voivode, the Polish Academy of Science in Gdańsk, the Student Parliament of the Republic of Poland, the Polish Chamber of Chemical Industry, the Association Iskry Nauki, the website eDoctorant, and the website dlastudenta.pl. I would like to also welcome our scientific committee, which includes 24 members from 11 different science centers, which is Professor Anna Axman from University of Gdańsk, Professor Henry Pinto from Jadza Tech University, Professor Agnieszka Chylewska from University of Gdańsk, Professor Marta Kolanowska from University of Łódź, Professor Katarzyna Wierzchowska from Warsaw University of Life Science, Professor Ilya Serdiuk from University of Gdańsk, Professor Iwona Jędrzejczak from Bydgoszcz University of Science and Technology, Professor Dawid Zych from University of Opole, Dr. Katarzyna Węgrzyn from University of Gdańsk, Dr. Judith Mary Harip-Krasz from University of Copenhagen, Dr. João Manuel Ferreira Gomes from University of Coimbra, Dr. Agata Kućko from Warsaw University of Life Science, Dr. Paweł Mazierski from University of Gdańsk, Dr. Monika Majewska from University of Gdańsk, Dr. Małgorzata Gutkowska-Stronkowska from Warsaw University of Life Science, Dr. Małgorzata Kapusta from University of Gdańsk, Dr. Dawid Wnuk from Jagiellonian University, Dr. Magdalena Miodyńska-Melzer from University of Gdańsk, Dr. Maria Madej from Jagiellonian University, Dr. Bartosz Szymczak from Nicolas Copernicus University in Toruń, Dr. Maria Kochaniec from Warsaw University of Technology, Dr. Daria Harskowa from University of Gdańsk, Dr. Artur Piruk from University of Gdańsk, and Dr. Monika Rewers from Bydgoszcz University of Science and Technology. I would like to also welcome our special guest. Yesterday we held the lecture of Paweł Mazierski from University of Gdańsk, and today we will listen the inaugural lecture of Dr. Agnes Klar from University of Zurich, and it is about a next generation dermoepidermal skin graft, vascularized, pigmented, and fat and scented. During the registration, we had a very high number of speakers, which is from 39 scientific centers in 13 countries, which is making total 57 oral communication, 58 poster communication, and 78 audience participants. Today, just like yesterday, we have two session. In this session, we can listen to the special guest lecture and oral communication session 5A, 6A, and 7A. But on the parallel parallel meeting, we could hear the 6B and 7B oral communication session. To join to the second session, you have to go on our conference homepage and join using the appropriate button. And this is a schedule of today. We start at 8 of UK time, and the closing of the conference will be at 3 p.m. I just also want to share that during the conference may have some technical problem, so the order of the presentation in session may change. So I want to please all the speakers to be on their session. However, the duration of the presentation session will not be changed. And the oral communication session, every communicate has 12 minutes and 3 minutes of discussion. So I want to please you to stick to the time, and speakers whose presentation will be shared by video also are requested to be on this session to answer the question from the audience. Today we have the poster communication session. It's will be on 1:45 and it takes time to 3 a.m. of UK time. And the posters are divided to room 1 from 1 to 6. To join the poster session, you have to go to our homepage, click the relevant button, and enter the password, which is NSBC 2025. The video recording of the posters and also the abstract will be on the website. And in case of any problem, you can contact us via WhatsApp or send email to Mateusz Baurk or Daria Łada. Thank you. This is all so I want to say, and now I want to invite Dr. Agnes Klar. Dr. Klar, are you with us?
Sorry, no, my micro was switched off. Can you hear me?
Oh. Yes,
okay?
yes, yes, okay. We hear you and we see you. Can we start now?
Yes, I will.
Yes, thank you.
Try to share my screen. Can you see my presentation actually? Or?
Yes, we see your presentation, but actually your screen. So
yes,
we don't see the presentation in full form. Oh yes, now it's
now okay.
Yes, yes.
So thank you very much.
Okay, yeah. Thank you. You can start. The floor is yours.
Yes, I think it's working. So thank you very much for this nice introduction. And actually, recently I've been visiting University of Gdańsk, and I was asked by Kamil Klimkowski to give a short presentation in this conference. So, as you saw maybe in the abstract book, I thought I will just give you a broad overview of our research in the lab. So about skin grafts and about different aspects of artificial skin grafts. So
Excuse me, Dr. Klar, I'm sorry, but we didn't hear you. I think you turned off your microphone.
Sorry, now, yeah, I changed here the slide. Okay, now it should be fine. So our institute, it's called Tissue Biology Research Unit. And we are actually, it belongs to the University Children's Hospital Zurich. So, and also at the same time, it belongs also to the medical faculty of the University of Zurich. So we are like, we have this double affiliation, and our lab, sorry, I have problem with switching the slides somehow. So our lab is actually, our institute is located at the campus Schleden. So it's one of the campuses of the University of Zurich. It has many over the city. So today, to just give you a brief overview, I will talk only about skin bioengineering. So this is our like main topic in the lab. So I will give you a brief overview about human dermoepidermal skin substitutes. So how we bioengineered those grafts, about preclinical and clinical evaluation of those grafts. And I will also briefly also introduce the vascularization approach. And also we'll talk about skin pigmentation and about adding also fat tissue, so the hypodermis layer to those skin substitutes. So this is actually the motivation for our research. You can imagine that children, mostly very small children in the age of like infants until the age of 5 years old, that's the most like the frequent victims of burns. So that's according to the statistics in Europe, that's the victims of, yeah, which are affected really by burns severely. So sometimes it's up to 60–80%. They can be really very severely burned. And you can imagine that those children will need pretty large skin transplantation to cover the wound. Of course, we have also different like congenital disease, so different skin defects which also need to be treated. Like here, this melanocytic nevus, this is kind of disease where you need to actually excise the skin, and you need to also transplant artificial skin to because otherwise the skin can develop melanoma. So there are also different skin defects. You can imagine like car accidents and whatever accidents we get, we need also skin transplantation. So as you may know, the human skin contains 3 main layers. So the one, like the outermost layer of the skin, which we all can normally see, is just the epidermis with hairs and of course sweat glands, because we are all sweating. So the underlying dermis, so that's the next layer, normally we don't see it. But of course, when the skin is wounded and it opens, then we also see, of course, that it's also bleeding. So all this blood is coming actually from the dermis. And we have the third layer, which is the subcutis, or the hypodermis, which is just the underlying fat layer. And so nowadays, the current gold standard, how the clinicians actually are treating those skin wounds, are the so-called split thickness skin. So the surgeon has a device called dermatome, and with this device, the surgeon is harvesting like the healthy skin of the patient. So they're looking for like a spot on the skin which is healthy, and where they can harvest some autograft, so some skin of the patients. But they are not taking like the full thickness skin, as you can see here, but with this device, they just go for epidermis, so this upper layer of the skin, and they're taking just a bit, so just some parts of the dermis, and that's why it's called just split thickness skin. But you can imagine that, of course, this procedure has different disadvantages, because with this, we are creating kind of scar on the spot where the skin is harvested. And of course, this is very thin layer, so you can imagine that in cases in patients who have a very deep wound, like a 3rd-degree burn, they will need another also dermal template, not just the split thickness skin, because it's very thin, so it will not really fill this gap in the skin. And that's why, of course, also if you imagine that we have patients with very large surface, so burnt surface of the body, this is also not easy really to harvest enough to cover the wound. So as we were collaborating and still collaborating with the surgeons, so with this burn center at the hospital for children, they actually told us that they were not really convinced by this procedure, and that actually we should look for another kind of skin substitutes, or develop something which will cover this large wounds. And we came up with this idea a long time ago, like over 20 years. Yeah, over 20 years ago, actually, to develop such a autologous, so taking cells from the patient and creating artificial skin, but skin which contains like both the dermoepidermal layers, so like both layers of the skin, and to do it, of course, in a size that is matching the patient, so that we can really cover this large wounds. And so this is like the kind of first prototype we develop several years ago, actually. And this is around 7 by 7 centimeter in size, but of course we are not limited by size, so we can produce even larger or many of those pieces, which can be then transplanted to the patient. But so to understand like the procedure, so how do we isolate those cells and how we produce such a graft for patients? So for this, we just get a small biopsy, in this case, a very small full thickness skin biopsy from the patient. So it's around 1 by 1 centimeter, so it's really small. We then digest the skin. As every tissue, you need to, of course, digest to isolate the cells. So we isolate keratinocytes from the epidermis and then fibroblasts from the dermis. And those cells are then, of course, expanded. So we need to passage them in vitro because we don't have enough right away to construct the whole skin patch. So we expand them, and then we co-culture them in a 3D hydrogel. So first fibroblasts in a collagen type 1 hydrogel, and after 1 week we then seed keratinocytes on top, and then in total after 3 weeks, actually those dermoepidermal skin substitutes are ready and can be transplanted on the same patient. Of course, before we started phase 1, even we need to provide a lot of information to the authorities and a lot of preclinical data. So we established in our lab this kind of immune deficient model. This is a nude rat model. It's nude, so it's immunocompromised. It doesn't have any T and B cells. So in this case, you can transplant human cells, and those cells will not be rejected. So it's for us, it's very good model actually to even for long-term analysis of those skin substitutes. And here you can see an example from the rat. So how we transplant those skin grafts. So on the left side, that's just a macroscopic view. So this is a ring. It's like a silicone ring which we put on the back of the rat. The size is about 2.5 in diameter, 2.5 centimeters. So it's around the diameter of the 6-well inset, 6-well plate kind of. And so here this white patch is the skin, and the ring just protects from the protects the graft, that the rat skin is not overgrowing the whole transplant. And this is hematoxylin eosin staining, so it's just very simple histology showing that we have indeed the epidermal layer, so the human epidermis is on top, and then we have the dermis underneath. So it kind of mimics those two layers indeed, what we also have in our skin. We then also performed some immunofluorescence staining. So you can see here human E-Caterin, it's staining epithelial cells, so the junctions between the cells. So that indeed it's those keratinocytes are connected, and there is the human dermis stained by human CD90. CD90, as you may know, it stains human like mesenchymal cells, stromal cells. So here in this case, fibroblasts. And we also confirmed that those keratinocytes were differentiated, so cytokeratin 1, and in general, cytokeratin are maturation markers for the epidermal stem cells. So in general, for epidermal cells, so like keratinocytes, suprabasal keratinocytes, you can see that indeed they were differentiated and they were organized in different layers, like in normal human skin. We also, after longer time, so we waited, and now here it's also after 3 weeks in vivo, we saw that already human vessels, so here in red you can see human vessels stained by CD31, they were already growing into the dermis. So it was vascularized, so to say, by the host, the transplant, and also we observed, but after longer time, so after 8 weeks in vivo, we observed that nerves were also ingrowing into the dermis. And so until now, like in the research at the beginning, we only work with this 6-well format, so to say, because this was, of course, the cheapest option and the easiest option to optimize the protocol. But of course, as I mentioned, for patients and in general for transplantation, you need larger pieces. So this was the first prototype, was 7x7. And the requirement was also really to test those big patches on a large animal, like preclinical animal model. And here the pig was actually the most, pig skin is actually the most similar, has the most similar features to our skin. And that's why it's actually a good model also for human skin transplantation. So we then transplanted, but in this case, this were autologous skin, pig skin graft, so to say, with containing pig cells on this animal. So it was really possible to transplant those big patches, which was not possible on the rat, of course. And then the next step, looking for clinical application, of course, was to use GMP facilities, so good manufacturing practice. So this is actually requirements for all kind of products which you bring on the patients, into patients. You need to use this special facility to really ensure that the quality and the sterility of these products is really at the highest grade. So we were using such a, at that time, we were lucky that such a facility was really built at the University of Zurich, and we were able to use it. And we actually produced the first 10 patches of the stem epidermal graft, so the Novoskin, in the GMP facility, and we then started phase 1 back then. And this is just to, I hope it's not too much blood for you. It's just a clinical pictures which was published, so from the phase 1 study. So you can see here in the middle, it's just this big flask with this big kind of transplant, and this was then put here on the patient together with autologous split thickness skin. So split thickness skin, you remember I told you at the beginning, it's a gold standard. So we were kind of obliged to transplant like something which is like a gold standard together with our transplantation, like with our skin. So this is, here you can see this is this is 3 months after transplantation. You can see here on the left side our skin graft and then split thickness skin, and then 1 year after transplantation. So this was like the first follow-up in this publication, and this is here already like looking much better, and it really it changes with time. I mean, it's not so reddish anymore. It takes more and more the features of the patient's skin. And here, just to give you a very short overview, this is like the first follow-up now after 5 years, because we have already those patients now for 5 years, so we can also have a look. And you can see here on the left side is always day 0, so it's like the day of the transplantation. And then after 5 years, actually, I am not a clinician, but as you can assume from the pictures, it's actually very similar, and I cannot see the borders really where the skin was transplanted. So, so that was just a general overview about our pathway, like from the really bench to the bedside, with this skin grafts, which are now in phase. So they just recently started phase 3 clinical trial. So we believe that sooner or later those grafts will be available, not only for children, of course, but also for other skin defects in adults. But the focus is first on children and burns. But I would like to also give you an overview now on different research aspects in skin physiology. So this was like a first generation, let's say, of skin grafts reproduced, but we are very interested now also in vascularization, because this is very important for wound healing. And especially also, for example, in chronic wounds, the vascularization is really impaired, and that's why the wound healing is kind of stuck in the inflammation phase. So here it's just a simple picture. You can imagine if you have like full thickness skin from the patient, something which is vascularized, then those vessels will connect very rapidly to the vessels in the wound bed. But of course, in a normal artificial skin, we don't have such vessels, right? So the idea was here for pre-vascularization, so to form kind of network of vessels already in this artificial skin, which then, when it will be transplanted on the animal, then of course it can connect to those wounds, to those vessels in the wound bed, and there will be very rapid and efficient perfusion. So that is the idea actually of pre-vascularization. And in this case, we applied exactly the same protocol as I already presented before. So we also isolated fibroblasts and keratinocytes from a skin biopsy. But in this case, we also isolated human dermal microvascular endothelial cells, so the so-called HDMACs. Those are just cells which can be isolated from the capillaries of the skin. And those HDMACs, when you co-culture them with fibroblasts, they will develop in vitro in such a network. So they will develop really a vascular network. And then with keratinocytes, you can get actually a dermoepidermal skin substitute, which is vascularized. And of course, this we also can test on our immunodeficient rats. This is just how those vessels grow in vitro. So we were really following those different steps of co-culturing those HDMACs and fibroblasts in collagen or fibrin hydrogels. And you can see that this really, it goes step by step. So you can see that those endothelial cells, they form this kind of capillaries, very simple capillaries. But after 3 weeks, so we see that after 3 weeks, this kind of, it's like the best time, optimal time to really achieve kind of complex network of vessels. And here on the right hand side, you can see such a vessel, and also with lumen. So you see the cell nuclei on the sides, and in the middle, it's like a lumen. So it's really like a real tube. It's not just a cord-like structure. And it's also covered by pericytes, so it's kind of pretty mature, even in vitro already, those vessels. And this is like a network, vascular network, which can be achieved in vitro. So when you co-culture those cells in 3D, they really can establish very complex and ramified networks of vessels. For us, of course, the most important question was to confirm the functionality of those vessels when we transplant such a vascularized skin in vivo. And here you can see already 4 days after transplantation, we confirmed that those human preformed capillaries here in green, they connected to this red CD31 here in red vessels, because it's yellow. So all the parts which are yellow, it's like overlay of both colors. So it's connected in vivo. And the most crucial part was to see that you can see red erythrocytes in the lumina of those human red vessels here. So meaning that actually there was indeed this inosculation, so this kind of connection, and this transplanted vessels were indeed perfuse. Here it's a picture. You can see on the left side are those controls which are non-prevascularized. And here prevascularized on the right side. You can see even in hematoxylin or zinc staining that indeed there were already red erythrocytes in this dermis of this transplanted skin. And here at the bottom you can see the prevascularized gels after 7 days. You can see that there was indeed a lot of vessels, so human vessels in the human dermis, and you can see here also pericytes. So we co-stained with human alpha smooth muscle actin, which is one of the markers of pericytes, so cells which are stabilizing those vessels. So already 1 week after transplantation, we had a pretty mature kind of vessels in this transplanted skin. So this was about vascularization, and I would also like to briefly mention pigmentation, which is a very important aspect also for skin tissue engineering, especially now also when we have in summertime because of the high sun exposure we get. So as you know, we have different color of our skin, of our hairs. This is always mostly genetically already, because of our genetic background, we get specific sets of cells, this is called melanocytes. And those melanocytes, they produce melanin, which is a pigment, which gives just the color to our skin and our hairs. And so this is something, it's not only for aesthetical, of course, appearance, but it's very important, as you can imagine, when we go into sun, as everybody knows, we get brown. Some people get red, depending on the type of the skin. But this is, of course, very important for protection against melanoma. So we need this melanin really to protect here the cell nuclei of keratinocytes. So you see that those melanin pigments, this is distributed over suprabasal layers, and this melanin protects really the genetic material of our cells in the epidermis. So that's why this was very important aspect, and this is also where we put a lot of effort actually to optimize the protocol and produce this kind of pigmented grafts. For this, of course, we isolated, in addition, melanocytes. So melanocytes, as I showed you, they are sitting in the dermis, in the basal layer of the epidermis, and you can also easily isolate them from the epidermis. You can culture them, and when added with the keratinocytes, when you seed them also on this fibroblast layers, then they will also establish specific color in those skin transplants. And we investigated this also on our immunodeficient rats. And as you can see here, we just prepared 2 sets of experiments. So one in one experiment we use skin like cells of the patient with very light pigmented skin. So you can see here the upper panel, it's not white, of course, because almost no skin is white, but it's kind of light, right? And here at the bottom panel, you can see cells which were isolated from dark pigmented donor. It's really dark. And also here, the skin substitutes on the red, after 15 weeks, you can see that they kind of also got dark. So with this experiment, and I mean, we did a lot of studies, I am not showing everything here, but it tells us that indeed, just using the patient cells, those melanocytes, putting them in a specific ratio like we have in our skin, can really mimic, by doing this, you can mimic the skin pigmentation of the patient. So you can give, so to say, the color back to the patient. Here it's just a specific staining of this melanin pigment. So you can see here in this dark pigment skin substitutes, it's just heavily stained. So this melanin pigment is really dark. And you can imagine that those patients, of course, has the the best protection, the highest protection against sun, UVB, UVA radiation. And of course here, light pigment skin substitutes that are not so well protected. You see some melanin pigment, but just at this lower layer, so it's not so much melanin around. And this is immunofluorescence staining also for those melanocytes in green. HMP45 is a specific marker staining those melanocytes. And you can see that indeed in the donor skin, but also in skin substitutes, we can confirm the presence of those melanocytes. And just going to the last aspect which I would like to present you today, it's the creating the hypodermis, so the fat layer. As I mentioned at the beginning, it's not just the epidermis and the dermis, which are the two most important layers of the skin, of course, but we have also the hypodermis, so it's just this underneath layer which we don't see normally, but we have this layer, of course. And for this, we also it is important not just, the fat layer is not just there to be there, but it's nowadays we know that it has an important function also for wound healing. And we know from surgeons that indeed in deep wounds, this fat layer is also burned mostly. So they need to kind of remove it because it's that when they are doing this debridement, so they're removing a lot of tissue. And sometimes they have such deep wounds that they would just need fat, even as a fat, as a fat layer to just fill in this gap, this big wound. So that's why this project was initiated actually together with the surgeons to see if this is feasible actually to develop such a fat layer and to add it actually to the skin. So for this approach, we use adipose-derived mesenchymal stem cells. So, it's like from bone marrow, but just from fat. And so we use these cells for this fatty layer. And we use other cell types, so fibroblasts, keratinocytes, and also those HDMACs, so these endothelial cells, for this dermoepidermal skin grafts. And this was like kind of the protocol how we created this. And this is here on top, on the left-hand side, you can see with oil red. The oil red is just a specific staining for this for the lipids. So you can see that indeed this the upper part of the graft in vitro is really is not red. It's just the dermis and the epidermis, and the lower part is this lipid-containing oil red containing stained layer, which is just the hypodermis. And this was transplanted also on our renewed rats. And here at the bottom, in the bottom panel, you can see that's the transplant, how it was transplanted. So we call it 3-layered skin substitutes with the fat. And this is at the day of transplantation, then after 2 weeks. And here we transplanted as a kind of control our standard, so B-layered dermoepidermal skin graft, because we, for example, wanted to see if there is more contraction, what happens actually to those 3-layered grafts. But actually, we saw that the graft area was similar, so there was no difference in the contraction or graft take. So actually, those 3-layered skin substitutes, they did pretty well in vivo. And these are some immunofluorescence stainings we took. For example, what is very interesting here in D, you can have a look. We stain for adipored. Adipored is just a staining for lipids. And we stain for CD90, which is this mesenchymal stromal cell marker. And you can see that, of course, CD90 was also in the dermis, which is here. But here, the hypodermis was indeed positive for adipored. And we stayed also with other markers like body pie. So here in green. So we could really confirm in vivo that all these layers were intact. So from the epidermis going down to the hypodermis. And the important part of the study was also that it was vascularized. So it was actually this kind of, if you have 3 layers, actually it's too thick for a tissue to be transplanted without any necrosis, because in this case, yeah, it's just too much for the for the host vessels. It takes too much time, too long for them to vascularize. So here we also added those human capillaries in the dermis, and we saw that actually this inosculation happened also very fast after up to between 4 to 5 days. You see here in white the red vessels, so connecting to our in vitro generated vessels. So there was also like at this border between the hypodermis and the dermis, there was this inosculation also happening in vivo. So I think, yeah, just not to talk too long with this, I would like to thank you for your attention, and I am open for questions you might have. So thank you very much.
Yes, I also want to thank you for this very interesting lecture. I see we have some questions, but I'm sorry I can't stop myself to ask you because maybe I explain myself. I was really disappointed that I can't participate in the lecture you gave in University of Gdańsk, because I had classes with students in the same time. But the topic of yours is also combined with mine, because I also take the topic of wounds, especially the chronic wounds. So I just first I want to ask you, is this technique, skin graft, also can be useful in treatment of chronic wounds like ulcers or the diabetic ulcers, on venous ulcers?
Yes, it's a very good question actually. So as I mentioned, we are collaborating a lot with surgeons, because we think for all these clinical questions actually, they know actually what they need, the clinicians, right? I mean, we are just researchers, so we don't have this kind of idea always what is needed, right, in the clinic. So talking with like vascular surgeons, with all these clinicians who are dealing with these ulcers every day. So there was idea, and actually they find it very interesting, this vascularization approach. So for example, you have, as you said, different kind of chronic wounds, diabetic wound ulcers, but also this venous or arterial leg ulcers. And actually we think that it could be very interesting. So diabetic, this DFU, so diabetic foot ulcer, is kind of, everybody's doing something for this. It's kind of first target application for very many products at the moment. But like our surgeon said, at least here in Switzerland, I don't know how it is in other parts of Europe, but venous leg ulcers, there are not many treatment options for venous leg ulcers, and they can be, so this is like this really large wounds you get on your leg, so the lower part of the leg. This is because of problems with with blood pressure. There are some problems really in the veins, but finally you get really in this there are different, of course, stages of this disease, right? But in this very late stage of the disease, you get just skin wound, which is very difficult to treat, because those are large wounds, so you cannot just put something small like a dressing. and vascularization is very impaired in those wounds. So we think actually that it might be something interesting, but it's it's another topic that burns. But this vascularized skin grafts, I think it's indeed we are going a bit also in this direction with the vascularized grafts. Yes, in maybe also diabetic foot ulcer, but mostly this even venous leg ulcer, which is also which is difficult to treat, even more difficult to treat also because it's so big, and yeah, it's difficult apparently.
Thank you. So maybe another question from me. Have you seen some limitation now or of your technique? What is the most limitation?
Yeah, you mean like for clinical application?
Yes,
Right.
yes.
Yeah. So the problem indeed, this was, I mean, luckily for patients, but we had some problems with patients with specific resistant bacteria. I mean, you have kind of standard antibiotics in your culture medium, but for some patients, these antibiotics did not really work well. So there was like 1 or 2 cases even, you have this kind of compassionate use. I don't know if this is, so sometimes when the product is still like under, clinical, in a clinical trial, the surgeon can use it if there is nothing else, to just save the life of the patient. So we had some really severe burns, like I think it was from different countries, like Saudi Arabia or somewhere. So there was one kid which was like almost 80-90% burnt. And they were trying, so we were really trying very hard to produce skin substitutes for this kid, but apparently he had some specific bacteria which were totally antibiotic resistant. So I think they tried 3 times, and every time everything was contaminated. So in this case, you are not, you cannot just produce any patch because it's always contaminated. So I know for this patient, our surgeons, they tried whatever they had, like dermal templates, so like Integra, they put whatever they could put on this patient just to cover, because it was such a big burn that you get infections with time, so you need to cover. So that's the first, just to cover whatever you have, and just to save the life. And then you don't think about scarring or like what happens next, but just step by step, right? But in this case, so that's our limitation. Actually, we know that in this case, it's when there are those bacteria, you cannot actually treat the patient. That's the problem.
So I want to ask if I good understand, when you prepare the skin graft for specific patient, you take the material, the cells from themselves, right?
Yes. So we need like a healthy biopsy, right? And so we
So if there is something with the, I don't know, skin structure or some genetic changes in the skin structure, it also could be the limit for preparing the skin graft.
If you think about genetic disorders like skin diseases, which where you have a gene defect in the skin cells, you cannot use the cells. But but for this, of course, you need gene therapy. You would need, right? So we need like small biopsy, but when we can isolate like a healthy skin cells. Otherwise, it's not possible.
Okay, it's really good to hear that there is a lot of things to do in the topic of wound healing, so I can still provide my research. So okay, maybe it's time for the question from the audience. I see the question from Monika Godlewska. Dominika.
Yes, good morning, Professor. Thank you very much for the inspiring and very interesting presentation. Considering the complexity and potential of this technology, I would like to ask what are the possible direction for future development of this approach, and what still needs to be achieved for it to be widely implemented in practice, for example, in other areas of life, and not only in medicine.
So what we think, what is still missing, we are aware of the fact that, of course, human body is a very complex thing. It's not so easy to always to mimic those features in vitro, but So skin appendages is something we still don't have. We were trying with sweat glands. So sweat glands would be crucial to also include in those transplants because, you know, our skin, now this artificial skin is not sweatable. So, and this is a big problem for thermoregulation because if you have such a transplant, so large areas of the body is covered by such a transplant, then this skin cannot sweat. So yeah, it's a, from medical perspective, it's a big problem for those patients. Yeah, hairs, of course, it's more for cosmetics. So for like physiology, it's not such an important thing to have also hairs, but this is also something which is missing. So this would be something which is needed for the future. Also a bit regarding question of Krzysztof Polaczek regarding the, you know, what is like limitation. I also think, and what is like for the future, what would be useful is just to use, you know, induced pluripotent stem cells from the patient. So to have, I mean, ideally would be to have like a skin biobank kind of from patients. So like induced pluripotent stem cells from patients, and from this you could just create like the whole artificial skin like on demand. You know, once you get the accident or you get burned, then just from this, using this induced pluripotent stem cells, we could create like artificial skin. This would be something like high tech and something for the future. But at the moment, of course, we have many publications showing that it's possible. But you know, it's the functionality. It's not so 100% sure at the moment if using just induced pluripotent stem cells we are able to create, you know, the whole skin. But this would be something. And of course, for the research, so you mentioned that what would be important not just for the clinic, right? So I think at the moment, like we use it also as an in vitro model for skin research, and I think also for dermatology and for the perspective of 3R principle, you know, to just reduce the animal experimentation. I think it's yeah, in vitro research in general, so spheroids now, and also this very small hydrogel, so you can use even in 48 well format, for example, you can use this for research, and it's even forbidden in the EU, in general, also Switzerland, to use animal models for like cosmetic, you know, testing, and it's of course clear that we can, for many studies, we can just go for in vitro, and I think this is this is a very wonderful actually model to be used in vitro, because those capillaries, those melanocytes, they all kind of cells, they grow really well in 3D, and whatever drugs, for example, you would like to test, you can do it also in vitro. And in vitro is of course much easier than in vivo, and then once you have good results, you can, for example, go in vivo. So this is, I think, it's also kind of nice. Also for skin diseases, of course, we kind of also creating now a model. So using this our approach, and also in different other labs, people are using those skin models also for disease. So, for example, for inflammatory skin diseases like atopic dermatitis and other psoriasis. So it's very now well established to use those kind of models, just adding also immune cells or trying to, you know, understand better this interaction between the like skin cells and immune cells. So I think that's a bit also future directions are like skin also research. Yeah, and dermatology also, a lot of studies for dermatology at the moment are ongoing.
Okay, thank you very much. It will be useful. Thanks.
Welcome.
We have another question from Lucia Ptach. Lucia.
Hello, can you hear me?
Yes.
Thank you very much for your extraordinary talk. I was wondering, can you tell me what are the criteria for qualifying patient for this type of bioengineered skin grafts?
Yeah, so it's a good question. I mean, so I know just that our clinicians, you get kind of, you know, requirements like settings from the authorities. So first of all, here we performed the study first in Switzerland. So it's like Swissmedic. It's like EMA in, you know, in Europe. And they just, you know, you need to give them a specific target, specific group of patients. So our first like main application, target application was actually burns and in children, because that was actually the idea and the dream of our surgeons, because of course we are at the children's hospital. So this was like the topic, and for this they kind of how the surgeons directly, you know, how they target the patients. I don't know. I think it is all specified in this documentation you provide to the authorities. So I think there were for sure some specific requirements, like maybe at least 10-20% of the body surface burned, or yeah, they have, for example, that this was just this disease and no other disease. And with children, it has also to do with ethical approval. So, you know, yeah. So for phase 1, yeah, it was just more safety study actually. But where the exact criteria I cannot tell you, so just out of my head. I know that there were for sure some specific, but it's, you know, it's like in the standard documentation. Yeah, but
okay, I see. So like overall, it's a bit more complicated for example, children patients than the regular adults.
Yes. You know, and also we had the idea very at the beginning, we had already the protocol with pigmentation, so we could have started, you know, with pigmented skin even at that time, but they said no, because this like melanocytes are very, you know, can be very dangerous cells, because if they, you know, change to kind of get some mutations, they can actually create melanoma. So for this, the authorities are very strict, and especially in children. So you don't want to, you know, transplant something which could maybe give melanoma. So there, especially with children, you know, from the, like also from all this for the ethical consideration, it's more difficult to perform such a clinical trial, because there are children, of course, and you know, all the drugs, all this also transplants, there can be different side effects like in adults, and most of the drugs are actually, you know, tested in adults, and for children you never know if there could be some other effect, because they are smaller, and everything is a bit different. From this perspective, it's with children, to do clinical studies with children, it's very difficult. But you know, once you provide all the documentation, this bulk of paper, they will also say yes. But with this kind of products, it's even more difficult, because it's, you know, ATMP, so it's this advanced therapy. What is this advanced therapy medicinal product? It's like biologics, like gene therapies. Even the authorities, they tell you that they don't have like a specific protocol for your product, because they are also learning. You know, nowadays there are more and more of this new kind of treatments, and they are also learning. They also don't have like very specific protocols. So you just need to provide data, and they will give you feedback. So this is on this kind of, you know, working like this, and then they see, okay, then now you need to provide more data on this. So it's never that it's white and black. They tell you this and you bring this, but next time they want more. So with pigmentation, it's very actually the most yeah, I mean, the novel skin, it's just white, right? It's without melanocytes, because this would be much more difficult. And you want, once you want to start also just, testing something you have, and in the meantime, you are trying to do more. And this is also now, we have actually funding, and also they are now preparing at the Children's Hospital also those pigmented skin grafts. So there will be also phase 1 clinical trial, but that is very difficult with pigmentation in children. So, yeah.
Okay, thank you very much.
Okay, I think we still have time for one question. Adrianna.
Good morning, Professor Klar. I want to thank you for a very interesting presentation. It looks very difficult. That's why I have one question. What were the biggest challenges in developing the layered skin model? Could you tell me?
You mean this with the hypodermis or just different layers?
Different layers.
Yeah, so I think the most difficult question. I mean, because like the fibroblasts are the most, the easiest cells to be cultured, right? And so to produce the dermis with fibroblasts, it's the most easiest thing to do. Keratinocytes are a bit more, difficult to culture, so they are very sensitive. And you cannot use high passages. So anyway, we use up to passage 3 normally. And but like what is more where we need to like struggle a lot was this vascularization. So to find actually, meaning the layers, to find actually co-culture conditions like culture media time, that all the layers are happy, and that's the most. When I am talking also to other researchers, that's always the most difficult part. If you have different layers, you have different culture media normally, right? So with this, we are using this transfer system. You probably know with this hanging inserts in a well, right? So you can have two different media on top, for example, for keratinocytes, and then at the bottom we add this fibroblast medium. But with the hypodermis was another problem, because we had 3 layers, and this fat layer has another medium, because you need to differentiate first, right? So you have this adipose mesenchymal stem cells, and you need to differentiate them into adipocytes. So, and this medium was actually killing the capillaries, so structures. So the capillaries could not grow, but the adipocytes were there after 3 weeks. So we then figured out that we actually will do this separately. So we prepared this adipogenic kind, like this fat layer separately, and just the dermis, vascularized dermis and epidermis together, and then we combined. So this was the approach. But that's, like doing different layers, it's always, I think, this kind of issues you get. Whatever, I think, organ you are creating, it's always the same with this culture media, to find very the best medium, which is like there is no one medium, so you always need to find a different ratio, like perfect mixture of different media, how to combine and how to actually to co-culture them. That's the thing actually about the layers. I would say separately it's more easier if you have just one layer. I would say.
Oh wow, it's very impressive. Thank you.
Yes, I'm sorry to say that, but we have to stick to the time. Once again, I want to thank you for a really interesting lecture. I also have a lot of questions, but I'm sorry, it's time for the session. So maybe I try to contact with you.
No problem.
From Professor Motovidło. Okay, so once again, thank you for a very interesting lecture. And
thank you.
In the next edition, we have to consider to increase the time range from the question to our guests.
Thank you.
Yes, now it's time for our first session. So the presentation session will be provided by Edyta Raczuk. Edyta, are you with us?
Good morning, everyone.
Good morning. So I leave the voice to you. It's from me. It's thank you everyone for the listening, and see you at the end of the conference.
Thank you. I'm pleased to welcome you at NSBC for our second day's morning session. This is the 5th session in the schedule. It ends at 10:15 UK time, and we're looking forward to 5 live presentations in the time, 12 minutes each, and 3 minutes are allocated to the discussion afterwards. And now, allow me to welcome our first speaker, Magdalena Szpunar, from the University of Rzeszów in Poland. Please, the microphone is yours.
Can you hear me?
Yes.
Okay, so I will share my screen. Okay, so can you see my presentation?
We can.
Right. So, hello, my name is Magdalena Szpunar, and I am a PhD student at the doctoral school of the University of Rzeszów in the field of physical science, but also chemistry. My scientific supervisors are Professor Andrzej Wal and Professor David Ebisher, and today I will present you the results of my scientific research on the evaluation of free radicals produced by indocyanin green using EPR spectroscopy. So first of all, it is worth familiarizing yourself with what EPR spectroscopy is, also known as electron paramagnetic resonance. It's a spectroscopy technique that allows to detect and obtain information about the surroundings of a given spin sample using microwave resonance containing n-pair electrons when the radiation frequency is equal to the precession frequency of the magnetic moment of electrons in magnetic field, which manifests itself as a change in the absorption of energy by the sample and affects is detected and analyzed, which makes it possible to obtain information about the electronic structure of the sample, the chemical environment, and molecular dynamics. And on the right, you can see the scheme of the EPR machine. So you have 2 big electromagnets, the sample cavity in the middle, the source detector, phase-sensitive detector, and modulation input. Another really important part of my research is reactive oxygen species. ROS is a term that describes chemical compounds formed as a result of incomplete reduction of oxygen, and we can divide them into 2 groups. The first is free radicals. Among others, there is a superoxide and hydroxyl radical, which we will describe in this research. And also there is a second group, non-oxidizing compounds, which contains, for example, singlet oxygen. Okay, so how EPR works and what we can see. As radicals have short lifetime, we need to use spin traps. For example, DMPO, which I used in this research. Each radical has its own specific signal, and experimental signal represents combination of different radical signals, which you can see on the right. So at the top, you have the equation representing the chemical reaction of DMPO and hydroxyl radical. And below there is an experimental signal with the black, and then signals from hydrogen radical and hydroxy radical with red and blue signals. Those are simulations of just clear radicals. And most important, indocyanin green, it's a clinically accepted agent used for fluorescence imaging, but it has fluorescent properties. It can be potential candidate for use as a photosensitizer in photodynamic therapy. Photodynamic therapy is based on the use of singlet oxygen and reactive oxygen species to destroy cancer cells. And the interaction of water with light and oxygen contained in the surrounding tissues can kill the cells. So we have here a mechanism. Maybe I will use pointer. Okay, so we have the light, and when the light goes to the PS, so the photosensitizer, it goes into excited single state. Then through intersystem crossing, we have the triplet state. And there are two types of reaction. Either it can go with type 1, so produce radicals from oxygen and generate radicals, or it can go from the oxygen by type 2 and create singlet oxygen, which is important in the photodynamic therapy. Okay. What are the experiment objections? So we have two main objectives. Evaluation of the production of free radicals by indocyanin green under both irradiated and non-irradiated conditions. And the second one is analysis of the chemical reactions occurring during the irradiation of ICG. For research, we prepared aqueous solutions of indocyanin green with molar concentration of 500 micromoles and DMPO with concentration of 250 millimole for the study of free radicals. For testing with an EPR spectroscope, samples they were prepared in volume ratio 1:2, 1 part of ICG and 2 parts of the drop. And the sample was irradiated with high intensity fiber coupled laminator with 91 centimeter long fiber bundle. Power at the fiber tip is 1.4 watt at maximum bulb intensity, but we use 40% of this power. Wavelength range is from 400 to 1600 nanometers. This study was carried out on a Bruker Alexis E580 multi-frequency spectrometer with a high sensitivity chamber to the X band at frequency of 9.42 gigahertz with a power flux of 2 decibels. And the measurements were performed in two series. Series 1 without light exposure and series 2 with light exposure. And the change in the EPR signal of the sample was studied over 60 minutes. On the right, you can see the photo of when the light from the illuminator falls on the X-band chamber. So just to describe what is what, you have the scheme on the bottom right side that represents the signal simulated from each radicals. You have them for hydrogen, for hydroxyl radicals, and oxygen radicals in the bottom. So I put the same colors to respond the lines. So we have hydroxyl radicals with L2, L5, L9, and L12 signals. Then hydrogen, L3, 7L11, so the red one, and the oxygen radicals with purple color. So on the experimental signal, you can see combination of different radical signals. So you need to check what is what. Just to present overall how it looks like. So we have 13 measurements of during the time. So from the beginning, the first one is 0 minutes and the last one is 60 minutes. It is hard to say what is what here because there are too many signals. So I will show you only the most important one, the crucial one. And let's look in here. We have the first signal at the beginning, so 0 minutes. Another one, the red one, after 15 minutes. And the last one after 60 minutes. So you can see the different colors corresponding to different signals during the time. So we can see, for example, in here, where we have hydroxy radicals, that there is a difference in intensity for 0 minutes, 15 minutes, red one, and then 60 minutes. Okay, so go to the clue. What is the difference between sample without irradiation and irradiated sample? So you can see the sample without irradiation stays mostly the same. The spectra, so for the 0 minutes, 15 minutes, and 60 minutes stays the same. There is a slight change in the noise, but you can see they are mostly similar. But when you look at the irradiated sample, you can see the differences. There are not a lot of differences for the hydrogen radicals. So the 3, 7, 11. But when you look at the hydroxyl radicals and also for oxygen radicals, you can see the change. And this is what I wanted to see and describe in later. Okay, so you can see the big example with hydroxyl radicals, hydrogen radicals, oxygen radicals. So you can observe the differences on the spectra. So the hydroxyl radicals, after 15 minutes, the signal is increasing, but after 60 minutes, there is a decrease of the signal, but it's still higher than at the beginning. And for the oxygen radicals, so you can see at the L10 at the beginning, so black one, there is a nice slope. Then it's decreasing a little bit, but after 60 minutes, the signal is really low. I will explain later why this is happening. But let's look at the whole range of the time. So from 0 to 60, you can see all measurements and the point corresponding to all the radicals. So you can see hydroxyl radicals in here, hydrogen radicals and oxygen radicals. Without irradiation, it is, you can say, similar, something is going on, but it's not risky. Okay, but the irradiated sample for the first 15 minutes, hydroxyl radicals are increasing. The signal, the intensity amplitude is increasing. So we could see this on the graphs before. And also we can see decrease of the oxygen radicals. Now let's move on, but we can focus on the first part from the 0 to 20 minutes. There is, like I said, increase of hydroxyl radicals. hydrogen radicals remains at the same level. And there is decrease of oxygen radicals. And that's why we need to explain the reaction corresponding to this data. There is something called decomposition or peroxidase when the MPO with oxygen creates the MPO-OOH. Through the decomposition, it goes to the MPO-OH, which is similar or exactly the same as the MPO with hydroxy radicals. So that's why you can see the increase of the hydroxyl radicals in the same time as decrease of the oxygen radicals. But it's not only reaction that's going on. There is also increase of the connection of the MPO with hydroxyl radicals through the irradiation. Let's go to the conclusions. The first one is light affects ROS producing by accelerating the generation of hydroxyl radicals, and the irradiation also affects the reduction of oxygen radicals. Most likely the composition process occurs simultaneously and also affects the formation of hydroxyl radicals. Light has no particular effect on hydrogen radicals, and the evaluation of indocyanin green and the effect of light on ROS production is important in order to use it, and further research is needed to standardize its role in photodynamic application. That's my bibliography, and thank you for your attention.
Thank you very much for interesting presentation. We've only got time for one question, I'm afraid. But please, I see one person from the audience, please take it away.
Hi, thank you very much. Thank you for your really interesting presentation. It's a completely new topic for me. So my question may be rather simple, but I'm wondering, is there any application potential that your research can provide?
Yes, as I said at the beginning, I want to use indocyanin green for the photodynamic therapy, but it's not completely research on that. So I need to make, that's my PhD research topic. So I need to provide photodynamic therapy with indocyanin green to kill cells, but it's not commonly supported photosensitizer. So I need to check if indocyanin green can be used for that purpose.
Okay, so it's like in your plans for the future, basically.
Yes, yes. I need to make a research to then use it for a cell.
Okay, thank you very much.
Thank you very much again for your presentation. I encourage you to ask questions in the chat if you have them. But for now, thank you. And
Thank you.
Please welcome our next speaker, Monika Godlewska from the University of Agriculture in Krakow, Poland.
Hi, hear you me?
Yes, we can hear you.
Okay, wait for my presentation. Okay, can you see my presentation?
We can, but it's not in the full, okay, it's now in the full screen mode.
So, hi, today I would like to present to you the results of the research conducted on the topic impact of the use of silver nanoparticles in potato cultivation. If you have any question, then please send your questions to the email below. The potato, Solanum tuberosum, is the third largest food crop in the world after rice and wheat. The size of the world potato crop was as high as 70 million hectares in 2020. In a significant development for the global agriculture sector, the potato market is expected to experience strong growth over the next 5 years, increasing from 119.79 billions dollars in 2025 to a project 142.27 billions dollars by 2030. This promising prospect detailed in a new report titled Potato Market Size by Murder Intelligence highlight the potato's enduring role as a stable food and its growing importance in the global food economy. Potato is not only a rich source of energy, but has many valuable nutritional compounds such as amino acid, lysine, phenylalanine, leucine, valine, and more. Dietary fiber, vitamin C, B1 or B6, and elements potassium, magnesium, iron, zinc, phosphorus, which important for human health. Moreover, the potato tuber accumulated phytosterols and secondary metabolites, such as anthocyanins or phenols. Compounds of phytochemical help to reduce the risk of diseases such as cardiovascular diseases via reduced serum LDL cholesterol levels, cancer, and inflammatory via compounds which are responsible for antioxidant activity. However, feed crops are exposed to microorganisms, viruses, bacteria, fungi, so chemical sprays are used to protect the plant. Given current trends emphasizing environmental protection and the resulting restriction on the use of chemical, pesticides, and fungicides, protective agents which are accumulated in the environment with destructive effects following spraying, protective agents that are more friendly environmental fertilizer but still fulfilling their function of protecting plants from microorganisms. Some of the diseases of potato field crop are very difficult to combat. This is related to the spread of potatoes with irrigation water, for example, Pactobacterium carotovarium. Therefore, there is a constant need to develop new technological solutions. Nanotechnology solutions using metal nanoparticles are gaining popularity, mostly due to their unique properties, high surface volume ratio, the potential for surface modification, thermal activities, antibacterial and antioxidant activity. Silver nanoparticles, in particular, are known for their antimicrobial properties, which is why they have become an alternative to traditional plant protection products. Despite the antimicrobial properties of protectants, they not only affect the physiology of pathogens, eliminating the pathogen's threat, but also affect the physiological processes of the plant. Previous reports indicate that depending on the plant species and its morphological and physiological conditions, the effect of silver nanoparticles can be either positive, resulting in plant growth and development, or negative, inducing DNA damage, causing decrease in the activity of the antioxidant system or breakdown of the cytoplasmic membrane. The effects of silver nanoparticles depends on their dose and the physicochemical properties that are different depending on the method of synthesis. Different synthesis routes allow obtaining nanoparticles of various size. The dimensions of particle influence their antimicrobial activity. The smaller particles, the greater antimicrobial effects. Furthermore, the silver nanoparticles effect depends also on the method of nanoparticles applications. The possibility of penetration, speed of transport, nature of interaction with the plant, and the plant of silver accumulation are of key importance in the content on the potential of direct use of silver nanoparticles in agriculture plant product treatments. Therefore, it seems that a properly selected dose and structure of the nanoparticles can be of great importance in the case of crop production. Considering food safety, it is extremely important to know where metals accumulate and how a particular protectant affects the nutrient compounds in the edible parts of the plants. The research aimed to examine the effectivities of silver nanoparticles, addressing different methods of their synthesis with regard both to accumulations of silver ions and the nutritional properties of potato tubers. This research presents a relationship between methodology of spraying silver nanoparticles on contaminated silver accumulation in plant and the nutritional properties of tubers in field potato cultivation. For the experiments, two synthetic procedures were incorporated. The first synthetic route used sodium dodecyl sulfate as a capping agent. The second synthetic route used sodium citrate sulfate as a capping agent. The experiment just the foliar spraying method for potato. For each synthesis free concentration of nanoparticles were used 10, 1, and 0.1 per liter. Plant material comprised of potato Solanum tuberosum, medium early variety Typhoon. The first spraying of the potato plants was carried out 4 weeks after the plant's emergence. Subsequent spraying was carried out every 2 weeks. In total, 3 sprays were performed. Each combined were established in 3 replicates. Each replicate consisted of 9 plants. The experiment was planned in random blocks. After 2 weeks from the spraying, plant material samples were collected. From each combined 9 plants were collected 3 plants from each replicate. After a thorough cleaning of plants with tap and deionized water, the plants were divided. From the above-ground plant part, young and mature leaves, and first, third, fifth, and seventh internode above ground. Conjunctive from the ground were selected. Tubers were divided into periderm, core, and pith fragments. Analysis of silver content in leaves, shoots, and tubers were carried out, as well as analysis of tubers for vitamin C contents, soluble sugar contents, phenols contents, and radical scavenging activity, and lipid peroxidation level. Silver nanoparticles elicit in the plants a number of responses at the anatomical, morphological, and as well as biochemical, physiological level. Positive or negative effects of silver nanoparticles activity dependent on their concentration, duration of action, size, surface coating, application site as well as species and plant vegetative phase. Since silver ions in excess can pose a potential risk to human, it's important to examine the distribution of silver ions in the spraying plants, especially in the edible parts, and that's assess the nutritional risk. Analysis of silver ion concentration in different parts of the potato shoots show that spraying with the highest concentration of silver nanoparticle synthesis with citrate led to the highest accumulation of silver in young leaves. At the same time, silver accumulations in mature leaves and subsequent internodes was several dozen times lower. Spraying with the highest concentration of silver nanoparticles synthesized with citrate led to the accumulation of the highest silver ion concentration in the tuber pith and the lowest in the core. In contrast, spraying with the highest concentration of SDS synthesized silver nanoparticles resulted in the highest accumulation of silver in the tuber periderm. In the case of potato, nanoparticle size range from 50 to the 126 nanometers depending on the synthesis method, so they could be transported both apoplastic and symplastic ways. The speed the transport route, the concentration of silver ions in potato tubers was low, especially in case of spraying with silver nanoparticles synthesized with SDS. In general, spraying plants with silver nanoparticles synthesized with citrate resulted in an increasing the sugar content in all parts the tuber relative to the control. Vitamin C content in tuber of control plants was highest in the cortex. Meanwhile, spraying with the plants with silver nanoparticles increasing the vitamin C content in the tuber pith relative to the periderm. With spraying silver nanoparticles citric 1 and 10 resulted in a decrease in the core relative to the pith. Comparing the effect of the solution in the different part of the tuber against the control, a decrease in the phenolic context in the periderm was noted after the spraying of nanoparticles regardless of the synthesis method. In terms the activity, the scavenging free radicals in control tubers was highest in the periderm, lower in the core, and the lowest in the pith. The applications of citric synthesized silver nanoparticle spraying did not change in the distribution of the free radical scavenging capacity among the different parts of the tubers, but led to its decrease relative to the control at all parts in the tuber. The lowest amounts of silver ions were transported to the tubers after spraying with silver nanoparticles synthesized with SDS rather than with citrate. Nevertheless, silver ions accumulations in tubers was negligible. SDS method of synthesis was more favorable in terms of nutritional properties of potato tubers. The highest tested concentration of silver nanoparticles SDS had a favorable effect on a variety of macro and micronutrients, ascorbic acid and soluble sugar. In turn, lower concentration of silver nanoparticles SDS increased the content of phenolic compounds and free radical scavenging efficiency of tubers. I would like to thank you, the research team, that participated in the research conducted. Thank you for your attention. If you have any question, please send me an email.
Thank you. I'd like to open the floor for questions and comments you may have. I can see a person raising a hand. Ms. Kapuścińska, please.
Yes, hello. I have a question. Thank you for your lecture. Why was the typhoon potato variety selected for this study? Were other varieties considered or tested as well? And if so, did the results vary significant between them?
Can you repeat questions?
Yes. Why was the typhoon potato variety selected for this study? And were other varieties considered or tested? And if so, did the result differ between them?
I think the research similar results, but if you use the different variety, the best is the prepare new research. But different variety is the different physiology and different morphology, and is the must the.
Okay, but you tested other varieties or no?
No, no yet.
Okay. Thank you very much.
Thank you. So your question.
Ms. Tak, please.
Hi, hello, can you hear me? Is everything working?
Yes, we can.
Great. Can you tell me, are there any downside to using silver nanoparticles in potato cultivation that can, for example, influence people's health?
So the silver is the metals, and in the high accumulation in the, for example, tubers. If the human eating like these tubers, the accumulation in the organism of human, and then the diseases for the accumulation metals. But in this research, silver nanoparticles isn't accumulation in tubers, which the organs is edible parts for the potato.
Okay, thank you very much for your answer.
Thank you for your questions.
Dr. Vnuk, please.
Thank you for your very nice presentation. I have one question about the control conditions, because you show us that your control is the plant without spraying, but I have a question about the SDS. So do you use SDS only for the preparation of your particles, or it will be in the mix of the spraying? So is the SDS is the mixed spraying or not? What is the presence of SDS in this mix? Is presence or not?
So SDS is only the the prepare nanoparticles, but the control is no use any nanoparticles.
Okay, okay, thank you.
Thank you, Soyu, for.
Thank you for your questions. And now I'd like to invite Afaq Hassan from Gdańsk University of Technology. Please, the microphone is yours. We can't hear you yet. Okay, since we have technical problems from our guest speaker, please, let's hear from Angelika Łepek first, from Gdańsk University of Technology, and we will move this presentation to the end of the session.
Okay. Can you hear me now or not?
Yes, we can.
Oh, okay, that's perfect, perfect. If you can hear me.
Okay. Let's stick to the schedule then.
Okay, thank you so much. Hello everyone, good morning. My name is Afaq Hassan and sorry for the delay. I'm from Gdańsk University of Technology, working under the supervision of Professor Justyna Wojciech. The topic today I'm going to present is related to ammonia oxidation reaction. It's the electrocatalytic performance of nickel boride at nickel copper hydroxide deposited on the nickel form. I will keep it simple so that everyone can learn from my topic. First of all, why we need ammonia oxidation reaction? The simple thing is, if we break down ammonia, 1 mole of ammonia, we will get 1 mole of nitrogen and 3 mole of hydrogen. So this is the simple and theoretical approach to get clean and green energy, which is hydrogen, which is the future, and Europe is striving for the hydrogen energy. Why not other processes? This is the main question, because as we all know, there are many other electrochemical processes taking place, such as urea oxidation reaction, hydrogen oxidation reaction, and oxygen evolution reaction, OER. Why not all these oxidation reaction? Why we should particularly focus on ammonia oxidation reaction? The simple question to answer to this question is low over potential. We required a low energy to break down ammonia as compared to other oxidation reactions. Furthermore, there are no byproducts in ammonia oxidation reaction. However, in other oxidation reactions I mentioned earlier, there are some byproducts, harmful byproducts, which are not good for our environment. So if we break down ammonia, we will get nitrogen and hydrogen, which is our goal, to get the clean and green hydrogen energy. So there are some challenges which are attached with ammonia oxidation reaction. Number one is slow kinetics and some side reaction which creates poisonous on the surface of the catalyst. So we need some catalyst which minimize the poisonous and byproducts, and also increase the efficiency, reduce the cost, and in return improve the catalytic efficiency of ammonia oxidation reaction and reduce the potential for the production. Since now platinum catalyst, noble catalyst have been so far best for the production of nitrogen and hydrogen from ammonia oxidation reaction. In our previous work, we have published 2 articles related to ammonia oxidation reaction. We use non-noble metals such as nickel and copper. In this research, I'm also going to present nickel, copper, and boride-based catalysts. So this is the simple hypothesis of my research related problem statement and the research objectives. Now we will move forward to our next slide. This is the methodology. I use a simple hydrothermal methodology and dip coating method to synthesize my electrocatalyst. Initially, I wash the nickel foam. Nickel foam is used as the substrate to deposit my catalyst on the surface. The first step is cleaning.
Excuse me, we can't see the next slide. I think you mentioned you're going to go forward, and I don't think it changes.
Really? I don't know. Wait for a moment.
We are stuck on the problem statement and research objectives.
Okay, wait. I will change the connection, or maybe just give me one minute. Okay, can you see now?
Unfortunately not. Maybe you should try full screen mode. Okay, now it changed.
It changed. Okay. Thank you.
Thank you.
So this is the methodology. First step of cleaning of nickel foam, and the second step is hydrothermal deposition of nickel and copper hydroxide on the nickel foam. I use simple hydrothermal synthesis, which is carried out at 120 degrees C for 12 hours. And the third step, I deposited, doped the nickel copper hydroxide with nickel boride, and after that I carried out XRD experiments to check out whether I get the deposited nickel boride on the surface of nickel hydroxide or not. So this was my simple methodology I carried out. These are the list of electrodes which I used to evaluate the ammonia oxidation reaction performance. Some reference samples, and with the variation of dipping cycles, nickel boride 5, 10, and 15, you can see. So I used up till 15 dipping cycles to check which is the best to provide the best efficiency for the ammonia oxidation reaction. These are my XRD results. You can see in the figure A, which contains only nickel-based catalyst, nickel boride at nickel hydroxide, and in the figure B, you can see nickel boride at nickel copper hydroxide. Here you can see we can identify the nickel boride peaks here through XRD, which tells us that nickel boride is successfully deposited on the nickel hydroxide. And similarly in the figure B, nickel boride along with nickel copper hydroxide. So the aim of my synthesis was confirmed with the help of XRD. There will be furthermore some characterization to verify, such as XPS and SEM EDX analysis to further confirm that the required catalyst was synthesized or not. Up till now, I have XRD, so I present it in front of you. This is the electrochemical testing, most important. How we came to know that ammonia oxidation reaction take place or not. Here we can differentiate between these two graphs, A and B. You can see in A, we have a 1 molar KOH solution, and in B, we have 1 molar KOH solution and ammonia. And if we compare the peaks on both sides, you see the bump here, a plateau in 1 molar KOH, but in 1 molar KOH ammonia, you don't see the bump, a peak, which represents, you see the straight line, which represents that ammonia oxidation reaction takes place. But without ammonia, there is no straight line, so you can differentiate and say that ammonia is taking place. And also you can see the potential. The potential is reducing in terms of ammonia, and also the current densities are higher. So when the current density is higher, potential is less, and there is a straight line with ammonia. This shows us that we have ammonia oxidation reaction. And in the figure C, I have compared the current densities with the different electrodes available in this in the literature. So our electrode, the new electrode, this work you can see still stands near to the best electrodes reported in the literature. As this is the new work, there is no so much literature available. So for now, our catalyst nickel boride, nickel copper hydroxide stands in a good position compared to the literature. These are the LSV results. We can see if we plot a straight line with respect to x-axis, we can see the reduction in the potential, which means we need less energy required for the ammonia oxidation reaction. And this graph, this shows the TEFL slope. What is the TEFL slope? In the simple terms, if I explain, if we go to the mountains and if slope is higher, we need more energy. If slope is less, we need less energy or power of the car. Simply here, if the slope is less, we need to provide less energy to carry out ammonia oxidation reactions. So if we compare all our electrodes, the best electrodes, nickel boride 10 and nickel copper hydroxide, green one, shows the less slope, which means this one is the best and required less energy to carry out ammonia oxidation reaction. And similarly, in the figure F, I compare my result with the literature. Catalyst available in the literature, and so far this our work is the best as compared to other catalysts available in the literature. And now the figure A represents the CDL comparison, which is double layer capacitance. It is the measure of electrochemical surface area. Here you can see we have the best ECSA or CDL capacitance for our nickel boride at nickel boride 10 and nickel copper hydroxide. And similarly, the figure B represents the turnover frequency. Turnover frequency is an intrinsic property which tell us in a simple way, which tell us how many reactants are converted into the product. I calculated the turnover frequency at different potentials and find out that the best sample, which we claim in the previous electrochemical results, nickel boride 10 and nickel copper hydroxide has the highest turnover frequency. So far, compared to literature results, compared to our reference electrodes, this sample has shown the best catalytic activity. And furthermore, I evaluated the product analysis. In this, I checked out how much reactants are converted into the products after 24 hours. So you see in the figure A, removal efficiency after 24 hours, I have the 95% removal efficiency. And then I check my electrode with the literature, electrodes available in the literature. You can see nitrogen selectivity, it shows more than 85%, which still you can see if you compare with the other electrodes in the literature, it's best so far. But still we need to carry out more electrochemical results to support our idea that our electrodes has the best catalytic efficiency compared to other electrodes. This is the table, comparison table of my reference electrodes with the best one, just for the information. And conclusions, the final slide. Nickel boride 10 at nickel copper hydroxide electrode synthesized through the hydrothermal deposition and dip coating method exhibited superior catalytic activity. The catalyst enhanced performance in ammonia oxidation reaction is attributed to the transformation of nickel and copper boride and copper oxide. The third one is the addition of copper and boride into the nickel hydroxide matrix improve electron transfer. The ammonia oxidation reaction is based on how efficiently electrons are transferred on the electrode surface. So after the addition of nickel boride on the nickel copper hydroxide, it enhances the electron transfer, and in return, it improves the ammonia oxidation reaction and also improves the electrochemical active surface area. So these are my conclusions, and thank you so much for your time. And if you have any questions, more than welcome.
Thank you for your presentation. Now it's time for questions. Here we have one question from the audience, please.
Yes, hello. I have a question about your plans for future research. Maybe we can implement your result in practice, for example.
Yes, we are going to. Thank you so much for your question. Yes, we are going to apply this on small scale electrolyzer or a fuel cell, direct fuel cell ammonia oxidation reaction, in which we will check our catalyst ability to produce hydrogen or nitrogen. This is our future plan to use as an electrolyzer or in a direct fuel cell.
Okay, thank you.
Thank you very much. I have to ask that any other questions may be written on the chat. Please continue the discussion there. And right now, I'd like to invite Angelika Łepek from Gdańsk University of Technology for the next presentation.
Hello, everyone. I'm trying share with you my presentation. Can you see it? Wait.
Not yet.
Not yet. Okay, that's not good. And now always not, no, probably.
Still not, I'm afraid.
Okay, wait. I tried it by a different way. Traditional way usually is the best. Okay, can you see my presentation?
Yes, we see.
Yes.
Okay, perfect. So my name is Angelika Łepek. I am a PhD student at the Gdańsk University of Technology. And today I would like to present my project titled Multifunctional Laser-Induced Graphene Sensor Enabled by Neutral pH Aniline Electropolymerization. At the beginning, I would like to introduce two fundamental aspects of my work. First of all, let's talk about materials. In this research, I worked with laser-induced graphene, or LIG. This is a graphene-like structure fabricated using a CO2 laser on various substrates. In our study, we produced LIG on polyimide foil, but it can also be fabricated on other substrates, including unconventional ones like bread or wood, as shown in the picture. A key feature of LIG is its hierarchically porous structure. These materials possess pores of at least two different size ranges, which significantly increases their surface area. As a result, LIG provides a conductive platform with a large electroactive surface, extremely low production cost, versatile shape design, and, importantly, great potential for functionalization. LIG electrodes can be modified with biological molecules, metal nanoparticles, or polymer coating. This versatility is why I chose LIG as a base material for my project. The second critical element is aniline polymerization. Polyaniline is one of the well-known conductive polymers. It exists in three oxidation states, and each with a distinct color. Polyaniline can be synthesized via chemical or electrochemical polymerization. However, only the emeraldine salt is conductive form. So, to achieve this conductive state, doping is required. Typically, this doping is acidic environment. This requirement for low pH limits the application of polyaniline, especially in biological system or environmentally sensitive settings. So with this knowledge, the object of my work becomes clear. I would like to develop a multifunctional sensing platform based on low-cost LIG electrodes modified with polyaniline synthesized under neutral pH condition for use in biologic application. To achieve this, we performed electropolymerization of polyaniline using PSS as a dopant in a PBS solution to maintain neutral pH. We use cyclic voltamperometry for the polymerization. LIG served, of course, as the working electrodes, but also we designed a counter electrodes based on LIG, and we also used standard silver chloride electrode as a reference. All experiments were conducted in a droplet of only 50 microliters, which is another advantage of this platform. It requires a very small sample volume. We employed several characterization techniques to confirm the successful formation of polyaniline. SEM imaging showed a fiber-like morphology on the LIG surface, indicating polymer growth. Usually, we can see the polyaniline as a fibers or as a nanograms. Here we have the fibers. Raman spectroscopy revealed change in D and G bands intensity ratio, where D bands correspond to disordered carbon and G bands to graphitic carbon. This change supports the successful modification of the LIG surface. FTIR spectroscopy clearly showed characteristic absorption bands corresponding to the polyaniline, further confirming the success of polymerization at neutral pH. Okay, once the electrodes were ready, we test them as a sensor. I investigate two beta blockers, metoprolol and propranolol, using differential pulse voltamperometry with various concentration dissolved in PBS. So we are still in the neutral pH. We expected improved sensitivity due to the increased electrochemical surface area provided by the polyaniline layer. As shown, the pani-coated electrodes produced a stronger signal compared to the bare LIG, but in the case of metoprolol, the improvement was modest. So we conduct similar experiment with propranolol. For propranolol, the enhancement was more visible. The polyaniline LIG electrodes provided significantly better model fitting and 5 times lower limit of detection. This is very promising results for us. Also, based on the literature, we also test the polyaniline LIG electrodes as a pH sensor. We measured the open circuit potential over 2 minutes across solution with pH ranging from 1.6 to 13.2. The polyaniline modified electrodes exhibit excellent stability with a standard deviation of only approximately 0.1%, allowing them to function effectively as pH sensor across the entire pH range. Interestingly, even bare LIG, what is not typical because this is just a graphene, show good performance as a pH sensor. Of course, the stability was definitely lower. It was around 2% if we will talk about standard deviation, but still this is very good result. This is still acceptable for practical use. Both electrodes exhibit good model fitting. Yes, so this is very nice results, especially when we will think about the next steps of our research. So, to summarize, we successfully electropolymerized aniline at neutral pH on LIG electrodes, and only on LIG electrodes, because we also test glassy carbon electrodes, gold electrodes, and we did it only on LIG electrodes. Also, We test these electrodes as a beta blocker sensors and pH sensors, demonstrating promising results in both applications. This gives us a green light to proceed with the next stage of this project, designing a multifunctional sensing platform with small portable potentiostat, because we want to use this device also in typical environment area, and not only in the laboratory. So at the end, I just want to say that this work was supported by the National Research Center, and I really thank you for your attention.
Thank you very much. I'd like to open the floor for the comments and questions. I can see a question in the chat. It is, could this modification strategy be extended to detect other analyte classes beyond beta blockers and pH?
Yes, I think that definitely we can find different application for the polyaniline modification. We use beta blockers because it was our first analytes which we have in the, okay, maybe not we have that in the laboratory, but we also work with beta blockers with different projects. This is the reason why we choose it. But for example, we can test also different analyte, because the huge advantages of the polyaniline is that usually the electrochemical active surface area is increasing. So it should be connected with the lower limit of detection. So yes, we can. We also use the polyaniline, for example, to cover it with gold nanoparticles, to use it to create surface enhanced Raman spectroscopy. So we can find a lot of different applications for the polyaniline.
Thank you. Let's bring the discussion to the chat afterwards. And I'd like to invite our final speaker, Phuong Anh Tran from Hanoi University of Science and Technology in Vietnam.
Yes,
please take it away.
Here. Could you hear me?
Yes, we can.
Yeah, okay, let me share my screen.
The screen is visible, not yet in full screen mode yet.
Oh, okay. Did you guys see the screen now?
We can.
Yes.
Okay, thank you. So, hello everyone. My name is Phuong Anh, and I'm currently a master student at the University of Rostock in Germany. So today I would like to talk about synthesis and photocatalytic application carbon dot polymeric carbon nitride composites. So environmental pollution is still a problem we are facing now. And in this research, I focus on treating water pollution. Some common pollutants such as pharmaceutical and personal care products, persistent organic pollutant or heavy metal might well known for you all in this area. So there are several treatment methods currently used, such as adsorption, filtrations, distillation, but in this study, I focus on advanced oxidation process or photocatalytic degradations. And I work on synthesis and develop polymeric carbon nitride material. So photocatalytics is a photo-induced redox process based on the band structures and ability to transport charge carriers of semiconductor catalysis. And in 1970, titanium oxide has been found, but in 2009, carbon nitride had been reported as a metal-free conjugated semiconductor photocatalyst. under visible light illuminations. It's based on our solar energies compose almost visible light. So that's why this is widely studied in this year. So to introductions about the carbon nitride is a two-dimensional structure material with moderate band gap and good chemical thermal stability. However, it still has some drawback like limited absorption of visible light, low surface area, and high rates of electron-hole recombinations. So recently, carbon dots have gained attention due to their strong photoluminescence, low toxicity, wide light absorption, or good upconversion properties. So that's why I choose adding carbon dot to carbon nitride to improve its photocatalytic performances while keeping the material still metal-free. So now let's move on to the methods I use to prepare this material. First is carbon dot and carbon nitride I synthesize separately. The carbon dots are made by using a simple hydrothermal method at 200 degrees for 2 hours with the lemon juice and urea as the starting material. Meanwhile, the carbon nitride is synthesized by thermal decompositions of urea at 550 degrees. So after synthesis, both materials are characterized and stored for the later experiment. And once I have carbon dot and carbon nitride, the next step is I'm going to loading the carbon dot onto the base material, which is carbon nitride. So I have tests with 4 different methods for this step, including physical mixing, hydrothermal treatment, acid exfoliation, and thermal treatment. But the result I get that the thermal treatment gives the best performance compared to the other, and also is the most easier way to synthesize this composite. So the way I do it in detail will be in the picture like this. Urea first dissolve in water, then a certain amount of carbon dot or directly lemon juice is added. The mixture stirred for 2 hours and then evaporated to get the solid form. Then that solid will be heated at 550 Celsius for 2 hours in air. And after that, a second heating step is done at 500 degrees for 5 hours in argon gas. And after all, I guess the carbon dot and carbon nitride composites. So moving on to the characterization of material, first is the carbon dots. After hydrothermal process, the result solution had a yellow-brown, maybe a little bit green color, but under UV vis at 365 nanometer, it shows a bright blue emission, which is a typical optical properties of carbon dots. And from the transmission electron microscopy image, I observe well dispersed carbon dot at the nanometer scale, and in some dark spot show higher carbon concentration, but overall we can observe clearly dot in the range of 1 to 10 nanometer, confirm the successfully synthesis of carbon dot. And the UV vis and photoluminescence spectra also confirm the optical properties of the material. It shows good absorption at around 330 nanometer and a strong emission in the range from 400 to 450 nanometer. And the FTIR spectra and XPS result also reveal that carbon dot contain abundant functional group such as hydroxy, carbon C, carbon E, or amide, And this indicates successful nitrogen doped on the my carbon dot. And as you all know, nitrogen is known for its high electron affinity, so which is I expect to enhance the electron capture ability of carbon dot. So move on to the carbon nitride material. It also show characteristic functional group of triazine rings or CN heterocycle in FTIR spectrum. And also the surface area analysis show that the composite material after 2-time heating has the highest surface area, and the increase of pore size might provide more active site for the photocatalytic reactions further. And next is the result for UV-VSDRS and the photoluminescence spectra of carbon nitride and the composites. And it shows that the band gap degree after adding carbon dots. Here I have the band gap of carbon nitride, the pure one, and the composites after I add carbon dot. And the intensity of photoluminescence also decrease when carbon dot added to the carbon nitride, and it dropped further after the second time heating. And this degree suggests that the material can reduce charge carrier recombination rates, improving photocatalytic performance. So based on the characterizations result, the photocatalytic reaction was set up as in the slide. So a low intensity 150 watt of xenon lamps with a filter was used, so that I only use the visible light range for these reactions. And the reactor was carried out at room temperature with a water cooling coach. And I used 30 milligram of catalyst to treat with the 40 milliliter ciprofloxacin at 20 ppm. And the result was measured by using HPLC. So for overall, it's degradation of ciprofloxacin in comparisons for several material in figure 11. So in the darker part of the figure 11 is for photocatalytic part, and for the lighters is for absorption. So with a high amount of carbon dot or the lemon juice, the material show strong absorption up to around 80%. Therefore, a sample with lower carbon dot contents or lemon juice was selected for the second heating, as the green and the blue one here. So the results show that using carbon dot lead to the lower absorption than lemon juice. So the photocatalytic activity increased significantly to around almost 100% degradation of ciprofloxacin after 5 hours under visible light irradiations. So here in figure 12, I have picture of photocatalytics of ciprofloxacin using carbon nitride and the composite carbon dot carbon nitride at a lower contents of carbon dots. So for conclusions, carbon dot, carbon nitride, and composites were synthesized by simple thermal methods from fresh lemon juice and urea, and carbon dot was successfully incorporated into the surface of carbon nitride and functioned as an electron acceptor that reduce electron hole recombination risk and enhance photocatalytic properties. With rising amount of carbon dot added, absorption of ciprofloxacin increased significantly. The photocatalytic degradations of ciprofloxacin revert that 0.5% of carbon dot loading on carbon nitride after 2-time heating treatment had the optimal performance, which removed 96% of ciprofloxacin in 5 hours under visible light irradiation. And here I have some outlook for further develop of this area. So maybe in the future, I will try to develop the material to reduce the photocatalyst time and optimize the photocatalytic condition like temperatures, air conditions, like adding oxygen into the reactor, or I would change the light power to see its effect, or maybe the amount of catalyst pollutant concentrations. And I also going to propose the pathway of ciprofloxacin during photocatalysis process by using time-of-flight mass spectrometry. Thank you for your attention, and I also want to thank you by support of Phuong Anh projects. Okay, that's all.
Thank you very much for your presentation. I would like to open the floor for the questions and comments you may have. I can see a question from the audience, please. You can ask it now.
Hello, I have one question. What is the recovery rate of these composites from water?
Could you repeat your questions?
Maybe I can describe this in chat if you want.
It's okay. I can hear it clearly, so.
Okay.
You can say it again.
Okay, I can repeat. What is the recovery rate of these composites from water? I mean the carbon dots or the other composites.
Evaporated, you mean?
Yeah.
Yeah, at the beginning, I synthesis is all in the water. So after all, I want to get the solid form. That's why I have the evaporated stuff.
Okay, thank you very much for your answer.
Yes, thank you for your questions.
Thank you very much. Please continue in the chat if you have any more questions. And I would like to say thank you to all our speakers for the insightful presentations and participants for this session. Please enjoy what is left of our break. I'm sorry we seem to have accumulated a bit of delay. So this is 2 minutes to the next session. Please keep in mind that at 10:30 UK time, 2 parallel sessions, 6 will start. The session 8. A will be continued here, and for the session 6B, you need to enter separately through the conference website. Welcome to session 6A. Thank you for joining in. For the people joining in the meantime, my name is Edyta Raczok, and I will be chairing this session. I'm looking forward to hearing from our speakers. We are scheduled for 5 12-minute live presentations. The remaining 3-minute slot is for any questions you may have. And first, we will hear from Natalia Małecka from Wrocław University of Environmental and Life Science in Poland. Please take it away.
Hello, everyone. I hope you can hear me. I will try to share my screen with you. Okay. Just a moment. And please let me know if you can see my presentation.
We can see it.
Okay, so hello everyone. Once again, my name is Natalia Małecka, and I am first-year PhD student. And today I would like to present to you my topic, which is the role of elongator as a translation regulator during plant photomorphogenesis. So our research group is focused on the protein complex, which is called elongator, and it is a complex that is composed of 6 subcomplexes, among which there is ELP3, which carries out enzymatic activity of the complex. And nowadays we know that this complex occurs among all eukaryotes, and its structure is conserved. Although its function varies between different kingdoms. So, for example, in fungi, this complex's activity is modification of some tRNAs, while in animals, for example, in humans, the mutations in gene that encodes this complex causes some neurodegenerative diseases, such as familial dysautonomia. In plants, the role of this complex is unique, and it varies because of the localization within the plant cell. So we have 2 subpopulations within a plant cell. The first one is nucleus, where the transcription occurs, and the second one is cytoplasm, when the process of translation occurs. So this complex has 2 activities. It participates in regulation of transcription, mostly due to the histone acetylation, and also it participates in the regulation of translation by uridine modification. And uridine is a uridine that is at the position of 34 of the anticodon tRNA loop. And this modification proceeds in 2 steps. So in the first step, elongator attaches a carboxymethyl group to the carbon at the 5th position. And the second stage of modification is carried by a sulfo transport pathway, which consists of such proteins as URM11, 12, and CTU1 and 2. And it is about replacing oxygen with sulfur atom. Among elongator's role in plants, there is also one role that is participating in scoto and photomorphogenesis. And I would like to quickly remind you what is this process is. So basically, scotomorphogenesis is development of plant in darkness. So these plants are characterized by elongated hypocotyls and closed and undeveloped cotyledons. While exposure to light, plants changes their growth pattern, their hypocotyl gets shortened and cotyledons opens, and they are developed and photosynthetically active. And this process development in the light is called photomorphogenesis. So multifunctionality of our complex elongator, it is for us a challenge when it comes to understand by what exact mechanisms this complex influences plant development. And there were 2 publications. In 2018, there was a publication that suggested that elongator is necessary for proper hypocotyl development of plants. and this was justified by its role in histone acetylation, while 1 year later, another research group published an article when they suggested that proper leaf development that elongator influences proper leaf development due to the modification of wobbuiridin. So it's the other translational activity. So our research group performed a comparative experiment. This is a phenotypic experiment. We included couple plant lines such as wild type, which is Columbia 0, such as elongator mutants, and our double mutants. So those proteins basically participate in wobbuiridin at the second stage of translation. So our hypothesis was that the common features between our elongator mutants and our double mutants will give us the information what aspects of photomorphogenesis is influenced by wobbuiridin modification. So we performed measurements, and when it comes to hypocotyls, we observed that only elongator mutants has significant change, and other plants, they don't vary between themselves. But when it comes to cotyledons, we saw an interesting pattern that is that every plant lines, a wild type elongator and at least one of the double mutants varies between themselves. And also the phenotype of the double mutants is in between the previous lines. And this is logical because our double mutants has only one modification that is performed by elongator, but elongator mutants don't have any of the modifications. So my studies focus on proteomic analysis. The first step of this analysis was protein extraction. I extracted proteins by using lysis buffer containing SDS, and I also created a standard curve to assess the concentration of the proteins. And also because for further analysis, we're using chromatographic methods. Our samples were fractionated on SDS page to obtain the best signal to noise ratio. Later, we sent our samples to laboratory when they performed liquid chromatography with mass spectrometry, and we are able to identify 4,200 protein groups, which were representing approximately 30% of all products present at this stage of plant development. We also performed PCA analysis, and we found out that mostly our samples, they group very well between biological group. And when it comes to elo mutants, we found out that over 300 protein, they have significantly altered scale of synthesis. On the left side, I showed you all proteins that had this altered scale. And on the right side, I put only those with significantly changed scale. We performed also ontological analysis within increased and decreased protein. And to sum up, we found out that this mutant has the biggest problem with photosynthesis and with translation process. We did the same for WRM mutants. This time we found out that this mutant has over 600 proteins with a significant altered scale of synthesis. And we performed the same ontological analysis. When it comes to this mutant, we found out that the biggest problem this mutant has is with energy. seed development, and also protein modifications. When it comes to our research plans, we are planning to compare this proteomic analysis with transcriptomic analysis and metabolomic analysis to gain the full spectrum of what is going on in a cell and what is elongator's role in it. And also we want to study separately what is going on in a different part of our plants to know exact mechanisms that elongator influences our process of photomorphogenesis. So this is my references, and thank you very much for attention. And if there are any questions, I will answer them. Thank you.
Thank you very much for your presentation. I'd like to open the discussion. If you have any questions, any comments. Okay, I can see one person from the audience, please.
Yes, hello, very interesting research. I have a question about mutants for research. Are they commercially available or did you create them yourself?
No, those mutants are available. We bought it from a company and then we just gained another generations of these plants.
Okay, thank you very much.
Thank you.
Professor Axman, please.
Hello, I also agree that the presentation was very nice and interesting. You said that mutants had some problems with photosynthesis. Do you possibly know why? I mean, do you know if there is a problem with chloroplast development or with photosynthesis performance or something like this?
Because we already performed another experiment, which is transcriptomic experiment, we saw a lot of genes with altered expression that are responsible for chloroplast development. But also we see some both genes and proteins that are changed that are responsible for this structure of these photosystems.
Okay.
So we were even performing one experiment to find out the quality of this process, but we wasn't able to tell after first experiment what is altered in our mutants. But we also know that there's oxidative stress, so that can be some problems with this structure. It just needs further studies.
Thank you very much.
Thank you.
Thank you. Any other questions, please ask them in the chat. And next up, thank you very much for your presentation. Thank you for the questions. And next up, we have Lizaveta Rusakovich from Intercollegiate Faculty of Biotechnology of the University of Gdańsk and the Medical University of Gdańsk in Poland. Please, the floor is yours.
Hello. Nice to be here. And as mentioned, my name is Rusakovich Lizaveta, and today I will tell you a little bit about jojoba and lipazes located in its seeds. So research was done in the University of Gdańsk in the Laboratory of Plant Biochemistry under the supervision of Professor Antoni Banyś and Dr. Katarzyna Wierzchowska. So lipazes are enzymes found throughout nature. First isolated from bacteria in the early 19th century, they have since attracted growing scientific interest due to their unique and versatile properties. These enzymes are capable of hydrolyzing carboxyl esters of long-chain acylglycerols, typically containing more than 10 carbon atoms. So lipases represent a major fraction of enzyme industry. They are versatile and can perform both hydrolysis and synthesis reactions, which can be chemio-rigid and enantioselective. Lipases can also perform esterification and transesterification reactions in the water-restricted environments. Due to its high versatility, lipase enzyme has applications in various fields ranging from the food industry to pharmaceutical industries, and mainly in the production of biofuels. But despite the extensive range of microbial lipases, the use of those enzymes on an industrial scale is still limited due to their high production cost. However, there are plant lipases. For example, tag lipases are mainly concentrated in seeds as an energy provider. They are stable in pH range of 4 to 9 and temperature range of 25 to 60 degrees Celsius. Lipases present in the crude extract from plant sources can already directly catalyze hydrolysis and synthesis reactions of lipids. Unfortunately, very few plant lipases have been explored due to the complications of purification steps. So I decided to start my research with one of the most intriguing plants, jojoba, since it is the only plant known to store wax esters instead of triacylglycerols in its seeds. Jojoba is a perennial shrub that grows naturally in the deserts of southwestern North America. Jojoba wax esters are valuable compounds with numerous important commercial applications in the cosmetics and pharmaceutical industries. In oilseed plants, the accumulation of storage lipids starts with cleavage of an ester bond between glycerol backbone and fatty acids. In contrast, in jojoba wax esters are hydrolyzed by jojoba lipase, also known as wax ester hydrolase, and produced are fatty acids and fatty alcohols. And where the idea is coming from. In 2008, there was a project ICON, and the main goal of this project was to transfer the biosynthetic pathway responsible for wax ester production from jojoba into industrial oilseed crops. And targeted species included Cramba abyssinica, Camelina sativa, and Brassica carinata. And their seed oils are already widely utilized for industrial application. And the project achieved its main goal, successfully generating transgenic lines of these crops capable of producing wax esters. However, it was observed that the germination rates of transgenic seeds were lower compared to those of their wild-type counterparts. This impaired germination was hypothesized to result from the inefficient hydrolysis of wax esters by the endogenous lipases naturally present in these species. Initial experiments characterizing lipases from the microsomal fractions of germinating jojoba seeds, as well as from the germinated seeds of the transgenic oil crops, did not reveal significant difference in wax ester hydrolysis capacity between jojoba and the recipient plants. So in the current project, we have successfully developed a method for isolating membrane fractions of oil bodies containing active lipases. And the next phase of this study will focus on characterizing the biochemical properties of these lipases and comparing them with those of lipases located in microsomal fractions. So we can see microsomal fractions are subcellular components derived mainly from endoplasmatic reticulum, and oil bodies are small particles formed by monolayer and containing storage lipids. And to isolate those oil bodies, jojoba seeds were cut into small pieces and homogenized in an extraction buffer. After that, extracts were centrifuged and an upper layer containing oil bodies was collected. The procedure was repeated 2 times, then oil bodies were purified by the ethyl ether and frozen at -80 degrees Celsius. Suitable portions of that extract then were lyophilized and the reactions with radioactively labeled substrate were performed. After the extraction of products, the mixture was separated by thin layer chromatography, and lipase activity was assessed by quantifying the radioactive free fatty acids released from added radioactive triacylglycerol. And quantification was done by using electronic autoradiography or instant imager. And the first step in characterization of lipases located in oil bodies was to see how lipase activity is changes throughout germination process. So as you can see, it only starts to really kick in after 4 weeks of seed development, and here we can see elevated levels of activity, and then after this it stays at the same elevated level. Another important characteristics of lipases is their stability, temperature stability. So to check this, lipases were incubated in 60 degrees Celsius for 15, 30, and 60 minutes. First, before lyophilization, that means when lipases were still submerged in the extraction buffer, in the buffers that were extracted in, and as you can see, the activity diminished, and but when we performed the same experiment, lipases were incubated at 60 degrees Celsius for up to 1 hour, but after lyophilization, when oil bodies were dried and without water, it had a different opposite effect. It boosted the activity of lipases. And to check a wide range of pHs, were used such buffers as citrate, phosphate, trace, and 2 salts of sodium. And here you can definitely see that the optimal pH for lipases activity is 6 in citrate buffer. Also, how this reaction goes through time, you can see that the longer it incubated, the higher the activity, but after 2 hours, the differences are not really that big. So I decided to end reactions in my later experiments after 2 hours of incubation. And another important characteristics is at which temperature is the optimal conditions for reaction, and for lipases located in oil bodies, it is 30 degrees Celsius. Also, reaction saturates approximately at 100 nanomole of triacylglycerol when we use equivalent of oil bodies equivalent of 12 microgram of protein in those extracts. So lipases have quite a big capacity of converting triacylglycerols into fatty acids. And interesting thing starts when we go to ions. So normally ions are capable of boosting activity of different enzymes. And here I performed several experiments with addition of magnesium and calcium ions. And one experiment were performed in citrate buffer, that is optimal conditions for activity, and as I said, was performed in HEPAS buffer at pH 7.5. And as you can see in citrate buffer, the difference just weren't that statistically significant. It quite a large differences we will see in HEPAS buffer and not in citrate buffer. And indeed, in HEPAS buffer, the activity is boosted up to 4 times in calcium with addition of calcium ions. And this dichotomy is continued in terms of wax hydrolyzation. So we can see that in citrate buffer, at first 2 weeks of development, 7 days and 16 days, we do not see any activity in terms of wax hydrolyzation. But when those oil bodies incubated in HEPAS buffer in pH 7.5, the activity at 7 days and 16 days is present. So here we come to conclusion, and lipases of oil bodies of jojoba seeds are most active in the latest stage of seed germination, 4 weeks and later. Lipases of oil bodies of jojoba germinating seeds are highly stable in conditions of limited water access, so when they were lyophilized and incubated in 60 degrees Celsius. So tested lipases most active at pH 6 and temperature 30 degrees Celsius. And a different capacity of wax ester hydrolysis at those different pHs, as well as different reactions for magnesium and calcium ions addition in those two pHs, suggests that there is different isoforms of lipases in the tested membrane fractions. And this further confirmed by the differences in research done almost a decade. More than a decade before me. When our laboratory also participated in research about microsomal membranes of jojoba, and their results, those results suggest that optimal conditions for reactions of lipases located in microsomal fractions are 60 degrees Celsius and pH 7. However, mine suggests that optimal conditions for lipases located in oil bodies are 30 degrees Celsius and pH 6. It's further boosted theory about existing of two different isoforms of lipases. And my further goals will be digging deeper into this theme. Trying to assert how other similar changes in the other tested lines in the project icon, like Crambe and Camelina. And I would like to see if this tendency of different isoforms is retained in other plants. So thank you for your attention. This will be all from me. If you have any questions, you can ask them now.
Thank you for your presentation. We are waiting for the questions from the audience. And I can hear, okay, I can see a comment. It's from Lidia Banaszczyk. A great presentation. I have a question. Are you considering using alternative substrates, for example, wax esters, in future assays to better reflect the natural conditions under which these lipases operate?
Yes, I already performed several tests on monoacylglycerols, diacylglycerols, as well as different wax esters, and well. There are differences between different wax esters. For example, I already know that lipases from oil bodies prefer element 1 or 8. Longer and unsaturated fatty acids and not saturated. Yeah, like it is a part of overall characterization.
Thank you very much. Professor Axman, please.
Yes, hello. Thank you for a very nice presentation. I am wondering if you was thinking about commercial possibility of your research. Is it possible that your research will improve somehow lipid production for a commercial scale or something like this? Because we know that plants waxes and plants lipids are very popular now, and that they are very valid also. So it would be nice if we could improve commercially available plants to if we could ask them to produce more such substances. So could you give us some thoughts about commercial potential of your research?
Of course. Commercial potential, well, first of all, wax esters are used in cosmetics and pharmaceuticals industries. And for now, the only plant source is jojoba. Other than that is microbes that are quite costly. And one of the bigger goal is to give some insight on how those lipases are working inside of jojoba, so we can transfer them into other species that are not that are just faster growing, because jojoba takes quite a long time. It is a shrub in general. So yes, it is because plant lipases unfortunately are not that good characterized in general. So this is one first little step into, I hope, something that will grow into good mutant lines of those industrially available plants.
Thank you very much. I hope you will succeed.
Thank you.
Thank you. And one more question we have from Ms. Adrianna Kosiruk, please.
Hello, thank you for your presentation. I have one quick question. How large was the sample? Could you tell me?
Sample of what? Of jojoba?
Yeah.
I work on oil bodies isolated from 2 to 3 seeds. I achieve isolation extracts from them are quite enough to perform several tests. So I probably already used 15 seeds in general, because they are big and contain a lot of oil bodies. You can see here those are jojoba seeds, flax seeds, and crumpet seeds. And jojoba seeds are quite big.
I see. Thank you for your answer.
You're welcome.
Thank you everyone for the discussion. Thank you for the presentation. And moving on to our next presentation, we will hear from Katarzyna Wierzchowska from Warsaw University of Life Sciences in Poland. Please, the microphone is yours.
Hello, everyone. Please let me know if you see my presentation.
Yes, we can see it.
Okay, great. So hello, everyone. My name is Katarzyna Wierzchowska, and I'm from Department of Chemistry from the Institute of Food Sciences at the Warsaw University of Life Sciences. And today I would like to present some of the results in my presentation entitled Microbial Lipids from Jarowia Polityka, a Sustainable Approach to Vegan Food Innovation. And to meet the needs of growing population, it's essential today to integrate the principles of a circular economy with also increased food production. And to meet these challenges, today various strategies have been developed, and mainly because biotechnologies based on microorganisms have a long story in the food industry. Oleaginous yeast are considered as one of the tools for sustainably maximizing food production, and mainly because of their ability to accumulate more than 20% of lipids in dry biomass. And those cellular lipids are called, as you can see, single cell oil, SCO. And the main goal of the experiment was to attempt to develop the concept for the application of oleogenous Jarowiali politica yeast biomass and extracted from it microbial oil as a vegan food additive. And this is the first study in which to incorporate yeast lipids into plant-based cheese analogs using both extracted cellular lipids and whole yeast biomass. And the material for my study was an oleogenic yeast strain from the collection of industrial microorganism culture from the Institute of Agricultural and Food Biotechnology in Warsaw. And all cultures were conducted in laboratory bioreactor in media with the presented on the slide composition, and it was for 3 days at 28 Celsius degree with 5% of addition of the selected carbon source, and also waste substrate were used in yeast cultures, such as the waste rapeseed oil after cod frying from the fish processing company, and also molasses was used, obtained from the sugar refinery as the carbon sources. And lipids extracted from dried biomass was extracted by Phuong method, and then it has been analyzed, including microscopy using scanning confocal laser microscope, also fatty acids analysis, sterol analysis, determination of residual solvent used for the extraction, pressure differential scanning colorimetry used to evaluation the oxidation stability of the extracted lipids, and analysis of the polycyclic aromatic hydrocarbons content was done. So the whole experiment had 4 stages. Yeast were cultivation in media with 4 different carbon sources. It was glucose, molasses, cold press rapeseed oil, and post-frying rapeseed oil. And then the biomass was analyzed, as I said, microscopically, and also the quality and the composition of the analysis was carried out at each stage, determined the elimination of culture variants from which microbial lipids were extracted, and it was ordered to select one microbial oil in the final step of the experiment, which could become an ingredient in the recipe of the selected food product. And here on the slide, you can see photographs of yeast, Jarowiali politica, from cultures with various carbon sources. And those red dots are the stained cellular lipids inside the cells, inside the Jarowiali politica cells. And based on kinetic parameters of the culture, we can say that in the medium with glucose, which is conventional carbon source, the best strain growth was observed, but unfortunately cellular lipid content in dry biomass was very low. It was only like 8%, as you can see it in the table 1. But is it worth noting that cultures with hydrophobic carbon sources resulted in the most efficient biosynthesis of microbial lipids, and the lipid content was 25% in the case cold press oil medium, and 35% for post-frying oil medium. And considering practical application, is most reasonable to use microbial lipids obtained by culturing Jarowiali politica in media containing hydrophobic carbon sources more than sugar-based media, because we can obtain greater amounts of this ACO, of this oil. And generally, it can be assumed that fatty acids with the highest proportion in cellular lipids of Jarowiali politica were oleic, linolenic, and palmitic acids. And in glucose, generally in glucose medium, microbial lipids had the highest proportion of saturated fatty acid, but the lowest proportion of unsaturated fatty acids. But in hydrophobic media, ACO have a high percentage of unsaturated fatty acids. So we can say that when we're using plant oils as a carbon sources, not only, as I said, the efficiency of biosynthesis of microbial lipids was higher, but also the fatty acids profile was more favorable, let's say, from a nutritional point of view because of this higher percentage of unsaturated fatty acids. The lowest amount of sterol has been found in SCO from culture with post-frying rapeseed oil. It was only 4 milligrams per gram of oil. But for cultivation with molasses and cold press oil, the sterol content was similar. It was 7 milligram per gram of oil. And what's more, phytosterols, including beta-sitosterol and campesterol, dominated the SCO from media with cold press oil and post-frying rapeseed oil. And it's in contrast to use of molasses as a substrate, which promoted the biosynthesis of ergosterol, which was the dominant sterol in this medium. In oil from this culture. So also we can say that by selecting substrate, we can obtain oil from a different sterol profile. And as you can see on the figure 5, the highest oxidative stability have been observed also for SCO from cultures with post-frying rapeseed oil. And what's more, due to the use of waste substrate, mainly molasses, but mainly post-frying rapeseed oil, also the analysis of content of polycyclic aromatic hydrocarbons in the extracted lipid samples was carried out. And as for the highest permitted level of, as you can see it in the table 5, a level of benzopyrene and some of benzopyrene, benzoanthracene, benzofluoranten, and trizene, all analyzed samples of analyzed several lipid samples met the requirements included in the regulation. Similarly, they met the criteria in terms of the residue of solvent used for the extraction, and it was hexane in this case. I would like to add that the regulation I mentioned applied to edible oils and fats, because we still don't have any regulation directly for lipids extracted from yeast. Plant-based analogs of camembert type cheese were selected as a group of products that was finally enriched with SCO, with microbial lipids, and based on the previous stages of the experiment, lipid extracted from yeast cultured in media with post-frying rapeseed oil were selected, mainly because, as I said, high content of unsaturated fatty acids and high oxidative stability. And then this SCO, this microbial lipids, was added to this product in 2 forms: extracted from biomass microbial lipid and biomass content this microbial oil. And the addition of microbial oil or biomass, as you can see on the photographs, didn't significantly affect the appearance of the plant analogs, but after 14 days of ripening, the protein, fiber, and dry mass content of the product was highest in the analog with the addition of yeast biomass. But it should be said that the SCO enriched analog had the highest fat content in the product, but it was still lower than, let's say, in the classic camembert cheese. So there was also evaluated the quality of lipids present in the camembert analogs, and what's important, the addition of microbial oil resulted in increase of the oxidative stability of the fat fraction in the product compared to the control without any additives. So it was positive result. And let's go to the conclusion. The study emphasized the advantages of microbial lipids, such as its nutritional favorable composition and its potential for sustainable process of culturing yeast as a valuable source of microbial lipids. And also the study presented a solution for the management of waste substrate to obtain SCO. And by selecting appropriate substrate, it was also possible to obtain oil with desired yield, composition, and high oxidative stability. And we proposed a new food product, a plant-based analog of camembert type cheese with the addition of oleaginous CS biomass or microbial lipids extracted from it. And this concept is an example of a solution in food technology that aligns with the principle of circular economy. And what's important, the team in which I worked received a patent about method of producing microbial oil from cultured oleogenic microorganisms in specific medium. And we made another patent application last year about method of making a plant-based cheese alternative with mold growth. And now, thank you for your attention.
Thank you for your presentation. Let's hear questions from the audience. Please, Dominika Kościńska.
Yes, hello. Thank you for your presentation. This research is very promising and future-oriented. I have a technical question. In my own work, I use algae, which sometimes tend to grow in co-culture with other organisms, such as bacteria or protists, which can interfere with experimental outcomes. I wanted to ask you about your microorganisms. Do you sometimes have any problem with culturing, such as contamination with other organisms?
To be honest, we don't have such problem because Jarowia politica is able to grow in such various conditions that I think not any microorganism has such abilities because they so no, we don't have such problem.
Okay, thank you very much.
Thank you for your question.
Another question, please.
So it would be from me. Hi, and thank you for the speech. I have one question because you worked on Jarowia politica, but can you share that if it was a pH-sensitive strain of this fungi? Because I know from my own work that Jarowia politica is mostly pH-sensitive, but was your strain sensitive to pH?
No, our strain is totally not sensitive, and as I said before, it's able to grow in a wide range of temperature and also pH value. So it's easy to culture.
Okay,
but
thank you.
it's wild type strain. It's wild type strain, not genetic modification.
Okay, because I thought that maybe you can increase the amount of oil in a cell by adjusting the pH, but if it's not sensitive, it wouldn't work.
Yes, probably not. And during the culture also, this strain produce also various fat acids. So that's why the pH is low during the culture. So I think it's not necessary to decrease it.
Okay, thank you.
Thank you.
Professor Wiktorska, please.
Hello, thank you very much for a very interesting presentation. And I wanted to ask you about confocal microscopy because this is my favorite technique. But then I saw the other results that raised my concern. I speak about polycyclic aromatic hydrocarbons because I wasn't aware that we can that these are carcinogens, right? So that they are present, like traces, they are present in the food. And I don't understand why there is such a huge amount of this compounds and lipids that were cultured in media with molasses. I would rather think that the highest amount would be in post-frying oil, right?
Yes,
so
me too.
do you have any clue?
Me too, and probably it's why because before we adding the molasses to the medium, we prepare it for like we hydrolyze it, and then it's heating. So maybe during this process, that's why we have such compounds in oil. But I'm not sure, to be honest. I'm also was surprised.
Okay, thank you very much.
Thank you.
Thank you everyone for the discussion, and thank you for your presentation. And now, please welcome to the microphone Weronika Chmura from Intercollegiate Faculty of Biotechnology of the University of Gdańsk and the Medical University of Gdańsk in Poland. Please, the floor is yours.
Can't hear you.
I'm really sorry, I don't know what to do. It's not my computer and I have really a huge problem.
If it is a problem with sharing your slides, then you can send it to the email of the organizers. So due to the technical issues, I propose that we turn our attention to the final speaker from the schedule, Marcin Borowicz from Intercollegiate Faculty of Biotechnology of the University of Gdańsk and the Medical University of Gdańsk. And we will continue with the previous speaker at the end of the session. So please take it away.
Can you see me, hear me, and see my presentation?
Yes, to all the three.
Perfect. So my name is Marcin, and today I have a pleasure to present you a story about the tylosins, and especially a case from the soft rot Pectobacteriaceae. I'm from Laboratory of Biologically Active Compounds at the Intercollegiate Faculty of Biotechnology of University of Gdańsk. So yeah, the second part of my title is soft rot Pectobacteriaceae, and these are the group of plant pathogens which are causing many problems, mostly on potatoes, and you can try to imagine the world without potatoes, without fries, chips, and everything. It is hard to imagine. And not only there are plant pathogens, but they are also quite versatile in the environment. Then can live in rivers, lakes, on fields, almost everywhere. And this is why they are quite interesting as a model to study interaction between the plant pathogens, other bacteria, and of course plants. So my PhD project initially should be about the prophages in that bacteria. Prophages are like phages, which are viruses of the bacteria that resides in the genome of the bacteria, and I was trying to induce them from the genome. However, when I was using the very common inducer, which is mitomycin, it turned out that they are not producing any phages. However, they are producing something what is similar to just the phage tail. So phage tail is this part of the phage. It does not have a head, and the bacteria are using this structure for their own advantages. And even if we go further to the genetic level, in the genome of the bacteria, they're also having almost all structural parts of this phage. However, they do not have genes responsible for the head synthesis, which means that the structures cannot replicate in the environment. So this is the example of the structure which are called phage tail-like particles, and they are very, very interesting. However, today I will be focusing only on the tylosins. There are two types of tylosins, and I will be telling you about the type R tylosins, which are contractible but not flexible, and are morphologically and also genetically similar to the myophages. So this is how they look like. They are very beautiful, I would say, because you can see that they have a long part, and then there's a base plate with the fibers, which are very like responsible for the recognition of the target. On the picture B, you can see that they can really contract. So this is contracted sheet, and here is a tube which is normal inside this sheet. You can see it here that there is even a hollow part inside this contracted sheet. And on the lower part, you can see the pictures from the atomic force microscopy. Here there is this spiral structure on the sheet, which is also like showing that they can really contract. In the picture E, you can see that it is partially contracted, showing a bit of the tube. And the picture F is very interesting because here you can see a spike, which is like responsible for the mode of action of the structures, which I will show you in a moment. But before, how they work, how they are produced. So some of the bacteria have the genes responsible for their synthesis, and under some kind of inducer, it can be, as I already showed, mitomycin, or for example, even reactive oxygen species, they can produce tylosins. And this is very, very interesting, because to produce tylosins, they have to die. So even some scientists are calling this as a kind of altruistic act of the bacteria to die to produce these tylosins, and they are released via lysis, and they are used to kill kin strains. Usually this is the same species, sometimes same, sometimes even different genus. This is for now consensus that they have rather narrow and specific range. It is also quite interesting because in my studies I showed that there is a baseline of the tylosins production in the population of the at least soft-rod Pectobacteriaceae. And how they work? So they attached via these tail fibers to the susceptible bacteria. They are used to recognize the victim, and then using this spike, they are puncturing the cell and killing it via the disruption of the proton motif force. So then, this was the results for the almost a model type among these soft-rod Pectobacteriaceae. So I asked myself, okay, so how common is this phenomenon among the soft-rod Pectobacteriaceae? And as you can see, it is very common. Most of the chosen bacteria, these were bacteria isolated from the river in France, as a model, are producing tylosins under this normal induction using mitomycin. Then I isolated tylosins from each of these strains and tested its activity on the panel of these strains, showing which interactions can be mediated via tylosins production. And as you can see, it creates a quite complicated and dense network. And what is even more interesting, some of these interactions are retaliated, which means that bacteria which is producing tylosins against victim is also susceptible for the victim tylosins. And that is especially visible here in these Dikia-Dikia interactions. What is also quite interesting that some of the Dikia tylosins are targeting some of Pectobacterium species, so you can see that there is a cross species interaction. Then I checked how do they really look alike, and as you can see, they are just kind of tubes. You cannot really distinguish them just based on the simple morphology. However, again, if we go further, they are completely different at the genetic level between these two species, Pectobacterium and Dikia, not only in the sequence of the genes, but also in the synthesis of these clusters. However, again, going much deeper, if we compare the clusters intragenous, we can see that they are very, very similar. The only differences are in the sequence of the tail fiber proteins and some in the tail tape measure protein. And what is very interesting and kind of lucky for me, you can remember that Pectobacterium brasiliense was not producing tylosins, as you can see, it does not have a cluster, and this gene, which is here between these flanking genes, is annotated as a mobile protein element. So maybe there was some kind of act of recombination. And also Pectobacterium atrosepticum do not produce tylosins, as you can see, the case is almost the same. However, there's a bigger part retained of the tylosin cluster. Okay, and in the Dikia species, the case is quite similar. The clusters are very similar. The only difference are mostly here, which are the genes that are not directly, at least we think that, they are not directly associated with the tylosins production. And you can see that the orientation of them and the sequence can differ. However, here we have very interesting case because Dikia denticola do not produce tylosins, at least in the condition I tested. However, the cluster is intact. So maybe there are some difference in the how the tylosins are controlled by some other genes. We don't know yet, and this is very interesting case. Okay, so now we know that most of them do have the tylosins cluster. Most of them can produce tylosins. However, what can they do? So we tested these 3 pairs of the strains. In first 2 pairs, it was like that Dikia solani was killing the other 2 via tylosins interactions. At least it was possible based on this matrix you saw before. And in the second pair, Dikia solani was killed by the tylosins produced by these 2 strains. And the third pair, where Dikia was associated in this retaliated interaction. And what is very interesting, it is not enough. So if you can produce tylosins against someone, it is not enough to win, at least in this even start scenario, because they started from the same amount of the bacteria. And going even further, so we still asking ourselves, okay, they are very common, at least at the genetic level, we can see them on the microscope. So do they really matter in the context of the environment? So we chose 3 places from Poland, 3 different samples based on the proximity of the soft-rot Pectobacteriaceae, the places that these bacteria could occur, and we chose some strains from them. We tested almost 500 strains, and it turned out that in the environment there are some bacteria that are susceptible to the this model tylosins from Dikia dadanti, which is very interesting because these strains are not pectinolytic, non-virulent against the potato, and they are completely different from the soft-rot Pectobacteriaceae. So going back to this question, yeah, I think the tylosins matter, and probably they can shape in some way the even the microbiome of the plants or microbiome of the soils, and I will try to continue to find really how. And for the end, I wanted to show you something very beautiful, in my opinion. So this is reconstruction of this model tylosins from the cryo-M. And here you can see this spike, which is responsible for the killing of the bacteria, and parts of the fibers, which are responsible for the recognition of the victims. Thank you very much. If you have any question, I will try to answer them.
Thank you for your presentation. I'd like to open the discussion. Do you have any questions? I can see a question in the chat. Have you performed or are you planning any broader studies on the interactions between these compounds, microorganisms, and plants?
Yes, so truly speaking, I will be doing this week. This will be the first studies that we will try to use the susceptible strains, these plant pathogens and plants. Because this is one of our idea why these tylosins could matter, because if the strains are susceptible for the tylosins of plant pathogens, maybe somehow they should protect the plant. So then you will have this triangle interaction, which would be very interesting, but we don't know yet.
Thank you very much. And Professor Axman, please.
I have to say that the topic is quite new for me, but very interesting, because my team is working with unicellular green algae, and often we have problems with bacteria that colonize our cultures because they are liquid cultures. And we have problem because, of course, if we would like to kill bacteria with some chemical reagents, so it usually also affect our algae. So this is big problem. So if we have such a safe way to kill bacteria without killing our algae, it would be very, very nice. So I hope that this technique would develop, and that it will be available soon for different fields of industry, and also for science. So I keep my cross fingers for your research.
Thank you very much. So it was more of a comment, so I will answer with a comment. So there is very interesting case, because they are quite similar to the phages. However, they do not replicate. So this is also, I am seeing this as an advantage, because we can control them. If you release the phages, they are out. And this is like one-time use. So yeah, I see the potential in them.
Great, thank you very much.
Я успела.
Professor Wiktorska, please.
Okay, hello again. Thank you very much for this really nice presentation. It was really a pleasure to listen to this. So many results. And I have a question, because maybe, I assume that in the future, you maybe will think about practical or commercial application, because it looks like. So is this technique or methodology or this concept safe for humans? So
very good idea. We tested that in few. Oh, I do not have that. Yeah, I thought I have that, but we tested it on the on this worm. I forget the name. On the elegans, on the C elegans. Yeah, and they are completely safe for it. We also tested it on many different like type strain bacteria that can be associated more with humans to see like, you know, this meta influence on human, and there are still have very narrow spectrum of action. So we have these two things, at least for now. So they are safe for C. elegans, and they are very they have very specific spectrum. So they are not targeting, at least what we know now, any like human associated bacteria. So we hope that they are like safe for humans. They are also like just the protein structure, so they are completely biodegradable. And yeah, as I said to Professor Axman, they are like one-time used. So they are like single usage. They cannot replicate. They do not have DNA. So yeah, I hope they will find some like very nice application in future.
Yes, thank you. So it looks fine, and as a Professor Axman, I keep my crossed fingers for your success in the future. Thank you very much.
Thank you everyone for the discussion. Thank you for your presentation. And I'd like to invite again Weronika Chmura from Intercollegiate Faculty. Are you with us?
Yes, I am, and I'm extremely sorry. I'll try my best to show you the presentation.
If you have any trouble with it,
Yeah.
you can send it to the organizers and we're trying to share it for you.
Okay, I will send it in 1 minute.
Sure.
I thought that everything is all right for now, so I'm really sorry. I have a problem with this computer.
It's perfectly fine. We'll wait for you. Did you say you're going to send it?
Yes, yes, yes.
All right.
Just 1 minute. It should be by now.
Just let us know when you send it.
I've sent it.
All right. All right. Which email? The general one?
Daria Lata and Mateusz Baluk. And
all right. All right. Thank you. It seems we are still waiting to receive your presentation. So just let's wait a moment. Do you mind checking if the email is sent? Because it wasn't received.
It is sent.
Okay, so I received the information that we've got your presentation.
You've received, you see it, right?
Yeah, I can see it.
I'm extremely sorry. I don't know what to do on this computer. It's not mine. I'm really sorry. I'll try to be quick.
We've got actually a bit. Okay, we are out of time, but let's hear our final speaker anyway. So this is Weronika Chmura again. Please take it away.
Okay, so my analysis was conducted under supervision of Professor Igor Konieczny, and it focuses on poly-P and DNA interactions with selected proteins. So during normal growth, proteins interact with DNA, which help it to maintain local concentrations and affects protein together. I will be investigating few proteins from E. coli, alone protease, which is responsible for protein quality control, DNA A, which in ATP bound form is responsible for initiation of replication, COP-B deacetylase, which deacetylates DNA A and allow it to bind ATP and initiate replication, and histone-like DNA binding protein beta, which bends and compacts DNA to facilitate or restrict access to, for example, origins of replication. So what do we know about polyphosphate? It's that this molecule accumulates during stress, and phosphate PPK transfers phosphate residue out of ATP to growing chain of poly-P, which consists of up to 1,000 phosphate residue linked by high energy bonds. And due to it that's negatively charged, it binds metal ions. We also know that PPX enzyme after stress degrades it to shorter chains. It's also really important molecule in stress resistance. It's considered as membranous organelle, and it's important virulence factor for pathogenic bacteria and important in biofilm formation. Also, it may act as chaperone-like molecule because it prevents proteins from aggregation. Main hypothesis is that DNA and poly-P constitute alternative scaffolds for proteins, which can change its scaffold from DNA to poly-P and therefore change their intracellular localization and partners for interactions and activity and stability. We think that poly-P binds molecules, and that's why granules assemble. And then alone can act to degrade these proteins and recover of amino acids to restore another proteins. Also, it leads to poly-P granules disassembly, and it's preceded by degradation of polyphosphate itself by PPX. What we do know that up to 3 hours after nutrition shift, poly-P accumulates, and when its level drops, bacterial growth resumes. And in strain without PPK, the growth doesn't occur, so it means that's a really important particle in stress recovery. Also, on the right of the graphs, you see that poly-P granules stained by DAPI. What we don't know yet is about structure, composition, and function. Also, we don't know what are our molecular bases behind the switch from DNA to poly-P. What we do know is that lone binds polyphosphate and binds also DNA A in form of ADP, and it induces poly-P-dependent DNA A proteolysis. My first part of the project was correlated to that protein change their scaffold, and polyphosphate is negatively charged. When we compare DNA to polyphosphate, we can say that poly-P of the same length as DNA has 2 times less negative charge, because DNA is 2 strands. Oh no, can you see graphs?
Yes, the graphs are visible.
But yeah, I'm so sorry. I can see them, but if you see, that's okay.
Okay. No. Actually, the charts are visible, but not the graphs. The lines of the graphs are not visible.
I don't know what to do now. It's my bad day, I guess. Maybe I don't know seriously what to do, so I'm really sorry, and the presentation when it comes to this result is pointless, but you can see. I will tell you about different graphs. So when I used another method, which is electric mobility shift assay, I could observe that LON indeed is changing its scaffold to polyphosphate. And the same was for COP dacetylase. But when it comes to other proteins like histone-like DNA binding protein, I couldn't observe the full binding by poly-P. And also it was the same for DNA A, which, as you know, interacts specifically with DNA in form correlated with ATP. That's why it couldn't change its scaffold. So another part of my project was correlated to polyphosphate granule formation, and I used atomic force microscopy, in which I added polyphosphate or LON protease or mixed them together, incubated them on mica mineral, and then I could observe granule assembly. As you see, they changed their volume about approximately 10 times. And bottom graph shows the distribution of high values around the maximum peak depth. When it comes to histone-like protein, I observed a similar thing. And the last analysis was for COP dacetylase. As you can see, characteristic linkages. When I prolonged incubations with COP dacetylase, I could observe that this polyphosphate acts like a factory that can recruit up to 100-fold excess in COP amount. But really interesting is that if proteins can bind to poly-P particles at the same time, or how exactly does it work that stress granules assemble? And that would be it. And I'm extremely sorry you couldn't see my best results, but what can I do today?
Thank you for your presentations. Do you have any questions from the audience? I can see one person. Please, can answer your question.
Okay, hi. Thank you for your presentation. I just wanted to ask you about this poly-P molecule. So you said that it is accumulated during stress conditions. Is it specific to some stresses or in all kinds of stress?
actually in most of them, in heat shock, during stress correlated to nutrients, during oxidative stress, also when antibiotics works on cells, so multiple types of stresses.
Okay, thank you very much.
Thank you.
Thank you. Thank you for your presentation. Thank you for the questions. I'm afraid that if you have any more questions, they will have to be asked in the chat. I'd like to say thank you to all our speakers for their insightful presentations and all the participants of this session. Please enjoy the well-earned rest of the break. And the last sessions of our presentations are parallel as well. So please join us at 12 UK time for the session 7A here and session 7B through the other link on the website. Thank you again for participating.
Hi, good afternoon, everyone. My name is Angelika Łepek, and I have the pleasure of chairing the fourth, oh, I don't know, excuse me, I'm sorry, I need to correct myself. Chairing seventh oral communication session. Each speaker will have 20 minutes for the talk, followed by approximately 3 minutes for the question and discussion. We kindly ask our presenters to respect the allotted time. Thank you. I am pleased to introduce our first speaker of this session, Luiza Shumskaya, representing the University of Siedlce, Poland. Ms. Shumskaya will present as a part of BioPanel. Please go ahead and share your presentation and confirm that the slides are visible and everything is working as it should be.
Hello.
Hello.
1 minute and okay. You see my presentation?
Yes. Yes.
Okay. My name is Luiza and I have presentation about ecotoxicology of cosmetics, impacts on the Baltic Sea ecosystem. This presentation reveals how cosmetic ingredients contaminate the sensitive Baltic Sea. We explore chemical exposure, ecological consequences, and necessary intervention to protect this unique ecosystem. Baltic Sea vulnerable ecosystem. The Baltic Sea is semi-enclosed with limited water exchange. This makes it highly sensitive to pollutants from industrial and agricultural and household sources. Contaminants of emerging concern, UV filters, preservatives, and antimicrobials, also microplastics. Pathways of cosmetics. Cosmetic chemical reach the Baltic Sea through wastewater effluents. Studies in the Baltic region show what a significant portion of this chemical ends up in treated effluent of sewage sludge, which may be lost in agriculture or leak into waterways. Stormwater runoff, cosmetic products like sunscreens, lotions, and sprays applied on skin can wash off during swimming or beach activities. Rainwater then crisis residues from streets, parking lots, and recreational areas directly into the sea via stormwater drains. This pathway is especially significant in urban coastal zones with high tourism and direct relies during bathing. Ecotoxicological impact. This substance can disrupt hormones and in fish and invertebrates, affect reproduction and growth, accumulate in food chains. Wastewater treatments limitations. Many cosmetic chemicals are not efficiently removed during treatment, detected in effluents and sludge, persist in the environment. Bioaccumulation risks in the Baltic Sea. Persistent chemicals accumulate in marine organisms like mussels and fish, potentially entering the human food chain. This magnifies toxicity through food webs, warming wildlife. regulatory gaps. Current cosmetics regulations focus on human safety, not environmental impact. HELCOM urges environmental risk assessments and coordinated monitoring. And gaps in regulation and HELCOM's recommendations. First of all, regulatory gaps. Current laws prioritize human safety, ignoring environmental effects. HELCOM actions calls for stricter pollutants controls and eco-friendly products reformulations. Wastewater innovation, advanced treatment technologies to remove harmful chemicals effectively, and public awareness, educate consumers of choosing environmentally safe cosmetics. What can consumers and policymakers do? Choose eco-labels, select cosmetic certificate for environmental safety, support legislation, advocate for laws addressing environmental impacts of cosmetics, invest in green chemistry, promote research for sale and biodegradable cosmetics ingredient, uncode monitoring, continue synthetic studies, tracking contrastments and impacts. And conclusion, protection the Baltic Sea together. Cosmetics pollutants pose hidden risk on the Baltic Sea's fragile ecosystem. Coordinate efforts among industry, regulation, sensitivities and consumers are vital to reduce harm and preserve this valuable marine environment for future generations. And thank you for your attention. I would like to read your questions on my email because I'm currently at work and unfortunately my break is ending.
Okay, we get your message. Do you mind if the participants will write the questions on the chat and you will be answering on the chat here on this meeting? So is Luiza. Okay. So preferably if any of the listeners have a questions for Mrs. Luiza, please leave the question on the chat, and I hope Mrs. Shumskaya will answer it soon, as soon as she will have a little time. So we will not be waiting for the right time. It is the right time to move on to the next speaker, Mrs. Sarah Ater from Poland University of Szczecin and Kenya Technical University on Mombasa. I can see. Okay, I can see someone turn their camera on. And I guess probably it's our contestant. And we can see your screen. You can start sharing the presentation.
Good morning.
Good morning. Good afternoon.
Can you see the presentation?
Now we can see the screen of meeting, not the presentation, but your whole screen.
Okay, let me try again. Can you see it now?
Yes,
Yes.
very clearly, and everything is working as it should be.
Okay, thank you. So my name is Sarah Ater, currently an Erasmus student at the doctoral school, University of Szczecin, from the Technical University of Mombasa. And my presentation today is a sustainable development perspective of marine recreation and sport fisheries in Kenya. So my presentation, I'll give an introduction, explain the aim of my study, introduce you to my methodology and study area, then proceed to share the results, conclusion and recommendations. So sustainable development is about development that meets the needs of the people, at the same time putting into consideration ecological and social needs. When we look at the Sustainable Development Goals, the first goal is with regards to elimination of poverty. We have the third goal as regarding well-being, the 8th goal about economic growth, the 12th goal about sustainable consumption. And so marine recreation and sport fisheries feeds into all of these different goals, because it is useful. People do marine recreational fisheries for fun, so it's good for their well-being, but those who are involved also do it as a business, so it is important in terms of local development and economic growth. In the context of Kenya, marine recreational and sport fisheries began in the 1950s. It is predominantly a no-take fishery, meaning that you go fishing, but you shouldn't take the fish out. You shouldn't carry the fish away with you unless perhaps the fish is injured, and if you put it back into the water, it will not survive. The fishery in Kenya is tourist dominated, and one of the popular species that are targeted is the billfish. In the photo, we can be able to see sailfish. So the aim of my study is to be able to just examine who is involved in the fishery, what are the fishery resources, and also to explore the narratives in the data. This is important because marine recreation and sport fisheries are understudied in Kenya. We have little catch data, and reporting regarding the fishery is very inconsistent, and therefore we know very little about the actual status of the fishery. So my study is at the Kenyan coast, focusing on 2 counties, which is Kwale and Kilifi County. I have conducted a literature review looking at different scientific databases as well as grey literature, mainly in the form of government reports. I also have data from partial catch data, as well as small sport fishers survey. In terms of my results, using key phrases, I was able to get more than 400, close to 450 peer-reviewed articles. However, when I really actually narrowed down to marine recreational fisheries in Kenya, then I only found just about 15 that were relevant to the Kenyan context. When looking at the grey literature sources, then it was interesting that the national statistics make mention of marine recreational and sport fisheries, but they don't provide any actual data with regards to figures. Through the survey, I was able to find out that most of the sport fishing is owned, operated at an individual level, a majority of it. There are also some family businesses and what you'd call community groups, such as, for example, a club, and company is the least amount in terms of the involvement. When you analyze the fishery, you look at it, the fishery is valuable because of the amount of people that are employed and the resources that are used. Like I mentioned earlier on, it is very much dependent on tourism, and therefore it supports other industries such as the hotel, accommodation, and as well as travel industry. It's rare. When you look at the rarity of the industry, it is not very big. in terms of what is happening, but yet it has a lot of potential. When you look at imitability, not many people, local people, quite understand it. It is very much, sort of foreign-based, foreign-owned. And in terms of organization, we have had some fishing clubs. So in general, it is an industry in which there is potential that can actually contribute, for example, to the blue economy. When we look or you do a SWOT analysis, then we see that in terms of the people who are involved in the fishery, we have highly skilled crew and captains. We also have within the country, within the region, fishery scientists who can be involved in stock assessment and other components of research. As an opportunity, it has great potential in terms of the blue economy, but the challenges faced are in terms of weaknesses, which is inadequate data, and there are also reports of declining fish stocks, and there doesn't seem to be very much communication amongst the different agents. So, for example, when you look at the fishing clubs, for example, and the fisheries department, which is in charge of regulating the fisheries industry. From the survey, some of the challenges that were, came up are the issue of overfishing, reduced catch, the issue of pollution, conflict issue with other fishers such as commercial fishers, trawling, and general decline of the fishery. One of the sport fishers who has actually been fishing for more than 47 years said, but overall the numbers of schools of small to medium tuna has seriously declined since 1984. Marlin composition has changed significantly in that blue marlin is now far more abundant than it was during the 1960s to 2000. During the 1970s and 1980s, large tiger sharks were frequent sighting, and now sightings are infrequent and only small juveniles. Large yellowfin tuna are far reduced in numbers. In the 1970s and 1980s, September, October was a high season because of large tuna, and with the large tuna came other predators, but that aspect of the fishing calendar has completely collapsed. So we see that there are issues in the fishery that require monitoring. In terms of the conclusion and recommendations, I found that there is not much data, so it becomes difficult to plan for the fishery. Hence, there is need to streamline data collection and reporting. There is also potential to grow the fishing industry for local development and promote it as a local industry with a local community involved in the fishery and a local client base. There's inadequate understanding of the socioeconomic contribution of the fishery, and therefore there is need to conduct a social and economic analysis of the fishery, which I will continue to do in the process of the PhD, which is still ongoing. So I want to acknowledge the University of Szczecin Doctoral School, Technical University of Mombasa, Department of Development Studies, the State Department of Blue Economy and Fisheries, as well as Duaterato, and the WWF EFN and Erasmus Ability that funded me for to be able to participate in the Erasmus program. So thank you very much, and I welcome your questions. My email address is as on the screen.
Thank you so much for your insightful presentation. And now I open the discussion. Feel free to ask any questions that participants, even on the chat or by raising the hand on the meeting. Professor Anna Axman.
Hello, it was very interesting presentation. In Poland, fisheries is also very important, and also it's very challenging to keep the balance between our needs and the possibilities that nature offer us. So it is, I think it is a global problem. And I am wondering if you have any idea how we, all of us, as a usual people we are not government members, we don't have a possibility to establish law or something like this. Do you have an idea what can we do to help nature support us with fish, and to support fishermen to keep the balance between economy and ecology?
Okay, thank you very much. I think one of the important things is that we recognize that fishermen, mostly a good number of times it's men, but the fishers interact with the resource a lot. So they have a lot of knowledge regarding the resource. They also are able to see that there are changes in the resource. So I think it's important for us as scientists to develop one collaboration with fishers, so perhaps in the form of citizen science, where we work together with the fishers in terms of collecting data regarding the fisheries, and that way we are able to see from the data the changes that are occurring, and if there are any suggestions regarding, how to manage the fisheries, for instance, maybe we suggest closed areas, or we suggest, some protected areas, then I would imagine they'll be more willing to cooperate because they have been a part of the process in documenting and recording the changes within the fishery. So I think there's need for us scientists to work closely with the fishers and take advantage of the back home indigenous knowledge. We have, the fishers, they have a lot of the traditional knowledge, which is also useful for science and for management.
Thank you very much. It was really nice to talk to you and to see your presentation. Thank you.
Welcome.
Thank you, Professor, for the question, and thank you, Sarah, for your answer. It was it's very inspiring, and I thank you for actually doing a presentation on a very important topic, I think. Let's not talk very much. Do any of the listeners have more questions? Have time for that? If not, I have a question. My question is, which place makes a good and efficient spot for fishing hotspots?
Where is a good fishing hotspot?
Mm-hmm.
Okay.
So we cannot damage the ecosystems or have the little to lowest impact.
Okay.
Little to no impact.
I think in the Kenyan context, for example, again, the sport fishing is carried out in the deep sea. When we look, for instance, at our seagrass, our mangroves, and our coral reef system in Kenya, these are closer to the shore. So there is minimal damage to these important ecosystems when it comes to sport fishing, at least within our Kenyan context, because when you need to do the sport fishing, then you go out into the deep sea. But there may perhaps, of course, be damage to the seabed, perhaps, I imagine, but at least, what we consider the usual ecosystems that we rely on are pretty much safe within the Kenyan context.
Thank you so much. Thank you for answering the question. And thank you for your presentation again. And we will move on to the next participants. And Ms. Wiktoria Zawadzka from Poland, from University of Gdańsk. Are you here?
Yes, I am here. I'm showing my presentation, my screen right now.
We are not seeing it yet, but maybe in a few seconds.
Okay, I'm working on it. How about now?
Yes.
Okay,
We
great.
can see it and we can hear as it should be.
And can you hear me clearly? Because I had some internet connections earlier.
Yes, it is okay. It is okay. Everything is fine.
Okay, so good afternoon, everyone. Today I will present you two innovative microbiological approaches to detecting environmental pollution. I won't be talking about my own research yet, but the first of those researches I will talk about involves a bioluminescent marine bacterium used as a biosensor for heavy metals, and the second explores the use of microbial community DNA profiles and machine learning to detect explosive residues like TNT in marine sediments. These two case studies demonstrate how microbiology combined with modern analytical and computational methods can support ecological protection and pollution monitoring. Okay. So, oh no, am I missing a slide? Okay. So aquatic environments across the globe face increasing pressure from pollution.
Sorry for interrupting, but if you change the slides, we cannot see the changing slides.
Oh, you still see the first one, yes?
Yes, yes.
Oh, I don't know how I can fix that.
Are you sharing only you? Are you sharing the full screen or just like the window?
I'm sharing the window, so I will try with my screen. Okay, so now the full screen. Sorry.
Yeah, it is working correctly now.
Great.
Fine, thank you.
As I said, industrial activities introduce toxic materials like cadmium, lead, or copper, while historical wartime activity has left behind chemical and explosive residues, including TNT. And these compounds are persistent, bioaccumulative, and often toxic to marine life, even at trace levels. And worse, their detection in sediments or water is challenging and many times requiring costly instruments and laboratory methods. On the other hand, microbial biosensors offer a promising alternative because microorganisms react directly to toxic substances, and their behavior can be used to detect the presence, type, and even the intensity of pollution. And this is particularly useful in complex environments like seas, oceans, and so on, where low water renewal rates and unique salinity gradients amplify pollution risks. Why should we even use microbial biosensors? Microorganisms as biosensors? Well, microbes are nature's ultimate responders. Their small size, fast reproduction, and metabolic diversity make them extremely sensitive to environmental changes. Some, like luminescent Vibrio species, can produce visible signals in response to toxins, and others undergo community-level shifts. Some taxa decline, others thrive, that leave behind a biological fingerprint of what the ecosystem has experienced. Because these changes are often specific and reproducible, we can detect pollution indirectly by observing how microbial populations shift over time. And this can be more informative than chemistry alone, because microbes integrate signals over days or weeks. So it's telling us not just what's happening now, but also what has happened recently. And one of such microbial biosensors is currently commonly used. It's the portable microtox FX, which uses the bioluminescence of Vibrio fischeri. But also, there's always room for improvement. In the first study, we will focus on a new luminescent bacterium, Vibrio species MM1, that's what it was called, isolated from the Caspian Sea. And researchers aim to find a strain that could act as a rapid response biosensor for heavy metals in marine or estuarine waters. To isolate this strain, they collected seawater samples enriched for luminous colonies and screened them for light sensitivity using a luminometer. And the MM1 strain stood out due to its very high light output. It exhibited intense, stable bioluminescence under moderate salinity and neutral pH, conditions similar to many coastal zones, including our Baltic Sea. And then the research team tested MM1's response to 6 metal common in aquatic pollution: zinc, nickel, copper, lead, cobalt, and cadmium. They prepared metal solutions and exposed bacterial cultures to increasing concentrations, and after just 15 minutes of exposure, they measured the luminescence. Then they calculated the SE50 values, the concentration at which the luminescence dropped by 50%. How about the results? From these results, we can see that MM1 is particularly sensitive to zinc, nickel, and copper, all of which are commonly released from industrial activities. And this finding is significant because it suggests that MM1 could be used in portable biosensor kits, automated water monitoring stations, or field tests near industrial outflows. Such tools can help identify emerging contamination trends early, potentially preventing damage to fisheries, habitats, and biodiversity. In comparison to commonly used microtox, TMSA, the commercial standards, MM1 was significantly more sensitive, up to 17 times more sensitive for zinc. While this method showed promise in detecting low concentrations of heavy metals, several limitations and challenges emerged. One of the main issues was the occurrence of false positives, because the MM1 isolate exhibited a significant drop in luminescence in response to even low concentrations of heavy metals, which is useful for toxic detection. However, this heightened sensitivity could lead to misinterpretations, especially in samples when the presence of metals might be due to a residual contamination rather than current toxic exposure. And the bacteria's high sensitivity to various metals made it particularly susceptible for false positives, as I said, which made tracing where minor traces from previous contamination could induce a notable decrease in luminescence, confusing the outcomes of our research with possible ongoing with possible current pollutants in the water tested. And another challenge, which was a big one, was the reliance on specific environmental conditions, such as the optimal salt concentration for bioluminescence, which limits the applicability of this method in non-marine environments or areas with fluctuating salinity. This assay is a potentially powerful tool for detecting heavy metal concentrations, but it requires careful calibration to avoid false positives. And to probably skip this problem, we may isolate Vibrio species that are specifically in the areas that we want to test for heavy metals pollution. Now let's move on to a different yet equally serious contaminant, TNT. After World War II, large quantities of munitions were dumped into the Baltic Sea. One of the largest sites is Kolberger Heide of the coast of Kiel in Germany, where the research was placed. Over time, corrosion and low-level detonations and leaching have released TNT and its derivatives into surrounding sediments and waters. However, TNT is unstable and reactive. Its concentrations can fluctuate, and traditional chemical tests may miss low-level or historical exposures. This raises the question, can we detect TNT exposure indirectly by observing how microbes respond to it over time? Where to explore this, researchers collected 150 sediment samples from Kolberger Heide. They extracted DNA from each samples and amplified the V4 region of the 16S rRNA using universal bacterial primates, and then sequenced their genomes. To explore this even further, the raw reads were processed using Data2 pipeline, a bioinformatic tool that removes sequencing errors and produces high-resolution amplicon sequence variants. Then they were taxonomically assigned using the Silva database and organized using a phyloseq package. In total, over 1,700 genera were identified across the dataset. And for machine learning, they used a random forest and models and artificial neural networks. Random forest is an ensemble method that constructs multiple decision trees and identifies the most important taxa for classification, and artificial neural networks were used to cross-validate and test prediction robustness. And both methods were implemented during the study. And using only microbial community data, models predicted TNT present with up to 83.8% balance accuracy. Still, the accuracy can be, of course, increased in some ways, but further research on training the machine learning softwares is needed. However, this was higher than models based on geochemical sediment data alone, and the best performing predictors were 25 bacteria genera, including bacteria known to degrade nitroaromatic compounds, bacteria that are found in disturbed or oxygen-limited marine sediments, or genera associated with sulfur or iron cycling. Notably, in several cases, the models correctly predicted TNT presence in samples where chemical analysis found no detectable TNT. This suggests that bacteria retain ecological or functional signatures of past contamination, potentially due to persistent breakdown of products or selection for TNT-adapted species. How about the application of this approach? Of course, long-term monitoring of munition dump sites, tracking the ecological footprint of contaminations even after cleanup, and supporting action plans for environmental restoration and risk assessments. A key issue in this method was the occurrence of false positives, particularly in samples containing TNT metabolites. These metabolites can persist in sediments long after TNT itself has been dissipated, causing microbial communities to remember past contamination, and as a result, the model was more likely to classify metabolic containing samples as TNT present, which could lead to misinterpretations when detecting current contamination. In addition, some samples near decision boundaries were still misclassified, indicating the need for better resolution. And this study also highlighted the potential of using microbial community signatures for long-term pollution monitoring. However, the presence of TNT metabolites complicated this, as microbial communities may retain detectable signs of contamination long after the pollutants have degraded. And this ecological resilience suggests that microbial communities may continue to show signatures of past contaminations, complicating the distinction between historical and current pollution. Together, these two case studies illustrate a few frontiers in environmental biosensing. Whether it's a glowing bacterium or a complex DNA based fingerprinting interpreted by machine learning microbiology is providing new tools for fast, precise, and cost-effective pollution detections. These tools can improve monitoring coverage at a lower cost, provide early warnings for ecological disturbances, and capture not just the chemical present, but also the biological impact of pollutants. And although these methods do require further refinement, their potential for detecting and monitoring ecosystems remains promising. Significant effort and continued development are needed to effectively support environmental protection and safeguard marine ecosystems in the face of growing environmental threats. I didn't find any updates from the authors of those two papers, so the research is probably still ongoing. Thank you so much for your time. I'm open to any questions.
I'm opening the discussion right now. I see the one question on the chat, but I'm gonna ask first: is any of the contestants, if any on the listeners, have a question? Mrs. Kinga Nimz.
That was a great talk. I have a question related to this case study about the machine learning approach. Do you know if also as a measurement to measure the performance of the model, they only use the accuracy metric or something more statistics too?
And from what I've gathered from the paper, it was accuracy.
Okay, all right. Thank you.
Thank you. Anyone else?
I'm gonna read the question from the chat. What is the significance of native luminescence bacterial stains in monitoring pollution in the Baltic Sea?
Well, because this Vibrio, their luminescence was dependent on the pH and salinity levels of waters where they are originally from, and from where you take the samples that you want to check for pollution with the Vibrio. To use the same technique in the Baltic Sea, you would just have to isolate luminescence Vibrio that is naturally occurring in the Baltic Sea. There are many ongoing researches where they're trying to find such bacteria. And this would be a big step forward for using the same method in monitoring pollution in the Baltic Sea.
Thank you for answering the question and a delightful presentation. And now we'll be moving on to our next participant, which is Mr. Dipankar Das, representing Tripura University. And will be presenting as a part of a chemistry panel. So please go ahead and begin your presentation.
Hi everyone. My slides are visible or not?
It is visible and we can hear you clearly.
Okay. Thank you very much. Myself Dipankar Das, from the Department of Agriculture in India. My today presentation topic is fly-ash-based geopolymers, bridging waste management and sustainable building materials. So as we know that coal waste now it's visible.
I'm sorry, I was on mute. I'm deeply sorry.
Now it's visible.
Yes, everything is clear. Everything is great. We can see you changing the slides. I was just on mute, so I was just talking.
Okay, that's okay. So, as per the British Petroleum Agency Outlook 2018, that reports that China was the world's largest coal user in the year 2015, and the consumption of this coal for various coal-based thermal power plants in India might be doubled from 407 to 833 million tons of oil equivalent for the year 2015 to 2035. So, in the left side, you can see in the figure that India that produces 112 million tons of fly ash per year, and utilization is, you can see, 38 million tons per year. So in next, that is China, that is 100 million tons is production, and utilization is 45 billion tons. So you can understand that how this huge amount of the school flies are being generated every year. And these are the next. These are the images of the Poland. First one is the Gdańsk thermal power plant where the flies are being generated, and next that is Belchato power station. I just want to show some status of current flies generation in Poland. And these are also some power station located in that Poland. So if we talk about the impacts of that huge amount of fly ash, there are many concerns out there like air pollution, water contamination, land use issues, toxic exposure, because prolonged exposure of the flies can cause respiratory issues like skin irritation, long-term health conditions including cancer, heavy metal toxicity, carbon dioxide emission, even methane emissions from the ash pond, because flies are generally stored in wet condition and dry conditions. So in the wet condition, it can emit methane, which is a potent greenhouse gas. So what is the solution of this problem? So solution is like that to promote eco-friendly construction using fly ash. Second is the used plan to use in the soil stabilization and agriculture, advanced recycling and processing techniques like geolite production, geopolymers, rare earth extraction. Technological innovations are required like nanotechnology integration, carbon capture, storage, awareness and trainings are required. Even after then, implementation of strict regulation on disposal and utilization is required, and foster international collaborations on research and innovation in fly ash recycling is required. So now, what is geopolymer? Geopolymer are a class of inorganic polymer that can be formed by the reaction between an aluminosilicate source material and an alkaline solution. And this material has an amorphous three-dimensional structure that's similar to that of an aluminosilicate glass. And it can be considered as amorphous equivalent of geological feldspar, but synthesized in a manner that similar to the thermostatic organic polymers. For this reason, these materials are termed as geopolymer. So these are the geopolymerization mechanism where you can see that first step is the chemical attack through the alkaline solution, and after that dissolution takes place, and next is the gelation, and after that polymerization and growth. So these are the general proposed mechanism by the various researchers. And these are the few of the materials that are being used in the for the synthesis of geopolymer. First, in the left side, you can see that various industrial waste materials are being used, like fly ash, silica, fume, ground granulated blast furnace slag, and so on. There are few natural materials are also there along with. And in case of alkaline solution, we generally use sodium hydroxide solution, potassium hydroxide solution, sodium silicate solution, potassium silicate solution, and sometimes the combination of both. So objective of this present study is the collection of raw materials flies from the Gdańsk thermal power plant, and after the next step is the characterization of that raw material, because characterization is very much important. And after the synthesis of this fly ash with geopolymer and testing and characterization of geopolymer specimen. If we talk about the testing of this fly ash, if this is the chemical composition of the fly ash, where you can see that the extrafluorescence analysis of fly ash, where silica and alumina are the notable are the major constituents that are present in the fly ash, with the percentage of silica that is 58.99 and alumina that is 28.83%, along with calcium oxide percentage that is 3.29%. So the sum of this silica and alumina is 82.82%. So which indicates that this flies comes under the type of class F as per the STM C609. And there are another one type is there that is class P. So this flies comes under the class F type. So this is the SEM image of the fly ash, where you can see that this image shows a mix of the particles with varying size and shapes. Spherical particles dominate the sample, with some exhibiting smooth surfaces and other rough and agglomerated surfaces. And the scale bar indicates that the most of the particles lies in below the 50 micron in size, and smaller and fine particles that are almost below 10 micron, which contribute to the overall agglomeration. This is the XRD spectra of fly ash powder, where you can see that quartz and mullite are the major crystalline phases that are present in the fly ash, along with hematite, and this quite contribute to the highest intensity peak, confirming its dominance as a crystalline silica phase. So this is the FTS spectra of the fly ash powder, where you can see that the intense peak at 1104, which attributes to the asymmetric stretching vibration of silicon, oxygen, silicon, and silicon oxygen aluminum bonds. And the wave numbers at 3460 semi-inverse, which indicates the wave stretching vibrations. These are the thermogravimetric analysis graph of fly ash powder, where you can see that the initial was 0.349% in the range of up to 400 degrees centigrade, but the major weight loss was happening in the range of 400 to 700 degrees centigrade. And after the 700 degrees centigrade, the sample stabilizes, which suggests that any remaining material that is thermally stable. And the total weight loss is 5.942%. This is the pictorial representative of the methodology, where you can see that fly ash are being added with the mixed with the sodium hydroxide solution, sodium silicate solution. After then mixing by manually, or you can use mechanical milling system. After then casting, after then curing process, and we will get geopolymer specimen. Here, this is the this table shows the mixed design of the geopolymer paste, where you can see that the concentration of sodium hydroxide solution, that is 6, 8, 10, 12, 14, 16, and 18 molar, and the sodium silicate to sodium ratio, sodium hydroxide ratio is kept at 1, and the liquid to solid ratio is kept at 0.3, and curing condition are kept at that is under ambient curing condition for 28 days. This at the left side, you can see that some geopolymer sample which was synthesized during this process, and in the right side, that is the physical properties of geopolymer specimen, and it also shows the bulk density of the geopolymer specimen. So this is the composite strength of the geopolymer specimen, because if we are preparing some sample, mechanical testing is also required. So here the composite strength test is conducted. Here you can see from the graph, you can see that with the increase of sodium hydroxide concentration, the mechanical properties increases up to 14 molar, but after 14 molar, the strength decreases. So the increase of this mechanical properties up to 14 molar, that is due to the fly ash reactivity and higher alkaline solution. So it has been observed that the lower concentration of sodium hydroxide solution gives lower concentration due to weak chemical reaction, and further it reaches the rate of geopolymerization process. But after 16 molar sodium hydroxide solution, the presence of excess waste menace ion that hinders the polycondensation process, so that the strength decreases from after 14 molar sodium hydroxide solution. So the main reaction product of this gemolation fly ash based geopolymer is the sodium aluminum silicate hydrate gel, which is mainly responsible for the this mechanical properties, and the highest compressive strength that is achieved, that is the with the 14 molar sodium hydroxide solution, and the compressive strength is 33 MPa. Next is this is the FESM representative FESM images of the spectrographs of the geopolymer specimen, where you can see that this testing FESM was conducted after the mechanical testing. So here you can see that the most of the particles are completely dissolved and form that compacted microstructure, along with a very limited and unreacted and partially reacted particle. This is the transmission electron microscopy of the micrographs of that 14 molar this sample, which was received achieved highest compressive strength. Here you can see that the darker part that are the geopolymer factor is the dense gel, which is the harder matrix of the geopolymer, and the lighter part is the porous gel. Here you can see some unreacted fly ash particle also, and this confirms the formation of that sodium aluminum silicate hydrate gel. And here this is the FTS spectra of the geopolymer specimen along with the fly ash powder. Here we are just trying to compare there is some changes are occurred or not. So a strong distinct band that in case of fly ash, that is 1104 semi-inverse, which corresponding to the asymmetric stretching vibration of silicon oxygen silicon or silicon oxygen aluminum bonds, and which is characteristics of quartz and molite phases in fly ash. But in case of that geopolymer specimen, you can see that that is shifted to the lower wave number, approximately 1000 to 1020 semi-inverse in geopolymer spectrum, geopolymer specimen, and this shift indicates that there is some chemical changes occurred and the formation of sodium aluminum silicate hydrate gel. And from that enhanced wave stretching vibration in the range of in the range around 3400 semi-inverse, and hydrogen oxygen bending vibration at 650 semi-inverse that demonstrate gel formation, specifically sodium aluminum silicate hydrate gel. So after preparation synthesis of any material, durability is very much important. To study the durability of this geopolymer specimen, we have conducted the water absorption test, where the sample which achieved the highest mechanical properties is poured in water for 7 days, 14 days, and 28 days. From the graph, you can observe that with the increase of exposure time, the rate of water absorption decreases, and the lowest water absorption rate is 1.54%, and that is due to the secondary reaction during the prolonged exposure to water, such as the further reaction of unreacted alkali materials, which decreases the pore size inside the specimen and which results the more hardened and compacted structure with time. So these are the few images of the sustainable construction material. First one, you can see that the brick that was prepared with the flash powder and paper 1 and paper 2. As we all know that during the production of ordinary Portland cement, that produces almost 1 ton of carbon dioxide to the environment. So here no cement is used, only sodium, that aluminum silicate material, which is a waste material, and alkaline solution is being used to synthesize this material. So if we talk about the conclusion, the mechanical properties of the geopolymers are influenced by the concentration of sodium hydroxide solution, and the increase of that molarities of sodium hydroxide solution from the 6 to 14 molar increases the mechanical properties, but after 14 molar, the mechanical strength decreases, and the highest composite strength value that was achieved at 33 MPa, and the HRTM that confirms the existence of the geopolymer gel. Along with HRTM, the shifting of peaks in the FTS structure confirms the formation of amorphous aluminum silicate gel, the gel called that aluminum silicate hydrate gel. So these are the few references that are used for this PPT. And I would like to, as the acknowledgement, I would like to thanks to the Fahrenheit Union of Universities in Gdańsk, Poland, for the Mayor of Gdańsk, Daniel Gabriel Fahrenheit Scholarship, and the Department of Environment Technology, University of Gdańsk, Poland. I would like to thank Mayor of Gdańsk, Professor Adriana, Dr. Anna Godlewska, Carolina, Project Manager in the Fahrenheit Union of University, and each and every member of the Department of Environment and Technology, University of Gdańsk, Poland. Thank you very much.
Thank you very much for your presentation. You can stop sharing your screen. And opening the discussion. I'm saying that Kamil Klimkowski left the question for you.
Okay, I got one question in the meeting chat, that what was the optimal composite strength results and at which sodium hydroxide concentration was it achieved? The maximum composite strength that was achieved at that is value is around 33 MPa, and it was achieved in 14 molar sodium hydroxide solution. And also I would like to inform you that if you consider that if you want to prepare one brick, so generally worldwide till now that is brick mud based bricks are being used, and after then cement based bricks are also being used, and that shows the highest composite strength around 10 to 15 MPa, but this geopolymer station that shows higher mechanical properties as comparison to the traditional conventional material.
Thank you so much for the answer, and thank you for your presentation. And now we'll be moving on to our next participant, Mrs. Kinga Nimz, representing the University of Gdańsk, Poland. Are you here with us?
Yeah, I'm here.
Thank
Do you
you.
hear me?
Yes.
Okay, I will turn on my camera too. I hope everything is gonna work good.
We can see you, so it's a good sign.
Okay, awesome, really. Okay, so I will try to share the. I need permission to turn my screen, so sorry for that. Okay, click and open. Okay. Okay, is it good? Do you see my screen or not?
Not yet, but I think it'll be working in a few seconds. I hope so.
I don't know why, but I give the permission, but it's still not working. I don't know why. Maybe, sorry for these technical issues. Sorry, I left and I tried to share again.
It's okay, don't worry.
Okay, hello, and now should work.
Yes,
I
it's
think
it's
now
working. We
should
can
work.
see your screen now.
Awesome, awesome. All right, I'll just open quickly. Okay, awesome. All right, so hi everyone. My name is Kinga. I'm from University of Gdańsk, and today I'd like to talk more about micro nanoplastics. And I know we've heard the really great talks during this conference about this, but I would like to put another point of view, how we can use artificial intelligence to make this research. So the main question I would like to ask at the beginning, and we're going to go through, if it's possible to do this, to answer for this question, is can artificial intelligence reveal the hygiene and toxicity of micro nanoplastics? So let's start for the really simple question, why this matters and why we should care at all about the micro nanoplastics. So the problem is the hidden risk of the plastics. So imagine you're drinking the water and you're swallowing the plastics and you cannot feel it, taste it, or see it at all, but inside still is a micro nanoplastic. And not only in your water, because it's everywhere, it's in the food we eat, in the air we breathe, and even in our blood system. But the issue is we still don't fully understand what the plastics are doing to our cells. And here we can show up the traditional toxicity testing. But if you like to test each particle, it's take a lot of time, money, and usually includes the animal test. So if we want to protect the human health, and not only human health, but all animals and organisms around us, we need to be faster and find faster, better solutions to uncover those invisible risks of those particles. So what can be the smarter solution? That's a question. So I call it for that from lab bench to the algorithm as a way to predict the risk. So not all experiments need a lab. Some need only the data. For that point of view that we're living now. So let's compare the traditional experiments in the wet lab and the computational ones. So in the traditional experiments, they're slower, costly, and usually they include the animal-based test. But in the computational test, using machine learning and AI at all is like fast, scalable, and data-driven. And my message is not to tell you that we should skip the traditional experiments at all and don't do this never. But maybe we can decrease the number of the traditional experiments using before the AI-based test. So in my study, at the first thing, I collected the data, extracting specific informations. At the sum, I have 1,093 micro nanoplastics, and all features I extracted were like grouped for physical-chemical properties and experimental conditions, which the physical-chemical properties include the size, shape, polymer type, hydrodynamic size, and zero potential. But for experimental side, we have exposure time, concentration, and cell line information. Then we're moving to our magic thing, our machine learning methods. And here I use the classification approach. I'm gonna explain you how it works and what does it mean. But here I just want to show up, I used 5 different methods. So it means I created 5 different predictive model. And at the final to choose the best one with the best performance. So to assign the performance, we need to have some evaluation. So to evaluate the performance, I used some specific statistics as you see on the right. The first was confusion matrix that I'm going to show you up later. And based on that, I calculated 5 different statistics like accuracy, precision, and so on. Well, don't worry, we're not going to go through the math at all. All right, so how it works. We're starting for our data. As I mentioned, you extracted physicochemical properties and experimental conditions. And this is our input that we're gonna put inside our machine learning model. So here we're going to this part of machine learning. This also includes two crucial steps that we never can skip it. The first is the feature selection. So here we are assigning the most significant variables or features that they have the highest impact to define the cytotoxicity of the micro and nanoplastics. And later, after that, when you create the machine learning models, after the feature selection, we need to assign the applicability domain to show in which ranges our model works. So for example, if we have size from 5 nanometers to 1000 nanometers. So show the specific ranges. And then I mentioned is the classification approach. So at the final, we're predicting if the specific plastic that we have with specific properties is going to be cytotoxic for our mammalian cells. It means positive, or it's going to be not cytotoxic, so it's going to be negative answer. All right, so now we know more or less, you have an overview how it works. I don't want to go like through the real details. So let's go through the results. We are trying to answer the question, can AI predict cytotoxicity of micro and nanoplastics? So as I mentioned we have the input data, we go through the machine learning step, and we want to identify the most significant variables, which we're going to use to build our models. So in this case, I use the back-forward elimination algorithm, and this process will gonna improve our model's performance. So on the right, you can see the table with some really weird values. It is like p-value, probably it's more similar for you guys. We can see the variables, and I only show up you the variables which the p-value was lower than my cutoff. It means 0.05. And at the final, having these results, I decided to choose only top 3 variables with the lowest p-values. And they're the concentration, the size, and exposure time. So to build my model, I used only 3 information. I need only 3 information about specific plastic. Okay, so going through to results. I will show you only the best model, not show up all statistics that we're calculating, just the best model, how it's going up to date. So here I have confusion matrix, and I know this maybe sounds a little bit magic, but on the left, it's for training set. It means the set that we use to learn our model. On that, our model is learning and see to identify the patterns. So we see here on the true negative and true positive, like in this case, this model predicted correctly everything. But on the opposite side, we have a false, negative, and positive. So it means the model didn't predict that good. So get another answer that we expected. And the same for validation set. So is a test set that we use that we just predict the cytotoxicity on this test, but the model have never seen this data before. And the rule is the same, true, negative, true, positive. It's correct, like predicted correctly, and false, negative, positive is predicted incorrectly. And based on those confusion matrices, we can calculate the statistic that I mentioned you before. So for training set, at the final, if it's closer to 1.0, it means it's better. The performance is better. So for the training set, we see the numbers are really close to 1. 0.96, 0.99. So this is like really, really close, almost perfect sometimes. But on the test set, we see some disproportions for sensitivity, specificity, sensitivity, F1 score, and MCC, which they're not the best. They're not so bad, but they're not the best. The reason why we can also see here on this visualization. So those statistics there contains information about our positive class. So it means the cytotoxic particles. And we see the model predicted incorrectly 12, but predicted correctly 9. So it's on another side that we're expecting. And this also show up some few insights that could be meaningful for you guys too. Maybe the first thing is is a huge disproportion between just our data set. A lot of our plastics, they're not cytotoxic, so we have negative answers, but we have the really small subset of those positive that they really induce the cytotoxicity. And then, as a next thing as I mentioned to you, the applicability domain, so just defined if all predictions are inside our domain. In that case, I use PCA boundary rectangular method. And you can see here those lines that you see on the PC1 and PC2 axis, they're like our borders. So if something gets outside, that's not good. Everything is inside. So it means that like our model made predictions within the range were presented by those training data. So everything is stable, and it means it's consistent for the data available that I used. So the conclusions, and for you some takeaways. The first, the machine learning and ML methods have potential in cytotoxicity prediction of microplastics that we can see. The next thing, the algorithm showed the most important features for cytotoxicity prediction is concentration, size, and exposure time. At the third, this I observed during the data collection. The data are not characterized perfectly that they could. We have a lot of, we call it that missing values. It means unknown information about some, I would say sometimes really crucial information about the structure of the plastic, like polymer type, for example, or even size. So this is the thing that all of us can improve in the future, some work in the micro and nanoplastics. So at the final, we need more better characters data to use fully the potential of machine learning and AI technologies. As I mentioned, we see the potential, but still is a space that we can improve in the future, which is meaningful for us now. Based on that, the micro nanoplastic research is pretty fresh and new for a few years, so we still have some space to improve. And at the final, to answering for the first question that I show up you at the beginning, can artificial intelligence reveal the hydrogen toxicity of micro nanoplastics? Yes, it can. It's not perfect, but we see potential that we can use that in the future. But also we see the space to improve. And this is like a little bit sneaky, I would say. All my results was from my master's project. And during my master, I also developed the web app for data analysis. And you don't need to have any machine learning knowledge at all to use it. You just need to have some data. You can just have fun, try to analyze it, see what's going to happen. The web app is going to be available in the next week. So I encourage you, if you'd like to try out, just put my name, my nickname for the GitHub, and you can just click it and check it out. So thank you once again for your attention. If you'd like to connect and talk, share your thoughts, feel free to just click on my LinkedIn and text her. I'm available there for the whole time. So thank you so much for attention, and I'm open for your question.
Thank you for your amazing presentation. And I already see that someone has a question. Krzysztof, go on. Yeah.
Hi, I also thank you for a very interesting presentation. You said that you collect the data about the size and the shape, of course, of nanoplastic. Is this some kind of regularity of shape of nanoplastic in different materials? I mean, in this material, the nanoplastic is mostly circular, in this mostly rectangle or something like that?
Maybe not, I'll not say specific material, but the tendency I observed that mostly the shape of the micro nanoplastic are spherical or unknown, if we don't know, if no one say, but usually it's spherical or irregular. I haven't seen any other shapes during this research.
Okay. If I may, the next question. Thank you for the answer, of course. How do you plan to further develop or continue this research?
I was wondering actually to still be up to date because this is really fresh topic. So every day we have a new reports, new papers related to even cytotoxicity. But I would like to continue that for my PhD actually, and be focused more for another activities and properties that we can predict, like another types of toxicity, like genotoxicity, almost maybe focus from immunotoxicity. So most of the research, my interest is toxicity stuff at all.
Okay, so we all wish you to continue this work on your PhD studies. Yes, finger crossed.
Thank you. Thank you.
Thank you again for your presentation. Thank you so much for answering the questions. And now we'll be moving to our final speaker of this session, which is Mrs. Marita Samburska, representing Nicholas Copernicus University in Torun from Poland. And her presentation will be presented as a recording, but still there'll be discussion afterwards. So, Mrs. Marita Samburska, are you with us?
Yeah, hello, I'm here.
So now I'm asking for sharing the presentation. Thank you.
Good morning. My name is Marita Samburska, and I'm a master student of medical chemistry at Nicholas Copernicus University in Torun, Poland. It's a great pleasure to be here today and to present my talk titled "Its Adsorption: A Valuable Method for Water Purification." So, in some introduction, water pollution is one of the most serious challenges facing the modern world. In recent decades, there has been growing concern about the presence of many previously unheard of chemicals in the aquatic environment. These are the so-called emerging contaminants, newly identified or disturbing contaminants. This term refers to both completely new chemical compounds and well-known substances whose harmful effect or toxic mechanism have only recently been discovered. These are compounds of natural or synthetic origin, often present in the aquatic environment at very low concentrations. The diagram using antibiotics as an example shows how silent trace amounts enter the aquatic environment. The main sources are waste and sewage from household, the pharmaceutical industry, hospitals, agriculture, and the accidental spills. Pollutions enters the environment through landfills, sewage systems, untreated discharges, or sewage treatment plants. The most common compounds of this type include pharmaceuticals and hormones, pesticides, drugs, and various types of industrial additives. Many of them are biologically active compounds that can bioaccumulate in living organisms and persist in the environment for a long time. Some of the emerging contaminants include bisphenol A, salicylic acid, dichloromethane, or styrene. Current wastewater treatment technologies are designed primarily to eliminate classic organic and inorganic contaminants, such as nitrates or phosphates. Emerging contaminants, although present in wastewater and surface water, are often not covered by any legal regulations, and their removal is incomplete or even symbolic. There is increasing talk of implementing the fourth stage of water purification, which purifies entire volume of wastewater using various adsorbents as filters. So adsorption is the mechanism by which molecules or ions present in a gaseous or liquid bulk phase remain on the surface of a solid. The molecules present on the surface of the adsorbent have much higher energy, called surface energy, which is necessary to attract the adsorbate to the adsorbent surface. In the adsorption process, we initially have a solution containing the substance to be removed. A material with adsorption properties is added to the solution. The adsorbent binds the adsorbate molecules on its surface. In the context of water purification, adsorption is a technique that is effective. It removes contaminants even in low concentrations. Its simplicity of the process, possibility of regenerating the adsorbent, and there's no secondary contaminations. An interesting direction is the modification of activated carbon. Despite its widespread use in many fields of life, is the unique physicochemical properties combined with relatively low costs that makes activated carbon one of the most promising adsorbent in purifying water from irremovable pollutants. Activated carbon has highly porous internal structure with a heterogeneous range of pore diameters. Its internal structure contains macropores, mesopores, and micropores. The main effects of this high porosity is to give activated carbon a large surface area. Consequently, there results in a large number of binding sites with which adsorbate molecules can interact. Acid or alkaline treatments are usually used to chemically modify the surface of activated carbon. They impart a negative or positive charge to the surface, depending on the method. This modification is important for the adsorption of cationic or anionic compounds and charged organic substance, such as dyes. But it's possible to modify activated carbon in other ways and differentiate its properties. In comparison of adsorbents, natural adsorbents such as zeolites, clay, or chitin are very cheap and easily available, but they are characterized by rather low adsorption capacity, limited durability, and poor regenerability. Modified natural adsorbents offer better performance thanks to the introduction of the functional groups, which improves their effectiveness and allow them to be adapted to specific pollutants, although their cost is slightly higher. The best properties are shown by modified activated carbon, which is characterized by very high adsorption capacity, high stability in various conditions, and the possibility to multiply use. But this is associated with higher production and modification costs. So why don't other adsorbents do the trick? For example, zeolites are primarily ion exchange materials. They are effective only for small ions and poor at adsorbing organic compounds. Chitin works well for metal ions, but has difficulty absorbing complex organic molecules without modification. The next table shows difficult to remove contaminants from water and how modified activated carbon helps to remove them. Drugs and hormones such as ibuprofen are small, non-polar, and resistant to biodegradation. Activated carbon works here by being able to enhance hydrophobic and pi-pi interaction through appropriate surface modification. Synthetic dyes are large molecules. Thanks to the mesoporosity of a modified carbon, they can reach its inner surface. Microplastics are too large for the micropores, but can be physically retained by larger pores and van der Waals interactions. Organic nitrogen compounds, such as pesticides, are chemically stable, but their removal is facilitated by adjusting the porosity and chemical groups on the surface. On the other hand, volatile organic compounds, which are poorly reactive and difficult to capture by ionic adsorbent, physically bind well to the non-polar surface of activated carbon. Despite this, natural adsorbents and modified natural adsorbents should be used to purify water. They are key step in ensuring water purity. Activated carbon could be proved to be this additional. In response to the title question, is adsorption a valuable method for water purification? Of course it is. the most suitable adsorbent for water purification is non-selective adsorbent, and activated carbon is just like that. Adsorption from aqueous solution is always displacement. There is no pure adsorption because the process is equilibrium. Something always remains in the solution. There are thousands of chemicals compounds in water, so there is no 100% certainty to remove all of them. If molecule that interacts more strongly with the adsorbent came across, the others will not be adsorbed. Thank you for your attention.
Thank you. Now I'm open to the question.
Thank you so much for the presentation. And I can already see there is a question from Monika Kapuścińska. Write it on the chat. What is the proper way to dispose of activated carbon to ensure it doesn't pose any environmental risk? Can it be used for other purposes in some way?
Used activated carbon should be either regenerated or disposed of in accordance with hazardous waste regulations, depending on what it has adsorbed. Thermal regeneration allows to be used reused, which reduces waste and cost. In some cases, spent carbon can also be reposted, for example, in construction materials or as a fuel source, but I think only it's those not contain toxic substances.
And there is another question on chat, or 3 questions. And do you think the removal of ACs from the seas could be possible?
Should I do answer on first only, or
you can answer 3 of them. You still have the time, so sure, go on.
So for the first, it is technically possible, but extremely difficult and costly due to the waste volume of seawater and the low concentration of contaminations. Prevention at the source is much more effective. Emerging contaminants can disrupt ecosystems, affect reproduction in aquatic spaces, promote antibiotic resistance, and be accumulated in the food chain. In theory, yes, some technologies allows for the recovery of specific compounds, but in the practice, it's rarely done due to high costs and complex separation process.
Is everything?
It's all.
Okay. Thank you for answering, and thank you again for your amazing presentation. And now I will thank you to all of us, to presenters for their excellent contributions, and thank you to the audience for engagement and thoughtful questions. And this concludes our 7th sessions. And now we'll be having a technical break to 2 p.m. And after that, we invite you to visit the poster sessions. The links to the meetings and the rooms are on the official site of our conference. And please refer to the official programs for details. We look forward to seeing you there. Thank you again, and see you there. See you on the posters session.
Hello, everyone. My name is Viktor Czyżów, and it is my great honor and pleasure to be chairing this oral communication session. Today, we have pre-recorded presentations, and each of these will be followed with a couple minutes of discussion. Our first participant is Martyna Myszograj from Poznań University of Technology. Martyna, are you with us?
Yes, hello.
Okay, hello. It's good to be hearing you, and now we are waiting for the video.
To present a brief overview of the side effects associated with epidural analgesia, a widely used but not risk-free method of pain control, especially during labor and surgery. An epidural injection is a type of anesthesia administered through a catheter placed in the epidural space of the spinal column. It's typically used for surgeries lasting over 2 hours or for prolonged pain relief, such as in childbirth or after major operations. The procedure involves inserting a large needle into the lumbar region, as you can see on figure 1, between the spinous processes of the vertebrae and carefully advancing it into the epidural space. A catheter is then threaded through the needle and taped securely to the patient's skin. The needle is removed, but the catheter can remain in place for even several days to allow for drug continuous administration. This method provides targeted pain relief without sedation, allowing patients to stay conscious while remaining comfortable. The most commonly used local anesthetics in epidural analgesia are lidocaine, bupivacaine, and ropivacaine. These agents block voltage-gated sodium channels on nerve cells, effectively halting the transmission of pain signals. Their effectiveness is influenced by their lipid solubility, protein binding, and degree of ionization, which determine how quickly and how long the drugs act. Moreover, to enhance analgesia, opioids like fentanyl or morphine are often added to the local anesthetic. These target opioid receptors, enhancing pain relief and reducing the dose of local anesthetic required. In some cases, vasoconstrictors like epinephrine are also used. These help to prolong drug action by limiting systemic absorption and improving localization. Together, these drugs create a powerful, targeted, and customizable approach to pain management, making it possible to adjust the treatment used in accordance to patients' needs. However, despite its many benefits like effective pain relief and lower systemic drug levels, epidural analgesia carries potential side effects depending on the drugs used in patient-specific factors. These risks can include neurotoxicity, cardiotoxicity, and other complications like hypotension, motor weakness, or urinary retention. So let's take a closer look at some of these. Neurological complications may arise due to chemical irritation, direct trauma, or ischemic injury. Although rare, they can be serious. There are some clinical cases described with accidental spinal cord injury during an attempted thoracic and lumbar epidural, which led to severe complications due to mechanical injury, as well as the drugs combination that was used. And the typical symptoms may include numbness, motor deficits, or persistent neuropathic pain, so they can be often overlooked by doctors, even if reported by patient, because to some stage, numbness and motor deficits are expected after administering such drugs. And in accordance to cardiotoxicity, among local anesthetics, bupivacaine is particularly known for its cardiotoxic potential due to its high affinity for cardiac sodium channels and unintentional intravascular injection can result in arrhythmias, bradycardia, or even cardiac arrest. So that's why there are some aspiration tests, test doses, and close monitoring that are essential during administration of this drug. However, there is also ropivacaine, which is often considered a safer alternative offering effective analgesia with less impact on the cardiovascular system, which is really important in case of patients that already have some risk factors of heart diseases. So when comparing bupivacaine and ropivacaine, both agents provide effective pain control for labor and postoperative care. However, ropivacaine is associated with significantly reduced incidence of motor block, allowing greater patient mobility, which is particularly valuable during labor. While both drugs have similar profiles regarding hypotension, nausea, transient lower limb weakness was more commonly reported with bupivacaine. Looking at opioid adjuvants, fentanyl improves onset and depth of analgesia, but is linked with a high incidence of pruritus, up to 48%, as well as nausea and occasional urinary retention. Nalbuphine, a mixed agonist antagonist opioid choice, similar analgesic strength with a lower risk of opioid-related side effects. It causes less respiratory depression, minimal sedation, and no adverse neonatal effects, making it particularly suitable for obstetric use. And patients receiving nalbuphine, ropivacaine reported higher satisfaction and needed fewer rescue doses. So to sum this up, the choice of epidural analgesic agents significantly affects both the quality of analgesia and the side effect profile. Ropivacaine is preferable over bupivacaine when reduced motor block is desired, so especially in labor settings. Fentanyl, while effective, increases the high risk of pruritus and nausea. Nalbuphine emerges as a safer alternative with fewer adverse effects. And all evaluated regimens maintained hemodynamic stability and did not adversely impact neonatal outcomes. Tailoring chemical agent selection to individual patients' needs can improve analgesic effectiveness and minimize complications. So it is important to look at the patient's needs and their health state, and then choose the best suitable option. And there are the references that I've used to prepare this project and presentation. And in the end, thank you so much for your attention. If you have any questions, please don't hesitate to contact me via email or on my LinkedIn. Again, thank you so much.
Thank you for your insightful presentation. And I can see we already have a couple of questions from the audience. First up is Natalia Wyżlic.
Hello, thank you for your very insightful presentation. I just wanted to ask if there are any studies how the drug influences, other way, if the other drugs than epidural are safe for the babies. For example, if we are talking about using them to the birth.
So there are also other chemical substances that are also used in the epidural injection. For example, there is also lidocaine, which is a much lighter, I would say, drug for anesthesia. However, it is not that commonly used anymore because we have other more effective ones, just like fentanyl and bupivacaine, which I just described. So I hope that answers the question.
Okay, but are they safe for the babies?
Yes, I believe I've said that there are ropivacaine and nalbuphine, which are they have the less risk of any neonatal negative outcomes.
Okay, perfect. Thank you.
Thank you so much for the question.
Okay, and I see another one question from the audience. And it says, what other systems can be affected by the usage of enhanced epidural analgesia?
One of the most important risks, I believe, is any mechanical disasters that may occur because epidural is done by inserting this large needle very close to the spine. So I think the most important negative outcome would be any mechanical damage to the spinal cord. So we could destroy the nervous system, for example. So I believe this is the most important one because I can't imagine being a new mom and yet being paralyzed from the waist down, for example. So in my opinion, that's the most important risk here.
Okay, thank you once again. And thank you once again for your great presentation. Now we will be moving on to Mr. Jakub Nagórny from Adam Mickiewicz University of Poznań. Let me know if you are here with us.
Hello, yes, I'm here.
Okay, we can hear you. Now we are waiting for the video.
Welcome everyone. In this communication, I would like to tell about selective functionalization of boryl alkanes via coupling reaction. This study was conducted in Center for Advanced Technologies at Adam Mickiewicz University in Franczyk group. So first, let's talk about synthesis of aryl boryl ethanes, which are well described, especially for Z isomers, and they can be obtained via hydroborylation or borylation of alkenes. But the E isomers are not so much described. Only in 2 papers I found some traces about them, and the synthetic protocols mostly contain the hydroborylation of aryl alkenes, and also the isolation of these products wasn't perfect. So where can these aryl alkanes can be used? Mostly they are used as building blocks because of the cyl and boryl groups and also the hydrogen atom, which via coupling reaction can be substituted to obtaining other functional groups like aryl or vinyl, which can lead to different compounds, mostly with biological activity. And in this study, we focused on the Suzuki-Miura coupling, which is the substitution of boryl groups using halogen aryl or vinyl, which lead to creation of new CC bond. And our research plan was to obtain diboryl ethanes using hydrosylation. After that, we used Suzuki coupling for obtaining mono and bis substituted compounds. We wanted this process to be very selective, and after that, we also modified the obtained free compound with one still remaining boryl group with another aryl. So in first step, we synthesized 2 aryl 1-boryl etanes, and firstly we wanted mono-substituted ones. We conducted optimization studies using different silyl substituted substrate, using triethyl and dimethylbenzyl silyl group, and as the halogen compound we used iodobenzyne. And for the ethyl group, triethylsilyl group, the tetrakis 3-phenyl-phosphine palladium catalyst was perfect, and after a few studies we figured out that we should lower the temperature of reaction and also the concentration of catalyst, because as we changed it, the selectivity of product 3 was better, and we settled down on these conditions, which gave us a very good selectivity of obtaining mono-substituted compound. And for the dimethylbenzyl silyl group in substrate, we had to use the palladium acetate and 3-phenyl-phosphine separately, which also gave very good selectivity. And using this method of synthesis, we obtained 12 products with different groups, which provide us with information that these groups like methoxy group or nitrile group doesn't affect the reaction and can be readily used in synthesis. And also one crystallographic structure of one product was obtained, and we also obtained 4 different vinyl-phenyl compounds, and also we've got one crystallographic structure of this compound. After that, we tried optimizing the conditions for obtaining bis adducts of these compounds. And as we saw before, we had to use a higher concentration of catalyst and also higher temperature. So that's what we did. And after optimizing, we chose these conditions for the reaction. And thanks to them, we obtained products with high selectivity and yields. And also we were able to confirm the structure of one product with crystallographic analysis. And after that, we also tried modifying previously obtained compounds with different aryl groups for obtaining final product with different aryl groups. And for this, as we said in previous part of the study, we had to use more harsh conditions, so more catalyst and higher temperature, which led to obtaining of 4 new products. And in conclusion, boryl silyl alkanes can be used in organic synthesis as building blocks, which can help in obtaining complex structures with like biological activity. Also, protocols for selective modification of boryl silyl alkanes were created and optimized based on E-diboryl silyl etanes, which were synthesized by hydrosilylation of boryl alkenes. And these procedures allow for selective modifications of 1 as well as 2 boryl groups in one reaction in one pot. Also, synthetic protocols for modifying boryl silyl alkanes with 2 different aryl groups were developed, and during the research we obtained 21 products, 17 of which were firstly described in literature, And all of these products were fully characterized via GC-MS and NMR analysis. And also the crystallographic structure of 3 compounds was determined. And I would like to thank the National Center for Research and Development and Adam Mickiewicz University for funding the research, and also thank you for your attention.
Thank you for your presentation. It was very interesting. Now we are getting to the questions panel. Does anyone from the audience have a question to Jakub? Okay, I can see a raised hand from Krzysztof. Go ahead.
Hello. Hi. I know this your research is mostly about the mechanism, but do you have an idea or a concept for what purpose your compounds can be useful?
Hello, thank you for your question. Well, we mostly try to see how these procedures work to project to show that these building blocks can be used in synthesis of complex compounds like drugs or imitants of natural compounds, because some compounds can be difficult to obtain from nature. That's why we can use these synthetic building blocks for obtaining these products.
Okay, thank you.
Okay, any other question from the audience? Well, if not, then I do have a question about the Suzuki-Miara coupling reaction that you said you used, and does it have like advantages over other methods of synthesizing the boryl alkanes?
So Suzuki-Miara coupling is mostly used in substitution of boryl groups, and as far as I know, it's one of the most commonly used way of modifying the boryl group. It also is very selective and very efficient, and as you saw, all the reagents they are commercially available, so it isn't like very exotic reaction. It's pretty common in organic synthetic.
Okay, thank you once again, and thank you once again for your presentation. Next up, we have João Lincho. Are you with us?
Hi, hello. Yes, I am.
Okay, everything is working. That's nice. Then we are waiting for the video.
Hello, my name is João Lincho. I am from the University of Coimbra in Portugal, and I'm here to present our work entitled The Effect of Titanium Dioxide Nanotubes Reduction for Wastewater Treatment by Photocatalysis. Planet Earth is constituted by about 70% of water, but we can only use a small part. It is known that water demand and water shortages are increasing, and it will continue to increase in future, in which today we already feel the effect of water scarcity events. Around 4 billion people suffer from lack of water at least 1 month per year, while 500 million people face severe water scarcity all year. Thus, the solution to reduce the water scarcity problematic is the reuse of treated wastewater. Apart from water scarcity, there is also the problematic of water pollution, in which several contaminants of emerging concern are being detected in several water resources worldwide. The occurrence of these contaminants in nature may cause adverse effects in animals, ecosystems, and humans, and therefore we should avoid it. There are several causes for water pollution, such as industries and intensive agriculture, the release of untreated wastewater to the environment, and the poor wastewater treatment. The poor wastewater treatment occurs because the wastewater treatment plants are not designed to remove this kind of contaminants, and therefore effective advanced treatments are required to avoid the release of these contaminants to nature. The advanced oxidation processes are a group of technologies that use hydroxyl radical for the degradation of organic contaminants. Among OPs, photocatalysis is a very suitable technology because it's simple and uses a photocatalyst and radiation. The photogenerated radicals are going to react with organic compounds and transforming them into carbon dioxide, water, and even degradation products. The most commonly used photocatalyst is titanium dioxide that is usually employed in powder form. However, this dificults the industrial application because it requires complex separation to recover the materials from water, and it has a limited reuse. So, to apply the photocatalysis at industrial scale, the titanium dioxide should be supported or immobilized. One interesting way to obtain supported titanium dioxide is through anodization that generates the titanium dioxide in the form of nanotubes. This type of nanostructure is beneficial because it presents several advantages as high surface area, better light absorption, or lower electron-hole recombination. There are others, that is the easy separation from liquid phase. It can be reused multiple times without losing efficiency, and it can be even scaled up, which is very important for the application at large scale. However, the titanium dioxide still presents a high band gap energy of 3.2 electron volts for anatase. That is a most pretended crystallite phase, since it has high light absorption, high lifetime of electron-hole charges, and lower recombination. Thus, due to this band gap energy, the titanium dioxide is dependent on UV radiation. However, it is possible to modify the titanium dioxide and allow visible light activity and even enhance the performance of titanium dioxide under solar radiation. There are several ways to modify the titanium dioxide. Strategies as doping, metal decoration, dye photosensitization, or the creation of heterojunctions with visible light materials are seen. Other interesting way is introduction of defects into the titanium dioxide lattice, and this is interesting because it's a simple method that can be made just by annealing the amorphous titanium in releasing atmospheres as nitrogen, hydrogen, or argon. Therefore, in this work, we created titanium dioxide nanotubes for anodization using ethylene-glycol electrolytes, and then we did annealing of these nanotubes at 3 different conditions. One using air at 450 for 1 hour, the other using air at 450 during 1 hour with a posterior reduction in hydrogen and argon atmospheres at the same temperature and time, and the other was the direct reduction of the amorphous titanium dioxide nanotubes in the hydrogen and argon atmosphere at 450 degrees at the 4 during 1 hour. After it, we did the characterization of the samples by SIM, Raman, UV-Vis, DRS, and photoluminescence measurements, and then we used the same samples for the photocatalytic degradation of a phenol solution under UV-Vis and visible radiation, and for the degradation of a paraben solution under UVA radiation. The result by SIM shows us that the titanium dioxide nanotubes obtained and that were annealed in the air environment with or without a posterior reduction maintained the nanotubular shape, while the samples that were directly annealed in the reduction in the reducing atmospheres presented the loss of nanotubes. In fact, it is possible to see that this new structure is homogeneous along the sample, although there are some signs of remaining nanotubes that can be sometimes seen in the sample. This suggests that the nanotubes were converted into some kind of new grain-like shape during the direct reduction of the amorphous titanium dioxide in the hydrogen and argon atmosphere. We think that this did not occur for the samples previously annealed in air, because probably with the transformation of amorphous titanium into diatomaceous titanium dioxide, a higher stability can occur, and therefore the transformation or the loss of the nanotubes did not occur. Regarding the crystallite phase, all the samples present anatase phase, which is expected due to the selected temperature of 450 volts, 450 Celsius degree. And it is also seen that the reduced samples present higher intensity than the sample directly annealed in air. In fact, the sample that was annealed in air and posteriorly reduced in the reducing atmospheres presents higher intensity, which can be related to annealing treatments, while the directly reduced titanium dioxide also present higher intensity than the sample annealed in air. Other interesting thing that we see in the samples is a slight shift in the first band of Raman. That is a common characteristic that is seen in literature for the samples that are reduced. Regarding the optical properties, it is possible to see that the directly reduced sample present higher light absorption in the UV and the visible range. And when we calculated the band gap energy for the samples, we see that the samples that were calcined in air as a band gap energy of 3.3 electron volts, while the directly reduced sample has a band gap of 3.4 electron volts. The photoluminescence measurements also showed us that the reduced titanium dioxide nanotubes present lower recombination of electron-hole pairs, which can benefit the photocatalytic degradation of the contaminants. However, when we tested the samples for the degradation of phenol, we saw that the degradation was worse for the sample directly reduced in hydrogen and argon atmospheres. We did not observe visible light activity. In fact, we only had about 1 to 2% the removal of phenol, in which we think that could be related to adsorption. And when we did the degradation of the parabens mixture under UVA radiation, we also saw the same. That is, the photocatalytic degradation of the parabens were worse for the sample directly reduced in hydrogen and argon atmospheres. We think that these results can be related to the loss of the nanotubular morphology, because the reduced samples present better characteristics, such as the crystal, the higher intensity in the crystallite phase, but also better light absorption and lower recombination. However, more work should be done. We can pass by testing other reducing atmospheres and even optimize the reduction conditions to see if it is possible to have the degradation of water contaminants under visible light, and even to improve the degradation of the contaminants under UV radiation. Therefore, with this work, we obtained the titanium dioxide nanotubes by anodization, and we did the annealing in 3 different atmospheres with the objective of reducing the nanotubes, the titanium dioxide nanotubes. The directly reduced titanium dioxide lost the nanotubes morphology, and the anatase crystallite phase was seen for all the samples due to the temperature that was selected, with the reduced titanium presenting higher Raman intensity. The band gap energies were about 3.3 and 3.4 electron volts, with the reduced titanium dioxide presenting better radiation absorption, but also lower recombination of the photogenerated charges. The photocatalytic degradation reactions revealed us that the reduced titanium dioxide led to a lower photocatalytic activity, which can be related to the loss of the nanotubular morphology. Moreover, no significant visible light activity was verified in which the removal of 1 to 2% of phenol can be related to absorption. Future work should pass by the characterization of the samples, test and optimize different reduction conditions, and even test these samples in another OP technologies. We want to thank to our National Science Foundation for the financial support, and also to this conference organizers for the invitation and for the good work in organizing this event. Thank you so much for your attention, and I'm here to answer to your questions. Thank you.
Thank you for your presentation. It was really interesting. Do we have questions from the audience? Well, then I will. Oh, okay. Krzysztof has a question.
Yes. Hi. Thank you for the presentation. You said that the titanium dioxide nanotubes have better absorption, but lower efficiency of the during the photocatalytic reaction. Is I understand it good?
Hi. Yes, the UV-Vis DRS showed us that the reduced nanotubes, the reduced titanium dioxide, add the more light absorption in the visible and the UV region, and for us it was really interesting to see the application of the materials for the photocatalytic degradation of contaminants, because we were expecting that this material would be better than the other without the modification, but this was not what we saw. So we think that if these materials have more absorption, more light absorption, so the reason for the photocatalytic degradation be worse should be related to the loss of the nanotubular the structure and the advantages that this kind of structure can bring to the materials. But it was really interesting to see the properties and then see the effect on the degradation of the contaminants. I don't know if I was clear.
Yes. It could be a second question. I want to ask you also, how do you explain this phenomenon? But you automatically answer for for both questions. So thank you once again.
Okay, and we have question in the chat from Lucia Ptach. What criteria did you use to select phenol and parabens as model contaminants for evaluating photocatalytic activity? Hello, can you hear us?
Oh, sorry, everyone is hearing? No?
Now, yes.
Oh,
now
okay.
we hear
We selected the phenol because it's a common industrial contaminant that is used in industries and then seen in the industrial wastewater. And regarding the parabens, we selected these contaminants because they are products that are widely used in pharmaceuticals, food, and personal care products as preservatives, and they are also being detected in several water in river around the world. So that was one of our things to use such contaminants, and because also the parabens are also associated with some problems to animals and even humans. There are some studies relating the use of parabens to the appearance of cancer, and even we had regulations a few years ago that forbidden the use of some kind of contaminants. But in this case, those ones were not were not the parabens that we used. The ones that were forbidden, I think it was butyl paraben and benzyl paraben, and here we used the methyl, ethyl, and propyl paraben because they are the most used in the industries that I said.
Okay, thank you.
Okay, thank you so much.
I have a question too, maybe more of an insight than a question. Have you thought about changing the annealing conditions? Because you said that in the future you wanted to change the reduction conditions and the testing conditions, but you didn't mention the annealing conditions. Is this due to the specificity of the method used, or is anything else like holding you back, or did you just decided for these conditions?
Okay, thank you so much for your question. You know, in fact, I didn't thought about it, but maybe it can be an interesting thing to see and to analyze. And because I selected this temperature because in previous works using only the calcination, the annealing in air, they were the best conditions. So that's why I selected this temperature and even this time of annealing. But yeah, for sure, it can be an interesting thing to see if the behavior is the same using different temperatures. Okay, for sure. Thank you so much for the question.
Okay, thank you so much, and thank you again for your presentation. Next up, we have Alicja Podemska from Adam Mickiewicz University in Poznań. Are you with us?
Yes, I'm present.
Okay, great. So now we are waiting for the presentation to show. Great.
Ladies and gentlemen, today I would like to present a topic that combines two seemingly unrelated environmental problems, but brings a surprisingly innovative and promising solution for the future. I will talk about used cigarette filters, one of most common and toxic type of waste, and how they can potentially be reused to clean up oil spills in the oceans and seas. Let's start with problem of marine pollution. Over the past decades, the world has witnessed many catastrophic oil spills, often resulting from accidents involving tankers or drilling platforms. These events have left long-lasting scars on the environment, affecting marine biodiversity, coastal communities, and the global perception of oil-related industries. One of most famous disasters is the Exxon Valdez oil spill that occurred on March 24, 1989 in Prince William Sound, Alaska. After the supertanker hit Blind Reef, about 11 million gallons of crude oil leaked into the ocean. The spill polluted more than 1,300 miles of coastline and killed hundreds of thousands of seabirds, fish, otters, and other species. The environmental impact is still being studied today, more than 3 decades later. Another major accident was the Amoco Cadiz disaster on March 16, 1978. The ship ran aground on the port Saul, rocks off the coast of Brittany, France. It broke into 3 pieces and released more than 220,000 tons of crude oil, contaminating more than 300 kilometers of coastline. This spill remains one of the largest in history and underscored the need of international cooperation in preventing marine pollution. More recently, the explosion of the Deepwater Horizon drilling platform on April 20, 2010 in the Gulf of Mexico has become the defining environmental crisis of the 21st century. The platform burned for 36 hours before sinking, causing the largest marine oil spill in U.S. history with long-term environmental and economic consequences. Satellite and aerial imagery captured the spread of oil across the ocean's sources, but even more disturbing were the invisible toxic compounds of oil that were spreading beneath of the sources, affecting marine life at a microscopic level. Fishing area had to be closed and entire ecosystem were disrupted. On the map, brown indicates the extent of oil visible on satellite and aerial imagery. Yellow indicates the extent of toxic compounds of oil invisible to satellites. Blue indicates the extent of non-toxic compounds of oil, and a dash line indicates an area closed to fishermen to prevent contamination to catches. Oil spills are not isolated events. They are the result of growing demand for the transporting and storage of oil, driven by domestic, recreation, and industrial use. Whenever caused by human error, technical failure, or natural disaster, their consequences are always serious and far-reaching. The presence of oil in water leads to devastating effect. It creates a layer on the surface that blocks sunlight, interfering with photosynthesis in aquatic plants. It also clogs the feathers and fur of birds and marine mammals, reducing isolating and biomass. It contaminates food chains, causing long-term reproductive and genetic damage to fish and invertebrates. In such situations, sorbents come to the rescue. These materials can absorb and adsorb oil from water and are dividing into the three main groups. Natural organic products such as cotton, wool, or keratin-based materials, inorganic mineral products such as zeolites, synthetic organic materials including polypropylene, polyurethane, polystyrene, and polyacrylate. While synthetic sorbents are often effective, they are also expensive to produce and are not environmental friendly in themselves. This begs the question, can we transform an existing waste product into an oil cleaning material? This brings us to the second part of my presentation, which means cigarette filters. Cigarette butts are one of the most commonly thrown away items in the world. An estimated 4.5 trillion filters are thrown away each year. They are found on streets, in rivers, on beaches, and unfortunately in oceans. These filters release toxic substance into the environment, including arsenic, nicotine, heavy metals, and polycyclic aromatic hydrocarbons. The filters themselves are not toxic, as they are made of cellulose acetate, which has gained the sympathy of cigarette manufacturers due to its low production cost. Cellulose acetate is created by acetylating of cellulose, a polymer found in wood pulp. This process involves treating cellulose with acetic anhydride in the presence of a catalyst. The result is flakes of cellulose acetate, which are then dissolving in acetone and spun into fiber, ultimately creating a cigarette filter. Now, things get interesting. Researchers at Coventry University in the UK, including Now things get interesting. Researchers at Coventry University in the UK, including Augustin Ifelebuegu, have developed a method for recycling used cigarette filters into hydrophobic sorbents for cleaning oil spills. The process begins with collecting and cleaning the filters. They are crushed, then soaked in ethanol using ultrasounds to remove contamination. The filters are then treated with sodium hydroxide to roughen the sources. They are then thoroughly washed with distilled water until clear and dried in an oven at 70 degrees Celsius for 24 hours. To make the material hydrophobic, meaning it repels water and attracts oil, the surface is functionized using chemical vapor depositing. The filters are exposed to vapors of methyl 3-chlorosilane or methyl 3-methoxysilane, which bind to the sources and create a porous structure that attracts oil. The final product is a sorbent made from what was once hazardous waste. Tests show that these modified filters can effectively absorb oil from water without releasing toxic substances back into the environment. This idea is a great example of what we call waste valorization, giving waste a second life, not only reducing pollution, but also contributing to solving another environmental problems. In conclusion, I believe this topic shows how interdisciplinary thinking, combining chemistry, environmental science, material engineers, and can lead to truly innovative solution. Recycling cigarettes into sorbents solves two problems at once: the massive scale of cigarette butt pollution and the challenge of cleaning up oil spills. Thank you for your attention. I hope this presentation has encouraged you to see the potential in unexpected place, and that even something as small as harmful as used cigarette filters can become part of the solution to a global crisis.
Thank you for your presentation. And now we will be moving to the discussion. I can see one raised hand from Natalia Wierzchowska. Go ahead.
Yes, hi. I just wanted to ask you if you know if those filters, those modified filters are reusable. Can we use them? Can they be recovered and used multiple times without significant loss of efficiency?
I'm sorry, but I don't have information about that. But I think this should be also explored, discovered, or not.
Okay, so the group that was studying those filters didn't include this study, right?
Yes.
Okay, thank you.
Please.
Okay, and we have a question from the chat. What challenges do you foresee in scaling up this approach for practical application in real-world oil spill scenarios?
I think this can be used practical, but we have to put a lot of work how to get used cigarette filters, and also to do it more technology, more scale.
Okay, thank you. And a question from Krzysztof Polaczek.
Hi, hello. Thank you for the interesting presentation. I have a question. Is those filter who can be used for filtration of the pollution? It's have to be only brand new, or they could be also used in example after the smoke cigarette, because I think everyone who ever smoke a cigarette know how those filter looks like, and I don't know if there can be used for anything.
That's what about this presentation was, because you have a used product which is toxic, and you clean it up and try to recycling it to do something like that.
Oh, okay. I missed the point when you said that they should be cleaned previously. Of course, yeah. It's of course make a lot of sense. Thank you so much.
You're welcome.
Okay, I don't see any more questions, so thank you once again for the entertaining presentation. Maybe all of us will start looking at cigarette butts differently from now on. And now we will move to our final speaker of this panel, Catarina Fernandes from University of Coimbra. Are you here with us?
Hello, yes, I'm here.
Okay, great. Then we will move on to see your presentation.
Hello, everyone. My name is Catarina Fernandes, and I'm a PhD student in chemical engineering at University of Coimbra, Portugal. I am in the final stage of my PhD, and today I'm going to show you a brief overview of these last 4 years working with lignin valorization for the development of sustainable hair care formulations. This work is motivated by the importance that hair has for us humans, not only related to its biological functions, such as protecting the scalp or its role in thermoregulation, but also because of its significant impact on a person's image and consequent self-esteem. This leads to a high demand for cosmetics, and particularly hair products, to improve the statistical and physical properties of hair, namely decreasing the frizz effect and improving the manageability and shine. But to understand how can we improve our products, it's essential to first understand the hair structure and the problem we want to address. So hair is a fibrous biomaterial that has a hierarchical structure and that is mainly composed of proteins. At the surface, the fibers are covered by a lipidic layer that is chemically linked to the proteins. This layer, that is called F layer, is the first barrier of the hair fiber, and its hydrophobic nature is responsible for the luster of a healthy hair and for decreasing the repulsion between fibers that is characteristic of frizzy hair. But because our hair is constantly exposed to various factors, its surface gets degraded. This can happen by mechanical damage caused by brushing the hair, or environmental degradation due to exposure to UV radiation, or chemical or thermal procedures applied to hair. These factors will degrade the hair surface, particularly the F layer, and the hair surface will change from a highly hydrophobic to more and more hydrophilic and negatively charged surface, bearing a high density of negative charges that are responsible for the static electricity and freeze effect of damaged hair. To overcome these undesired effects, we can use hair conditioners. One of the classes of conditioning agents is cationic conditioners, which are positively charged compounds that can electrostatically interact with negatively charged hair and remain attached even after rinsing, helping restoring the lubrication and smoothness of hair. Commercial conditioning agents are, of course, highly effective at treating hair. However, these compounds are usually from non-renewable origin, are poorly biodegradable, and present high toxicity against aquatic organisms, which means that when we are using these products on a daily basis, we are constantly releasing these harmful compounds to the environment. To address these problems, the goal of my PhD is to develop new cationic conditioning agents derived from lignin and study their application in hair formulations. Lignin was selected due to its high availability, since it's one of the main components of lignocellulosic biomass, such as wood. It also has other advantageous properties, such as its biocompatibility and also the UV protection that could be beneficial for further protection of hair. To accomplish these goals, the work was divided into 4 main stages, starting from the extraction of lignin from the wood using green extraction methods, followed by a second step where lignin was chemically modified to improve its interaction with hair. Then we studied the interaction of these lignin derivatives with hair, and finally some preliminary formulations were developed and characterized. In the first step, lignin was extracted from acacia wood, which is an invasive species in Portugal, and contain about 20% of lignin, and it was extracted using deep eutetic solvents of natural origin, using this experimental setup where the solvent can be reused at the end of the process. The solvent composition and the extraction temperature were then optimized to maximize the extraction performance, and after conducting a design of experiments, we found the most relevant parameters affecting the extraction and achieved a process that could extract almost all the lignin present in the wood with a purity of over 90%. In the second stage, we introduced some cationic groups to improve lignin solubility and to enhance its interaction with negatively charged hair. Here, we followed a cationization reaction with GTAC for 3 hours and optimized the reaction temperature and the GTAC to lignin ratio to maximize the conversion. 2 responses were evaluated, which were the degree of substitution and the surface charge by measuring the zeta potential. And we can see that depending on the conditions, we can change from a highly negative lignin to cationically charged polymer after cationization. Then 2 of these derivatives were tested regarding their toxicity against aquatic organisms. The tests were conducted with organisms of different trophic levels, and one commercial polymer currently used in some haircare products was also used for comparison. We can observe that for some species, and especially in the case of rotifers, the commercial polymer in black presents high toxicity, showing 100% mortality at the studied concentrations, whereas the lignin derivatives are safer at higher concentrations, presenting high toxicity only at the highest concentrations. This reveals that the developed polymers are more environmentally benign than some of the current use options. Then we evaluated the potential of these derivatives to interact with hair, and for that we prepared aqueous solutions of these lignin polymers and applied them to real hair. And then the hair was rinsed to simulate the real application, and we can observe in this image that even after only one application and rinsing, the appearance of the hair is affected. These hair samples were then evaluated by surface potential measurement to check for the change in the hair surface charge after the treatment. Here we can see that untreated hair presents a surface that has low surface potential, being nearly neutral to negatively charged, what was expected for a damaged and untreated hair. And after treatment and rinsing, the hair surface becomes highly positive, which is a proof that lignin has the ability to bind to the hair surface and remain attached after the rinsing process. Finally, some formulations were prepared with these synthesized lignin derivatives. And this part of the work was conducted with the collaboration of these master students who prepared and characterized different formulations and evaluated their stability and shelf life. These conditioners are also being optimized using a design of experiments to achieve an optimal formulation. Here we are varying the content of the thickener, lignin, surfactant, and vegetable oil. And we can, for example, see the visual difference of the formulations by changing the lignin content. So lignin content not only can affect its physical properties, but also the final look of the formulations. All prepared conditioners present the desired rheological profile, and by changing the composition, we can adjust the final viscosity of the product to the one that is desired by the consumer. The rheological profile showed to not be affected by storage, and some of the formulations were very stable for a reasonable period, and even after accelerated aging conditions such as centrifugation, where no phase separation was observed. Although this work is in its final stage, as future work, it's necessary to test the efficiency of those formulations when applied onto real hair, assessing the toxicity of these derivatives and formulations to the skin, and further characterizing the conditioners regarding their shelf life and sensory properties. I would like to finish my presentation by thanking the team involved in this project, especially my supervisors and the master students who helped me with the experimental work. I'd like to thank FCT for the financial support, and of course, thank you all for your attention.
Thank you for your presentation. And now we will be moving to the discussion part. So does anyone from the audience have a question? Okay, I can see a question from Natalia Wierzchowska. Go ahead.
Hello, thank you for the presentation. It was really interesting. I wanted to ask, because you said at the beginning that you are at the end of your PhD, and at the end of your presentation, you showed us the future work. Are you still going to be a part of this future work, or with the PhD, you're giving it to somebody else?
Thank you for your question. It's actually difficult to answer these. We also had a project, like a short project, that ended this year. So now my PhD is finishing, and also this project is finished, but we are considering to probably submit like a second part for a continuation of this work, because we are having promising results. This is actually the first time that lignin is used as a conditioning agent. So I think this is promising, but as I said, we are still in need of some cytotoxicity tests. So we can prove that these can be effective for the application, but to move forward to a product, we need to ensure that this is not toxic for humans. So the first goal of my PhD was to address the environmental impact, and we have proved that our derivative is better, but we cannot only protect like aquatic organisms, we need to protect ourselves. So we don't have yet results from this part. And I think it would be useful to do that after I finished. I don't know if it will be for master thesis or if we could get some application for extending the project. Thank you.
Okay, thank you very much. And will you be also studying the toxicity of your product on the aqueous system, you know, like fishes or something? Because still it goes, when we use it, it goes back to the environment if it's not cleaned properly. I mean, the water, wastewater.
Yes, we have performed some toxicity tests on aquatic organisms, but the major issue here is these derivatives are new, so we don't know how they will be in the real wastewater. Sure. Because what we tested was the compounds that themselves. So we need to find some concentrations to test it, because one thing is the concentration in the bottle, and other thing is what it goes to the river, for example, or at the sea. We are also doing this at the sea level, because we have the wastewater treatment plants, so part of it will be removed. And also we need to test for a longer period the degradation products, because we know that our derivative has this structure at the beginning in the bottle, but when it goes to the river, it will be already degraded. So we don't have this information now. We have this comparison with the commercial polymers, but they are all in their native stage. And now we are doing some tests for the degradation products to see that.
Okay, thank you very much and good luck.
Thank you.
Okay, are there any more questions from the audience? Okay, I have a question though. The last question was about the product after it is being made and used, and my question is about the process beforehand, because if it would be to hit the shelves and be sold, then one question is like needed to be asked, whether it's economically feasible to make it, and how it is in terms of scalability. So if it can be made large scale.
Okay, thank you. In terms of the economical aspect, we didn't yet do this analysis, but I know that, for example, cellulose derivatives are already used, and with this type of cationization. So what I think is that if cellulose and lignin are coming from the same source, and cellulose is already in some conditioner products, I think after optimization and scaling up, the economical part will be similar, at least at these derivatives. I believe that these will be probably a little bit more expensive than the petroleum-based ones, because everything is optimized for that. But as everything, it will be dependent on the optimization, large-scale studies, and of course, like the demands of the consumers. If consumers want this product, and sometimes people ask me about the color, because some people think that color could be a problem for some consumers, but we already test that, and it doesn't stain the hair. So if this is intended to be used and rinsed, so there's no problem. So I think it will depend on the market. So probably it's not for all the consumers, but in terms of the scaling up, I think it is simple after all the challenge of scaling up. So we are doing this at a lab scale. So we are optimizing the formulation for stability at this scale. And of course, if we have like a partner, industrial partner, and we try to do a scale up with this particular formulation, probably it will not be the same as everything else. So it will require a new optimization at the real scale, of course.
Okay, thank you for your thorough answer. I will speak in the name of everyone with longer hair. Good luck to you with this, if you plan to expand on this after all. Okay, so once again, very interesting presentation. Thank you.
Thank you.
Okay, now we will be moving to the part that is technical break, and it will last until 12 a.m. London time, and we will hear each other either on the B session or A session. As a reminder, they're both available on the website, so it is up to you which one will you attend. Thank you, and see you later.
Good afternoon. I would like to welcome you all to the 7th section B of the Oral Communications at the Natural Science Baltic Conference. My name is Natalia Wierzchowska, and I am a PhD student at the University of Gdańsk, and I have the honor to be the chairperson of this session. I would like to remind you that the presentation time is 12 minutes, and then there will be about 3 minutes for discussion. Without further ado, I would like to welcome our first presenter, PhD student, Mr. Wojciech Wilczyński from University of Warsaw and Polish Academy of Sciences in Poland, who will give a presentation in form of a video. Mr. Wilczyński, please confirm your attendance.
Yes, hello.
Great, thank you. Now we can share the video. Okay, and we can start. Edyta, we can't share, we can't hear the video.
Let me try it again.
Hello, my name is Wojciech Wilczyński. I'm a PhD student at the University of Warsaw and a toxicologist at the Polish Academy of Sciences. I study chemical warfare agents, which are working agents in legacy weapons of mass destruction, the chemical weapons. And these chemical weapons were submerged in the seas and the oceans worldwide during the 20th century. In our Baltic Sea, there's also quite a large amount of chemical weapons dumped, with the biggest dumping area of the Bornholm Island. And luckily, these chemical weapons were mostly dumped in very deep areas, with the exception being Little Belt area. Now these chemical weapons resting at the bottom of the ocean, the sea in this case, are corroding, and chemical warfare agents are leaking out into the surrounding water and sediments. This raises concerns, and therefore several international projects such as Diamond, Modum, now Munimap, were launched in order to assess the risks associated with the dumped chemical weapons. A reliable risk assessment requires toxicology data for chemical warfare agents in aquatic organisms. And that was the goal of my studies. I wanted to assess the toxicity of several different chemical warfare agents in fish, and both the short, so acute term toxicity, and the long-term toxicity, the chronic toxicity, with several different biomarkers. I used basic toxicity thresholds, such as the median level concentration, a concentration that kills half of the study population, and effective concentrations that affect the given parameters by a certain percentage, like 10, 20, or 30% effects. I also estimated the bioaccumulation of chemical warfare agents in the muscles of fish, so how easily they can enter the food chain, maybe if they can pose any harm to the seafood consumers. I estimated markers related to oxidative stress possibly induced by chemical warfare agents, and markers in order to find out if the microbiota is disturbed, which is new in ecotoxicology. So I will start with the short-term toxicity test, so acute. I tested each chemical warfare agents in 10 concentrations, and I tested 8 organoarsenicals and 6 organosulfur compounds. These are both chemical warfare agents and their degradation products. And they are quite commonly found in the sediments of the Baltic Sea, some of them even in the tissues of fish. I used the OECD test number 236 with the model organism Danuario, and the experiments had a duration of 96 hours, short-term tests. Starting with results on organoarsenicals, only 3 of them were toxic, Clark1, Adamsite, and PDCA. And they were very, very toxic according to the criteria of GHS, with the LC50s being in the red frames here. The lowest is for Clark1, and these LC50 values were actually way lower than predicted by earlier mathematical models. So the toxicity was underestimated, and now we know that these compounds are very, very dangerous to aquatic life. When we look at the degradation products of chemical warfare agents, they are non-toxic, even as the highest tested concentrations in the OECD tests. So this is in line with the mathematical modeling, except for TPA. TPA was actually modeled to be very toxic, but it turned out that in the toxicity tests it was non-toxic. So that's interesting. I believe that it could have been because in the early life stages of fish, the chorion is protecting them, and TPA has quite a bulky molecular structure, so maybe it could not permeate the chorion. For the organosulfur chemical warfare agents, TDGA and the oxaditiepan were toxic, well, not even toxic, they were harmful to fish according to the GHS, with the LC50s being around 70 and 14. Now the other degradation products of organosulfur chemical warfare agents were non-toxic, but it's worth noting that TDGA was actually toxic due to its pH. It was lowering the pH, and when we buffered it, it was also non-toxic to the experimental animals. When we look at the chronic toxicity tests, I used a different approach. I only studied two compounds. These two compounds are Adamsite and TPA. They are compounds with the highest realistic risk profiles in the Baltic Sea among the chemical warfare agents that were dumped. I tested each of them in 5 concentrations using the OECD test number 215 for chronic toxicity. Again, the model organism was Dinorrhea, and the experiments took 30 days each in 3 replicates. That's why the number of compounds is so low. Starting with life history, Adamsite severely affected life history of fish with the most pronounced effects at the highest tested concentration, 0.25 micrograms per liter, so really trace concentrations, and you can see this reduction of around 30% in both body length and growth rate in this concentration. For TPA, the effects were way more mild, but they were still there. At higher concentrations than Adamsite, the effects were smaller, but it is still high chronic toxicity, which is unexpected because TPA was non-toxic in the acute toxicity tests. So this further supports the hypothesis that the chorion was protecting fish embryos in the early life stages. For the mRNA expression, the mRNA expression of oxidative stress-related genes, so catalase, superoxide dismutase, etc., was elevated with increasing Adamsite concentrations. Really highly elevated at the highest tested concentration. In catalase it was up to around 50-fold change, and in superoxide dismutase more than 250-fold change. So huge effect. And when we look at TPA, it was quite different. We can see here a bell-shaped curve response, possibly due to some bioenergetic trade-offs. Maybe it was this toxic. When we look at the enzymatic activity of these same oxidative stress-related enzymes, in both cases of Adamsite and TPA, the enzymatic activity was increasing with increasing toxicant concentrations. The effects were way higher in Adamsite, but in this case we cannot see a bell-shaped curve in TPA. Anyway, these results on oxidative stress biomarkers certainly indicate that in both compounds there is significant oxidative stress in the gills of fish. When we look at the bioaccumulation, starting with TPA, TPA was effectively bioaccumulating, which is apparent with increasing compound concentrations in water. But it was mostly bioaccumulating in its oxidized form, so it was metabolized. Now the question is whether it was metabolized by fish or by bacteria. My results suggest that it was metabolized by bacteria because I've done a PyCast analysis of the microbiota of the fish, and it seems that there are genes related to degradation of aromatic compounds like TPA were increasing in relative abundance with increasing TPA concentrations. So possibly the microbiota, the microorganisms present in the gut of the fish have helped metabolize TPA into its non-toxic form. For Adam's side, it was accumulating in the tissues of fish at a smaller rate, but at also apparent with increasing concentrations and in a non-degrade form. When we look at the PyCast analysis this time, we can see that genes related to the degradation of aromatic compounds were decreasing with increasing Adam's side concentration in the microbiota. So to summarize, well, I've tested 14 different chemical warfare agents for acute toxicity and 2 of them for chronic toxicity. There is still a lot to be done in this matter in order to get all the necessary toxicological data, but I believe that we are heading in the right direction and that the incorporation of multiple different biomarkers in this analysis helps broaden the understanding of the observed toxicity response. So that is everything for today, and I would like to thank my colleagues, my team, who helped me with all the experiments and the analysis, and here is my funding sources for the research. So also thank you for your attention, and I will end it at the references. I would welcome any questions if you have any.
Thank you for your presentation. Of course, as Mr. Wojciech said, we welcome any questions. Do we have any questions? I can't see any yet, but I'm interested because why don't we just remove the cause of the leaking of those chemicals to the environment?
You want to get them out of the water?
Yes.
Well, that's difficult because there's a lot of them. There's like 1 million tons of them worldwide dumped into the seas and the oceans, and they are quite deep. So in the Baltic Sea, you have them mostly in the Bornholm Deep area, the Gotland Deep, the Gdańsk Deep, and in the Bornholm Deep, where there's the most of them, there's 40,000 tons. They are at 100 meters deep, so it's not easy to get them out, and it would cost several billions of euro to even clean up a small part of the Baltic Seas. I don't see that's feasible. Maybe one day when it's more advanced. I know that some corporations are working on solutions to get them out. I believe it's Geofusion. There's a company like that, but it's still far off, I think.
Okay, it's interesting because you said that it would cost a lot to get them out, but like financing the studies to prevent to study the fishes, the water, to find the solutions to the problems isn't cheap also. So it just, why don't go to the cost of this problem?
I am not an oceanologist. I don't know.
I
I'm just
understand.
doing the toxicity.
Okay. Do you have any other plans for your future work?
Oh, yeah, I wanted to make a team, but my grant opus was not approved, so I'm just lost now. But
And
maybe one day.
okay. So anybody else would like to ask something, our presenter? Well, if you want to ask something, please write it in the chat. And thank you again for your presentation. It was very interesting. And now it is my pleasure to introduce our next speaker, PhD student, Miss Weronika Piątek-Gołda from Maria Curie Skłodowska University in Poland, who will give a presentation in form of a video. Please confirm your attendance. Miss Wiktoria Piątek-Gołda, are you here with us? Okay, I can't hear you. We will get back to you at the end of the session. So now I would like present the other participant. It's a PhD student, Miss Julia Płatkiewicz from Poznań University of Technology in Poland, who will also give a presentation in form of a video. Miss Julia Płatkiewicz, are you here with us?
Yes, hello, I'm present.
Perfect. We can share the video of Miss Julia Płatkiewicz now. We can start it now.
Good morning. My name is Julia Płatkiewicz and I'm a PhD student at Poznań University of Technology, the Faculty of Chemical Technology. The topic of my presentation today is the application of advanced oxidation processes for azole degradation as a potential alternative or supplementary wastewater treatment. In today's presentation, I'm going to cover 4 main points: theoretical introduction into the topic of azole's degradation, the methodology of my research, as well as results. Then I will shortly summarize the main conclusions. Due to growing problem of environmental pollution and the adverse effects of toxic compounds on living organisms, the study of pollutant identification and removal has gained increasing significance. Among these, our focus is placed on antifungal agents, especially azoles. Azoles are a group of 5-membered heterocycline compounds that contain at least 1 nitrogen atom in their ring. Although they display a broad range of biological activities, they are primarily recognized for their antifungal properties. Their mechanism of action involves blocking the synthesis of ergosterol, a key component required for maintaining the integrity of fungal cell membranes. These compounds are extensively applied as active substances in both human and veterinary medicines, in agricultural fungicides, as well as various personal care items, including topical creams, shampoos, soaps, and toothpaste. Based on their chemical structure, azole compounds can be classified into imidazoles, triazoles, and benzimidazoles. Imidazole derivatives such as climbazole, clotrimazole, ketoconazole are typically characterized by relatively high lipophilicity and are primarily used in human and veterinary medicine. Triazoles, including compounds like fluconazole, tebuconazole, and flutriafol, are widely applied as agricultural fungicides, except for fluconazole, which is used in the medicine. Another important group is benzimidazoles, such as thiabendazole, and they are also used in both medical and agricultural applications. After use, these substances are flushed into environment and wastewater treatment plants. On the slide, you can see the results of my previous studies when we conducted a long-term monitoring study of surface waters near Poznań to investigate the environmental occurrence of azole antifungals. Over a period of 3 years, we seasonally collected water samples from rivers, lakes, and field drainage ditches. Moreover, in order to confirm the pathways of entering the azole antifungals into the environment, we also analyzed the treated wastewater from 6 different wastewater treatment plants. The analysis revealed that azole compounds are commonly present in both treated wastewater and surface waters. The buconazole reached the concentrations as high as 1,783 nanograms per liter, especially in agricultural ditches, reflecting its widespread use as a fungicide. Fluconazole was consistently found at the highest concentration in wastewater effluents, exceeding 700 nanograms per liter, while several other azoles are also reaching 100 nanograms per liter. These findings indicate that conventional wastewater treatment processes are not fully effective in removing these substances. In order to confirm that thesis, we also conducted the biodegradation tests of azoles with the use of activated sludge from 2 wastewater treatment plants as inoculum. The results show that complete degradation was achieved for ketoconazole and clenbuterol with activated sludge from the central wastewater treatment plant. Slightly lower results were obtained for sludge from Borubiec wastewater treatment plant, but they still exceeded 90%. In case of thiabendazole and imazalil, the degradation efficiency reached 50 and 30% respectively, with slightly higher results with activated sludge from the central wastewater treatment plant. The compound with significantly the lowest degradation results was fluconazole, reaching 13 and 10% of removal. It confirms that conventional biological wastewater treatment is not sufficient for removing micropollutants such as pharmaceuticals or pesticides, which often occur at low concentrations. These systems are primarily designed to eliminate organic matter, nitrogen, and phosphorus. So as a result, more advanced treatment methods, such as advanced oxidation processes, are necessary to ensure effective degradation of contaminants of emerging concern. Advanced oxidation processes are a group of chemical treatment technologies designed to degrade persistent organic pollutants by generating highly reactive radicals, such as hydroxyl or sulfate radicals. These processes can be categorized based on the type of activation method used, either UV-based, like photolysis or photocatalysis, or involving strong oxidants, such as ozone, Fenton's reagent, and persulfate ions. The Fenton reaction is one of the most widely studied advanced oxidation processes used for the degradation of organic pollutants. It is based on the catalytic decomposition of hydrogen peroxide in the presence of ferrous ions, leading to the formation of hydroxyl radicals, which are highly reactive and non-selective species capable of breaking down a wide range of contaminants. The hydroxyl radicals attack the organic molecules, initiating a chain of oxidative reactions that lead to their decomposition into less harmful or fully mineralized products, such as CO2 and water. On the other hand, persulfate ions are activated thermally or by UV light in order to generate sulfate radicals, which are highly reactive species similar in strength to hydroxyl radicals. These radicals react with organic pollutants, leading to full mineralization of the contaminants. In some systems, sulfate radicals can also interact with water to form hydroxyl radicals, enhancing the oxidative efficiency of the process. The scope of the research included the degradation with the use of UV radiation and strong oxidants, such as persulfate ions and Fenton's reagent. The UV lamp with a power of 150 watts was fully submerged in the solution during the process to ensure the efficient energy transfer. The tests were carried out in batch reactor with initial concentration of 10 milligrams per liter for fluconazole and imazalil and 2 milligrams per liter for thiabendazole due to its poor solubility. The samples were taken at certain time intervals and the whole experiment lasted 60 minutes. The analysis was conducted with the use of high-performance liquid chromatography coupled with tandem mass spectrometry. On this slide, you can see the results of photodegradation experiments using only UV lamp. The graph shows the degradation efficiency over time for fluconazole, thiabendazole, and imazalil. As you can see, thiabendazole and imazalil were removed very efficiently, reaching almost 100% degradation within the first 15 minutes of exposure. In contrast, fluconazole showed significantly lower removal by photodegradation, with about 80% removed after 60 minutes. Here, there are presented the results of photophantom degradation. Before the experiment, we determined the optimal concentrations of hydrogen peroxide and iron ions, which are presented in the table. In the upper graph, you can see that the photophantom process was highly effective, especially for thiabendazole and imazalil, which reached the complete degradation very quickly, similarly to the photodegradation results, but with slightly better performance for fluconazole, which reached about 85% of degradation. In contrast, the bottom graph shows the degradation under the classical phantom process without UV irradiation, and the removal efficiencies were significantly lower for all compounds, not exceeding 15%. This highlights the importance of UV activation in enhancing the phantom reaction, especially when dealing with persistent micropollutants. The next tested process was photodegradation with the addition of persulfate ions. In the upper graph, we compared the different persulfate concentrations and the experiment without persulfate ions. As expected, the degradation efficiency increased with the increasing amount of persulfate. Above 5 millimoles, the reaction reached nearly complete degradation within the first few minutes. The lower graph shows the effect of pH on this process. The most efficient degradation occurred at neutral pH, while both more acidic and more alkaline conditions led to a slightly slower reaction. Still, the overall efficiency remained quite high across all tested pH values. In case of thiabendazole, photodegradation with persulfate ions occurs almost rapidly with slight differences between applied concentrations. However, there is visible improvement comparing to experiment with only UV radiation. The second graph indicates that pH does not influence the effectiveness of the process. These results suggest that even low doses of persulfate ions are sufficient for effective degradation of this compound. The results obtained for imazalil are nearly identical to those observed for thiabendazole. Degradation occurs almost immediately, even at the lowest persulfate concentration tested. Additionally, changes in pH do not significantly affect the efficiency of the process, indicating that imazalil is highly susceptible to oxidation under these conditions, and the system is robust across a wide pH range. This slide shows the degradation using persulfate ions alone, without any UV radiation. As you can see in the graph, the efficiency of degradation is very low for all three compounds, even after 60 minutes with optimal concentration of persulfate ions. This clearly contrasts with the results I presented earlier, where the combination of persulfate and UV light led to almost immediate and complete degradation. So this slide highlights the importance of activation. Without UV light, persulfate ions alone are not effective in degrading these azoles. In the final part of the study, we focused on testing photodegradation processes in a real matrix, that is wastewater treatment plant effluent. We compared two approaches, UV radiation alone and UV radiation combined with the optimal concentration of persulfate ions, that is 1 millimole for thiabendazole and imazalil, and 10 millimoles for fluconazole. Looking at the first graph, which shows degradation with UV only, we can see moderate efficiency. The best results were observed for imazalil, reaching nearly complete degradation within 10 minutes. Thiabendazole also degraded quite well, while fluconazole showed the slowest degradation rate, reaching 70% of removal after 60 minutes. However, the second graph, showing the combination of UV light and persulfate ions, clearly demonstrates much higher effectiveness. All three compounds reached near complete degradation, with imazalil and thiabendazole being removed almost instantly, and fluconazole following shortly after, up to 89% of removal. As an interesting side note, we also observed a visible change in the effluent's appearance, as shown in the photo, indicating that other substances present in the wastewater were also degraded during the UV persulfate treatment. This highlights the potential of this method not only for azole removal, but also for general improvement of effluent quality. To summarize, the conducted studies proved that fluconazole shows the highest resistance to all tested degradation processes, particularly photodegradation and classical phantom, indicating the need for more aggressive conditions for its removal. Thiabendazole and imazalil were effectively degraded in almost all advanced oxidation processes, especially under UV radiation, reaching near complete degradation within minutes. Photodegradation efficiency significantly increases when combined with strong oxidants such as persulfate or phenton reagents, confirming the crucial role of radical generation in achieving high removal rates. The experiments in real wastewater effluent confirmed the effectiveness of UV persulfate systems with nearly complete removal for all tested azoles and visible improvement of effluent clarity, demonstrating the method's practical potential. Thank you for your attention, and if you have any questions, I will be happy to answer them.
Thank you very much for your presentation. At first, I saw the question on the chat from Kamil Klinkowski. Which conditions of azole degradation are the most challenging to optimize or implement in wastewater treatment plants?
Thank you for that question. I think that it is the concentration of using oxidizing agents because it is important to introduce it to the wastewater and keep at the same concentration during the whole process, because the using of the UV radiation, it is quite more common these days, and it is much more easier to implement.
Okay, thank you. We have another question from Lucia Ptak.
Yes, hello. Can you tell me, can you reuse the treated water after azole removal, for example, in agriculture or some other application?
Yes, it can be used. Generally, it is released into the environment, into rivers mainly. So this step which I am talking about, it is the additional treatment, because we, in the last step of our experiments, we used the wastewater which is already enter into the environment. So when we add this additional treatment, it is even better.
Okay, I see. Thank you.
And we have another question on the chat. Were any transformation products of the azoles identified during degradation? And if so, do they pose any environmental or toxicological concerns?
This is the next step of our research. So we are planning to do this because it is very important to see if the degradation products are not more dangerous for the environment. So yes, I hope that maybe I will present it next year.
Perfect. Thank you very much. And thank you for your presentation. The floor now goes to the bachelor student, Miss Izabela Zarzycka from Adam Mickiewicz University in Poznań in Poland, who will give a presentation in form of a video. Ms. Zarzycka, please confirm your attendance. Ms. Zarzycka, are you here with us? Okay, perfect. Thank you for the confirmation. Now we can share the video.
Ladies and gentlemen, today I would like to talk about phytoremediation, a natural method of environmental cleanup. During the presentation, I will explain what phytoremediation is, what its main methods are, give example of plant use in this process, and discuss the advantages and limitations of this technology. Environmental pollution is one of the most pressing challenges facing the modern world. Of particular concern are heavy metals, which pose a serious threat to ecosystem and human health. This group most commonly includes elements such as nickel, copper, zinc, lead, cadmium, cobalt, iron, and mercury. Those metals tend to donate electrons, forming cation, and are readily absorbed by plants, which facilitates their accumulation in food chains. Unlike organic toxins, heavy metals are not biodegradable, making their presence in the environmental persistent and long-lasting. The primary source of heavy metal pollution are closely linked in the process of industrialization and urbanization, particularly activities such as mining, industrial production, transportation, and intensive agriculture. In response to these threats, it's essential to develop effective and environmentally friendly remediation strategies. One promising approach is phytoremediation, a modern green technology that utilizes the natural ability of certain plant species to accumulate chemical pollutants or transfer them into less harmful forms. This method offers new possibilities for restoring contaminated areas and represents an important step toward more sustainable environmental management. Phytoremediation techniques vary depending on the type of contaminated medium and the pollutants involved. These techniques include phytoextraction, rhizofiltration, phytostabilization, and phytovolatilization. One of the most commonly used and at the same time most effective phytoremediation method is phytoextraction. It involves the uptake of heavy metals from the soil by the root system of plants, and then they transport to the above-ground parts where they are sorted. After the plant complete growth cycle, it is harvested and then appropriately disposed of, composted, or processed. For this method to be effective, it is essential to select suitable plant species. Above all, these plants should possess a strong ability to accumulate metals. Rhizofiltration is a method aimed at purifying the water and soil-water interface zones. Its mechanism is based on the sorption of contaminants by the root system of selected plant species, followed by either the precipitation of this substance on the root surface or their accumulation in the above-ground parts. Additionally, the roots can slightly acidify the surrounding environment, which increases the bioavailability of heavy metals and thus enhances the effectiveness of this process. Rhizofiltration is primarily used in areas where the concentration of heavy metal are relatively low. Phytostabilization is a technique that differs from other forms of phytoremediation. Unlike methods that rely on the accumulation of pollutants in plant biomass, phytostabilization focuses on transforming contaminants into less toxic forms and reducing their mobility in the root zone. Plants used in this method primarily absorb contaminants within their roots, absorb them on root surfaces, and may also influence the precipitation of metals in the rhizosphere. This occurs due to the secretion of specific organic compounds by the roots. This substance stimulates metal uptake and contribute their precipitation in unsoilable salts, significantly lowering their bioavailability. Importantly, plants used in phytostabilization are not removed after the process, since disturbing the biomass could lead to remobilization of heavy metal into the environment. Phytovolatilization is a phytoremediation technique based on the ability of plants to uptake contaminants from the substrate, transport them, and then release in a volatile form through the transpiration. This process primarily concerns elements such as arsenic, selenium, and mercury, which after modification are emitted into the atmosphere. While the mechanism behind phytovolatilization are not fully understood, there are known cases its successful application. Let's consider this process using mercury compounds as example. For the oxidation of harmful mercury cations, specially engineered transgenic plants are used. These plants contain bacterial genes encoding enzymes such as mercury reductase and organomolecular liase. The ion is reduced to elemental mercury, a less toxic form, which is then volatilized and released into the atmosphere. In choosing suitable plant species for phytoremediation, it is essential to take into account the nature of contamination and also the strategy for utilizing resulting biomass. The selected plant should possess high capacity for heavy metal accumulation in above-ground parts, fast biomass grown, long plantation lifespan, resistant to unfavorable environmental conditions, easy adaptation to various soil types, the ability to extract multiple metals together. A specific group is formed by so-called hyperaccumulators, plants capable of accumulating 100 to 1000 times more heavy metals than typical species. This ability is due to a more developed root system and the ability to acidify the rhizosphere, which increases the mobility and bioavailability of metals. Hyperaccumulators typically show strong accumulation capacity with respect to a specific metal or a limited group of elements. In the case of phytostabilization, the requirements for plants differ significantly. Preferred species are those that exhibit low translocation factor for metals from roots to shoots, well-developed root systems, high production of root biomass. Unlike other phytoremediation methods, the aim of phytostabilization is not to remove contaminants but to immobilize them in the soil. Therefore, the root system plays a crucial role by limiting the migration of metals and reducing their bioavailability. Advantages: naturalness and environmental friendliness. Techniques use plants and benefits the environment. Roots boost soil microorganisms, enhancing fertility and preventing erosion and contaminant spread. Low financial expenditure. Phytoremediation is much cheaper than physicochemical methods, requiring neither expensive equipment nor specialized expertise. In situ work, this technique takes place directly at the site of contamination, eliminating additional environmental damage caused by transport. Social acceptance. Vegetating the area not only cleans the soil but also improves the aesthetic of the site. Limitations. Long duration of the process. The entire process can take several to many years depending on the degree of soil contamination and the type of plant species used. Plant damage. High concentration of metals in plant tissues can lead to plant damage or wilting. Limited to shallow soil layers, the depth of penetration is limited by the root system reach, influence of soil and environmental conditions. The speed of efficiency of heavy metal removal depend on the soil type, pH, and the length of growing season. Phytoremediation is no longer just a concept for the future, it's a technology that has already found practical application in various parts of the world. A notable example is the work carried out in Sudbury, Canada, where years of smelting and mining operation led to significant soil contamination with nickel and copper. Through the use of carefully selected plant species, the presence of heavy metal was successfully reduced. Another example is Bhopal, India, the site of one of the world's industrial disasters. As a part of a long-term reclamation effort for the contaminated area, several remediation methods were tested, including phytoremediation, recognized as a solution with great potential. A notable example of international collaboration is BAPR project Baltic Phytoremediation, carried out under the INTREG program by Poland, Lithuania, and Sweden. Its aim was to assess selected plants' ability to remove contamination from soil and sediments. The partnership between scientists and local authorities enhanced phytoremediation research and results in practical solutions for degraded areas in the Baltic Sea region. Phytoremediation is a forward-looking technology that, when properly planned, not only delivers significant benefits, but also minimizes the additional risk typically associated with traditional remediation methods, all without disrupting the natural balance of the environment. Investment in the development of this technology represents a promising alternative that could be key to sustainable development of contaminated areas.
Thank you for your presentation. Do we have any questions? Okay, question in the chat. A question from Kamil Klimkowski. What factors influence the choice of an appropriate type of
Thank you for your attention.
remediation? Okay.
I think the sorry, I'm a little bit nervous. It's type of the
Ms. Zarzycka, all the questions are in the chat. Maybe you would prefer to write the answers.
yes, I would prefer.
Okay, that's okay. So now we can go to another presenter. And I'm honored to welcome PhD student Mr. Michał Dominów from Gdańsk University of Technology in Poland. Mr. Dominów, please confirm your attendance.
Yes, I'm here. Do you hear me?
Yes, we hear you. Thank you very much.
Wonderful. Okay, so I will show my screen, I hope.
Perfect.
Okay, it should be that. You should probably now see the presentation.
Yes,
Is that working? Wonderful. Okay, so it's good to speak to you. Welcome to my presentation. It's a very nice day for talking, and my name is Michał Dominów. I work at Gdańsk University of Technology. I'm doing my PhD there, and my main topic I will show you today is the dry reforming of methane and catalyst development that I'm currently working on with my team and colleagues. So to summarize shortly, I will show you my motivation for that study. I will show you a short introduction, show you a bit of my methodology, then present the results already done and analyzed and under the analysis right now. And then I will conclude this all and show important information like acknowledgements and funding. So just to start, why bother with the process and what is it? Why bother? Because the most promising, the most widely applied technology for hydrogen production right now is reforming of methane. Methane coming from biomass sources, from biomethane, and also from not so environmentally friendly fossil fuels. But to develop new technologies that will be effectively in converting methane to hydrogen, which is much more useful in terms of chemical studies, either hydrogen, pure hydrogen, or syngas, so mixture of hydrogen and carbon monoxide, we have to develop new technologies. And one of these technologies is wet reforming, already widely even industrially applied, which is concerned about mixing methane with water vapor. And the other technology that is actually on the rise is dry reforming, so combining methane and carbon dioxide to obtain, as in that reaction scheme, carbon monoxide and hydrogen. What's the benefit? The benefit is that we are using two greenhouse gases, one very potent on greenhouse effect, the methane, other very, very widely produced in multiple industrial processes. We combine them and we acquire syngas, the basic building block of the whole chemical industry. This is wonderful, but to obtain that, we need really harsh conditions. The dry reforming is really, really hard to achieve because the reaction usually starts around 1000 degrees Celsius, and it usually needs high pressures and really good catalysts for that. So how to catalyze it? We have few problems and pathways to do that. One of the problems is that additional reactions occur. Multiple reactions are occurring between methane and other, even products of the reactions that are occurring by the side of dry reforming. So it's hard to distinguish what comes from what, and I will talk a little bit in my case of my study. The other thing is conventional catalysts are really prone to carbonization. So carbon covers the active particles, and in that case, the effectivity of the catalyst is decreasing rapidly. The solution for that, one of the solutions, is what I'm working on, X-solution catalysts. So the catalyst with the structure of the perovskite, for example, but another perovskite clandespinol, when the metal is not sputtered on the surface, it's not put in the surface like from the outside, it's emerging from the surface by the process of X-solution. It leads to the formation of really small nanoparticles that are really coking resistant. They are one of the most coking resistant substances that we know. They are really active and they are already embedded in the material. This is really important for the reaction mechanism to occur, that the active metal particles are embedded in the oxygen sink, I would say, so the perovskite structure that is reduced in the hydrogen. What is hard in that case? It is hard to develop a catalyst that promotes reaction in the correct way, accelerates the desorption of the methane on the metal particle surface, while simultaneously providing a way to remove oxygen from CO2 to achieve conversion to CO or other substances. So to combine it all, I propose a material that was already developed and thought of in the fuel cell field with the stoichiometry as shown. I synthesized this material in 3 different variations with different doping levels. In that case, 0.01, 0.02, and 0.05. So up to 5% of platinum, really small platinum amount. I used wet synthesis for that. I centered that in air, and then the material was reduced in hydrogen atmosphere to obtain the composite with the nanoparticles on the surface. So the X-solution process I talked about. So after that, we employed few structure and morphology characterization before the catalytic tests, and I will show you what happened and how it worked. The structure tests, as shown from the X-ray diffractions, were really good. The material was synthesized in almost pure form. Minor impurities were occurring, but the synthesis method was working. It was acceptable for us. The problem was that when reduced, not all of the materials behaved in the same way. The 0.01 and 0.02 are showing really great behavior. You can see by the SEM image on the right, the A1, the small dots that are visible on this SEM image are the nanoparticles. So these really small dots are our desired outcome. The big grains are the material. So these are the nanoparticles embedded in the material structure. Very good. This is okay. But the B1 for 0.05 shows really big flashy particles that are around the size of half of the micrometer. These are clumps, I would say, or clusters of platinum that formed during the reduction that are not wanted in our case. Because the bigger the clump, the lesser the activity and the lesser the coking resistance. So during the increasing of the platinum amount in the substance, we are actually accelerating the clustering of the platinum structures. So we are mostly concerned with 0.01 and 0.02 material because they are the most nanoscale, I would say, from that. And catalytic experiments confirm that this is a good idea. Short thing about setup of the catalytic experiment. We were putting an equimolar mixture of CO2 and CH4. by the U-shaped reactor with the fixed bed, we're flushing the gases through the reactor, so dynamic mode, I would say. We are measuring the temperature, and we used gas chromatography with thermal conductivity detector to see what comes out of the system. This was our main concern. What is the composition of the output gas mixture? We use the dryers to not kill our column, because carboxyl columns are really prone to hydration. So we have to protect that from water. And what happened is that the conversion rates wasn't really wonderful, but the dry reforming started to arise in temperature about 800 degrees Celsius. This is not the best result we hope for, but similar materials with other metals, for example, ruthenium, are also very active. So we thought about employing this knowledge that we have from platinum experiments to some other materials. And in that case, maybe the comparison will be most useful for you. This is the comparison of different doping levels. So we compared the pure structure, 0.0, no platinum, and the pure structure is almost inactive. It's like 0% conversion on the whole temperature region we investigated. So 500 degrees Celsius to 850. But in case of 0.01, we see the activity around 10% of the conversion of given methane. So we have 10% of the methane that's coming into the system is converted to hydrogen. 0.05 and 0.02 are really similar, because in 0.05 the clustering, the clump of platinum take precedence, and they are too big to achieve desired catalytic activity. So in that case, it's better to use 0.02, not 0.05, because it prevents the clustering, at least on the normal level. What's interesting, we also test the degradation rate of the catalyst after 72 hours of prolonged exposure. And in case of carbon monoxide, the degradation was almost unseen. So like all the process that is leading to produce carbon monoxide is highly resistant to long-term operation. And from that, I can say that there are possible additional reactions occurring that are happening in this system are, the arrows are missing, whatever, are the autothermal reforming of methane. That is probably a little less common, but it's also happening. The reverse water gas shift that can happen if the water vapor forms in the system. And most promising, reverse Boudouard reactions. So removing the carbon, for example, from autothermal methane reforming and producing additional CO. I believe this is the case for the lack of degradation in case of carbon monoxide. The carbon is actively removed from the system, and that's really interesting. I wondered what can be also done with these catalysts. So I made synchrotron experiments at Solaris in Krakow. They are currently under analysis, but I can show you a few tidbits about that. The comparison between pristine samples and reduction samples showed that there is a coexistence of metallic and oxidized platinum in the system. So the particles are not only pure metallic platinum, but also platinum oxide and platinum dioxide, which can lead to some interesting mechanism, because after the post-catalytic samples were measured by XPS, I also seen that the oxide phase is started to degrade or missing. So the reaction pathways sometimes utilize the platinum oxide, sometimes utilize pure platinum. It's interesting to show that. Also, activity of both species of platinum oxide is, I would say, for that part of the study, it's not big, but it's acceptable. And the process is reversible. So the degraded catalysts can be regenerated by bathing in pure hydrogen at high temperature, and they're used again. These are two main things that make this catalyst interesting, I would say. I also investigated as an additional method the XIS, so X-ray absorption spectroscopy technique, but I can only do that on platinum on the beamline that I had at the beam time. So it can only be done on titanium, not platinum. I would like to do that on platinum, but it's not the correct beamline to do that. In case of titanium, there are almost no differences. So I will fairly say that adding platinum does not distort the structure very much. At least it's not distorting the chemical state of titanium. To conclude, X solution behavior, so nanoparticles, active nanoparticles in really great abundance, is observed for 0.01 and 0.02. 0.05 microstructures are forming, not good for reforming. There is not really difference between 0.02 and 0.05 because of that microstructure forming. They are much more less active. They promote some additional reactions. This is important because even if this catalyst is not really active in case of reforming, we can use the platinum doping in different catalysts to achieve the same thing. So, for example, promoting the reverse Woodward reaction and I would say auto-cleaning the nanoparticles from the carbon poisoning, which is really big thing in case of both wet and dry reforming. Titanium is unaffected by doping, as I would say. Platinum oxidation sites and regenerative possibility still under investigation, but I will say that the process is really interesting and we have few different parts of it, so it's really interesting for us. As the future plan, this catalyst is not good enough to make some kind of a patent recognition or something like that, but I'm reusing these solutions from that catalyst in other substances, for example, multi-bimetallic phases in the same structures that can catalyze further the reaction and also have these positive elements of this catalyst, so promoting the reverse Woodward reaction and coating resistance. And this is my bibliography. The work was funded by the Euromidu program, so thank you for that. And I would actually say thank you for your attendance, and I would like to hear your questions for you. Thank you.
Thank you very much for your presentation, and I could see already in the chat question in the chat.
Oh my God! Yeah, okay. I will go from the top because it's really okay. Here are the answers. Okay, here. Okay, very nice results. Reproducibility of the synthesis, it was great. I actually didn't have to reproduce this synthesis, but I experimented with different metals on different ways. And usually when I would say, meticulously preparing the synthesis, there is a really low margin of mistake. The most common mistake or the most common caveat is that sometimes not all of the metal comes into the structure, but if the XRD is correct, then I can be sure that no other phases are occurring, so the whole metal goes into the structure. Below, I haven't experimented with that. Probably yes, but in case of platinum, it may be too less for having a good amount of active nanoparticles. So 0.01 was a little bit less active than 0.02. Probably with ruthenium, for example, I could get below 0.01, but it would be hard to, in that case, the mistakes in calculating, for example, will have a big influence. Do you think photoactivation can work here? I actually give that samples to one of my colleagues on University of Gdańsk to test some photo experiments, but these materials weren't active enough in that case. It probably needs a little bit tweaking in the band gap to do this for that. But I would like to also work on that, but maybe in the future. Okay. The material is stable. Like when it's put into the reforming experiment, it degrades a little bit. The oxide phase is not stable. The nanoparticles are stable. So checking from SEM or checking from the XPS spectra after the catalytic process, I can fairly say that the coupling occurring, the oxide phase is reducing and oxidized back, but the whole material as a matrix and the nanoparticles is stable. Decreasing catalytic successive cycles. Haven't done it yet, but I'm wanting, or I also want to do that. Probably I would check if few regeneration cycles have some kind of impact on the process. Probably yes. Other applications for dry reforming, depending on what you mean. The dry reforming itself produces hydrogen and CO. So depending on what are you going to use that, because this can be a fuel for solid oxide fuel cell. This can be a fuel for Fischer-Tropsch synthesis. This can be a fuel for methanol synthesis. Multiple pathways, depending on what you want different composition of hydrogen and CO. And for example, dry reforming can be also used as a, I would say, parasitic or additional process on wet reforming to tweak the ratio in the syngas between hydrogen and CO. So it kind of answers a question because it can be used as additional reformer or changer in the structure of the output gas. I hope that this is the answer for your question, Kamil.
Thank you very much for all the answers and your presentation. And at the end, I want to get back to Ms. Wiktoria Piątek-Gołda. Are you here with us? Again, Ms. Wiktoria Piątek-Gołda, are you here with us? Okay, I can see Ms. Wiktoria. So I just want to thank you once again for all your amazing presentations, discussion, and your attendance here. Now we have a technical break scheduled, and at the 1:45 p.m. UK time, the poster session will begin. I strongly encourage you to participate actively in the remaining session. Thank you again, and see you at the last session.
See you.
Thank you.
Okay, once again, but the last time, hello everyone and good afternoon. Do you see me and do you hear me?
Yes.
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 Yes, thank you for the answer. So all good things have to end, as well as our conference is coming to the end. I hope that all of you are satisfied from the participation in NSBC, which is international, online, and completely free conference where young scientists can share your research results with each other. And at the end, I want to thank all the organizers, which are Student Science Club for Chemistry of University of Gdańsk, Doctoral Student Council of University of Gdańsk, Chemistry Student Council of University of Gdańsk, and Center for Student and Doctoral Activities of University of Gdańsk. And I would like to also thank our patrons, which are Fahrenheit University, Director of University of Gdańsk, the Dean of the University of Gdańsk Chemistry Department, the Marshal of the Pomeranian Voivodeship, the Pomeranian Voivodes, the Polish Academy of Science in Gdańsk, the Students' Parliament of the Republic of Poland, the Polish Chamber of Chemical Industry, Polska Chemia, the Association Iskry Nauki, the website eDoktorant, and the website Dla Studenta.pl. I would like to also many thanks to the members of our scientific committee who ensured the high level of our conference. We had 24 members from 11 different science centers, which are Professor Anna Axman from University of Gdańsk, Professor Henry Pinto I'm terribly sorry for the last. It's have to happen something like that. I am again online. Back to the point. Henryk Pinto from Jadza Tech University, Professor Agnieszka Chylewska from University of Gdańsk, Professor Marta Kolanowska from University of Łódź, Professor Katarzyna Wiktorska from Warsaw University of Life Science, Professor Ilya Serdiuk from University of Gdańsk, Professor Iwona Jędrzejczak from Bydgoszcz University of Science and Technology, Professor Dawid Zych from University of Opole, Dr Katarzyna Węgrzyn from University of Gdańsk, Dr Judith Mary Harik-Krasz from University of Copenhagen, Dr João Manuel Ferreira Gomes from University of Coimbra, Dr Agata Kućko from Warsaw University of Life Science, Dr Paweł Mazierski from University of Gdańsk, Dr Monika Małecka from University of Gdańsk, Dr Małgorzata Gutkowska-Stronkowska from Warsaw University of Life Science, Dr Małgorzata Kapusta from University of Gdańsk, Dr Dawid Wnuk from Jagiellonian University, Dr Magdalena Miodyńska-Melzer from University of Gdańsk, Dr Maria Madej from Jagiellonian University, Dr Bartosz Szymczak from Nicolaus Copernicus University in Toruń, Dr Maria Kochaniec from Warsaw University of Technology, Dr Daria Harskowa from University of Gdańsk, Dr Artur Piruk from University of Gdańsk, and Dr Monika Rewers from Bydgoszcz University of Science and Technology. And many thanks for our special guest, Dr Paweł Mazierski from University of Gdańsk and Dr Agnes Klar from University of Zurich for very interesting lecture yesterday and today. And I would like also thanks all of members of organizing committee of NSBC. I want to tell all these names, but for all of you, many thanks. Without you, it could be impossible to make such great conference. Once again, many thanks. And of course, many thanks for our participant. In today's, we could heard 57 oral communication, 58 poster communication from participants from 39 scientific center in 13 countries. And also we had 78 audience participant. About technical details, we will send the certificates for participation in the conference and diplomas for awarded speakers within 2 days. And we are also encourage you to participate in other conferences, which is organized by us, which means conference chemistry, business and środowisko and environment, in shortcut CHEMBIS, and the 5th Congress of Young Science organizing in Gdańsk, which is international conference. And once again, thank you for those wonderful 2 days of our conference. Oh, I'm sorry, I forgot. Just one thing, we want to have a common photography, so please turn on your cameras, show us yourself, and we want to make some screen. Okay, I get the information that we also had the screens. So once again, thank you for the participation. And this is all for now.
Thank you very much and goodbye.
Thank you. See you maybe on other conferences.
Thank you.
Thank you very much.
Thank you.
everyone.
Bye-bye.
Yeah.
Thank you. Bye.
Bye. Here.